Hey guys, what's up? What's up? Can I get some fire in the chat box? Can I get some fire in the chat box? If you are able to hear me properly, you're able to see me as well. Okay, see my hand. Okay. Good evening, everybody. Yeah, you will be able to see me in just a few seconds. I'm just getting ready with your chats and with all your messages. Yeah, just a second. Just check, let me check from my end as well if everything is working properly or not. And please start liking the session and also sharing this with your friends that we are going to start with ray optics. Okay. With your chats and with. Okay, I think the voice is audible. Okay. Yes. Hello, everybody. Hello, everybody. Hello, Alden. Hello, Sai Sri, Pallavi, Geeta, Jenna, Aswari. Okay, good evening, everybody. Good evening, everybody. Yes, start liking the session, and here I come. Hey guys, what's up? How are you all doing? My name is Jonathan. You can all call me lovingly, and you call me lovingly as John sir, hai na? That's what you call me. And today is one of the most awaited chapters of your game of NEET 3.0. One of your most important chapters as well, one of your most awaited, one of the most longest chapters in your syllabus, including your 11th and 12th syllabus, that is ray optics. And Vagisha also, yes, Vagisha, yes, good evening. One of your most important and one of the most longest chapters in your syllabus, hai na? And very important. Yeah, it's going to be a long session. That's for sure. Let us say that I'm gonna take some 7-8 hours. Okay, 7-8 hours, 9 hours. Okay, it depends upon your response as well, hai na? It depends upon your response as well, how are you responding to all the questions, how are you all responding to everything, hai na? So that is exactly that we're going to do, hai na? Okay, from which all parts of the country are you watching this? From which all parts of the country are you watching this? Okay. And one more thing, people. One more thing before we start. I want everybody should have a notebook, hai na? And obviously pen. Yeah, that is your requirement, because ray optics is a kind of chapter which requires your practice, which requires your drawing. Okay, it requires your writing part. Okay. Yes, it requires for your writing part. Okay, people. So I want your attention, your 100% attention to this board, and you have to write each and everything with your own hand. Okay, you have to draw each and everything with your own hand. Even if I take a 24-hour session over here, even if I take a 100-hour session over here, if you don't write it, you're not going to understand it. Okay, people. Yes, and one more thing. I can see that many people are attending from many parts of India. Okay, that's good. But people, one more thing. Many of y'all have this have this doubt, sir. I am zero in ray optics. I don't know anything about ray. I even do not know what is a ray. So can I watch this lecture? Yes, you can watch this lecture, because I'm going to start literally from negative. Okay, I'm going to not just start from zero. I'm going to start from negative, and I'm going to take you till J level. That's a promise. Okay, that is a promise. Okay, people. But you have to make sure that you have to basically attend the session. How much ever lengthy it is, you have to attend the session, because it's a very important session, people, hai na? And this is not going to be a boring session. Don't worry about it, because I have bought a lot of animation for you all, lot of animations, lot of simulations for you all. We are going to do everything. Okay, we are going to do everything, and you're going to enjoy this very much. Okay. Okay, okay. So that is what we're going to do. Okay, people. Now, where are you going to find the notes of it? It's very simple, people. It's very simple. You are going to find the notes. Acha, one more thing. This is NEET Alchemy channel, one more channel which is run by me as well. I'm doing an all NEET PYQ series here. So obviously I've completed ray optics over here. So after this chapter, if you want to practice more questions, if you want to practice more PYQs, obviously you can go over here and practice your ray optics as well, hai na? So that is the channel NEET Alchemy by Unacademy, and you can find out there. Now, where to find the notes? Obviously, you can find the notes in my Telegram channel. You can basically scan this QR code, है ना, or just type Jonathan Matthew Physics in Telegram. You will be able to find my channel, and there you will be able to find the notes. Okay, people. So that is the QR code for you. I hope you will scan it, and then you can access the notes from there. Okay, people. So let us start with ray optics. Are you all ready, people? Are you all ready to start with ray optics? Yes, just a second, people, just a second. Okay, just a second. Hello. Yeah. Chat, people, can you just confirm me once again that whether I am audible or not? Whether I'm audible or not, because I've just changed the microphone. Can you please just check and just tell me if I'm audible or not? Okay. I'll just check from my end as well. Okay. Confirm me once again that yeah, it is audible. Okay. So don't worry, we are gonna start with ray optics, a very important chapter when it comes to your NEET exams, a very interesting chapter as well. Okay, and yes, so let's start. So ellarum sugamano, vanakkam, let's start. Okay, chaliye. Okay, perfect. Okay, so let's start with ray optics. Okay, we're gonna start with the basics. Okay, people. Now, introduction. Okay, now we're going to start with the basics as well. Obviously, you have studied it in your lower class that light always travels in a straight line, hai na? So that is what it is written over here, that light travels along a straight line path in a certain medium or in a vacuum. The path of light changes only when the medium changes, and we call this rectilinear or straight line propagation of light. And a bundle of light rays is called as a beam of light. This is something which we know, and this is an experiment which you have already seen in your lower classes, hai na? So if this is a candle right over here, and you have 3 slits over here, and these three slits are kept parallelly to each other, which all of these holes coinciding with each other, still you can basically see the light over here, because obviously light is traveling in a straight line. But if you basically just just disturb the orientation over here, any of the 3 slits, you will not be able to see the light. So this is just basically an experiment by which you can prove that light travels in a straight line. Okay, that is something which we can understand. Now, what exactly is a ray of light? It is very easy to understand, people. So if this is one point, if this is one point, and if this is the other point, so basically light is traveling from this point to this point. So I just have to join this 2 dots over here. And this is basically called as a ray of light. Okay. Now when I have many different rays together, okay, when I have many different rays, there are many different rays over here, okay, obviously, which are parallel to each other. So what I get is a beam of light. So what is a beam of light? A beam of light is basically a collection of many light rays, hai na? It is a collection of many light rays. Okay. Chalo. Now let's understand more further. Okay, now we're going to understand about reflection of light. We're going to understand what is reflection of light. Now we all know what is reflection of light. Reflection is just basically the bouncing of light, the bouncing of light when it strikes a polished surface, or when it strikes a plane mirror. Obviously we're gonna understand this plane mirror. Okay, so don't worry, we're gonna understand this plane mirror. Okay, so what happens over here? This is very easy to understand. This is a plane mirror over here. Yes, this is a plane mirror over here. This is the incident ray. Yes, this is the incident ray. It strikes the mirror over here, and this is the reflected ray over here. Similarly, there are many rays of light which strike or which incident on the mirror, and the mirror being a polished surface, the incident ray gets reflected back as the reflected ray. Okay, now this is basically called as a regular reflection, because you have an even polished surface over here, hai na? You have a even polished surface over here. So what is regular reflection or specular reflection? When reflection takes place from a perfect plane surface, then rays remain parallel after reflection. So if you see over here, the rays were before incidence were parallel, and after reflection also they are parallel to each other. So obviously this is a case of regular reflection. Okay, very good. Okay, next, what is irregular reflection? Obviously the polished surface or the mirror that we are going to talk about is not even, it is not plain, it has irregularities in them, है ना? For example, a disturbed lake, okay, a disturbed water or a disturbed lake of water, है ना? So if the lake is disturbed, obviously it's not a plain surface anymore, and that is the reason you see it blur, है ना? You see it blur, that is the reason you see it blur. So obviously over here, even if the incident rays are parallel to each other, I cannot say that the reflected rays will be parallel to each other due to irregular reflection. Okay, this is very basic topic, people. We can move on with laws of reflection. Okay, we can move on with laws of reflection. Now, if you have understood till now, can I get some fire in the chat box, people? If you have understood till now, can I get some fire in the chats? Yes. Okay, cool. Chalo. Now let's understand what is laws of reflection. Again, something which I've already studied in your lower classes. So what is laws of reflection? Sir, it's very easy to understand, sir. What is laws of reflection? First, the incident ray and the reflected ray and the normal all lie in the same plane. That is something which I've already learned. Then the angle of incidence, or I can say the angle the incident ray makes with the normal is called as the angle of incidence, and the angle which the reflected ray makes with the normal is called as angle of reflection. And we know that this angle of incidence is equal to angle of reflection. Okay, very easy to understand. This is something which I have already learned in your previous classes, है ना? Now, very important, but don't worry, I will be giving you some new points today, and some new points today regarding laws of reflection. Okay, so what it is written that the incident ray, the reflected ray and the normal at the point of incidence all lie in the same plane. Now you can basically understand with this diagram over here. This is your mirror, this is your mirror, and perpendicular to this mirror I have a plane over here. If you are able to imagine this. So this is the incident ray, this is your reflected ray, and what is the normal? Normal is basically an imaginary line perpendicular to the mirror or perpendicular to the reflecting surface. Okay, yes. Don't worry, see, I've already told you, you all will be receiving the notes on my Telegram channel, on my Telegram channel. You all will be receiving the notes on the Telegram channel. So don't worry, even if you miss out on your notes, don't worry. I want your 100% attention to be on the screen, on the board itself, because it's a very important chapter. Don't worry even if you miss out some things when you're writing the notes, because you're already going to get these notes. So don't worry about that. But when I'm going to tell that you have to solve some equation, you have to solve some problem, that is the time you have to use your notebooks and basically solve that equation and solve that question. That is the time you have to use your notebook. Rest every time and rest all the time, your focus should be on your board. Okay, people? Don't worry about your notes, okay? Because you're gonna get it on my Telegram channel. Yeah, as I was saying, this is the mirror and the plane perpendicular to the mirror. This is the plane perpendicular to the mirror. So the incident ray, the reflected ray and the normal. What is the normal? A normal is an imaginary line perpendicular to the mirror. Yes or no? They all lie in the same plane. Very good. Okay, chalo, next. Then what was the next point? The next point was angle I is basically equal to angle R. This is called as angle of incidence. This is called as angle of reflection. Very good. We are able to understand this. Now, sir, is this law of reflection only valid for plane mirrors? No. It is valid for every mirror out there. Be it a convex mirror or be it a concave mirror or be it any mirror or be it any irregular reflection. This is always valid. That is the reason it's called a law. Obviously, this is useful for boats. That is the reason it's called a law, because it's valid everywhere. So even if you have a convex mirror over here, you can basically say the incident ray, the reflected ray and the normal, they all lie in the same plane and angle I is equal to angle R over here. In the same way, even if it's a convex mirror, I can basically say the incident ray, the reflected ray, the normal, they all lie in the same plane, and angle I is equal to angle R. That's it. Story is over. है ना? So I can definitely say that over here angle I is basically equal to angle R, and over here also angle I is equal to angle R. Clear? I hope so. This is absolutely crystal clear in your minds. Okay? Very, very important to understand. Very, very important to understand. Now, if you want just an animation, and I will just show you an animation over here. So this is your plane mirror, and this is your plane mirror over here. This is your plane mirror over here. Okay. The blue color, the blue lines represent your incident ray. है ना? The blue colors, the blue line there, it represents your incident ray, and the green color, it represents your reflected ray. Okay. I hope so it's visible. Yeah, it's visible. It's visible. Okay. Okay, see this. Now, if you all notice over here, I'll just write it so that there is no confusion over here. So blue color, है ना? So blue color, this blue color, it represents your incident ray. This is your incident ray over here. And the green color, है ना? The green color, this represents your reflected ray. And the orange color over here, I'm going to write it with red. Okay, the orange color over here, this represents your normal, है ना? This represents your normal. Okay, this represents your normal. Okay. Now, don't worry, I'll give you the websites. I'll put it down in the description after the class. Okay, don't worry, then you can play with it. Okay. Now, see, it's very simple to understand. Can I basically assume this board to be a plane? Yes, I can assume it to be a plane because it is a plane. Hai na? It is a plane. It is made up of two axes. This is the x-axis. This is the y-axis. Obviously, I can call it as a plane. I can definitely say, yes, sir, the incident ray, the reflected ray, the normal, they all lie in the same plane. Yes or no? Yes, sir, they all lie in the same plane. And I can also say, sir, this angle of reflection is I, this angle is angle of incidence, and this is angle of reflection. And over here, I can definitely say angle I is equal to angle R. Straight, simple. Okay, clear? Chaliye. Settled in medulla, very good, है ना? Very, very easy to understand. I don't think so that you have any problem whatsoever. Moving on. Okay, very, very important to understand, people. Now I'm gonna give you something which you don't know. Okay, it is very important. Mostly teachers, they don't teach you this, but I feel that you should know about it. है ना? Because obviously NEET 2025 physics paper was on a bit difficult level, so you need to increase your level as well. So I'm going to give you advanced content over here. This is something that you may that you may have not studied in your class. Okay, let's understand. Let's understand over here. Okay, people. So one more time I'm going to explain. Sir, this is your incident ray. Okay, this is your reflected ray, and this is your normal. Okay, and we already know that this is angle I and this is angle R. And we already know that angle I is basically equal to angle R. We already know about this. Okay. Now, people, this is normal and this is your plane mirror. We already know that this is 90 degree for you all. Yes, sir, this is 90 degree. This is also 90 degree. Yes, sir, this is also 90 degree. So can I write this alpha? As 90 minus I? Can I write this as 90 minus I? Yes, sir, you can write it as 90 minus I. Now this angle beta, can I write this beta as 90 minus R? 90 minus R. Yes, I can write it as 90 minus R. Now, do they have some special names? Yes, they do have. This is called as the glancing angle of incidence, and this is called as the glancing angle of reflection. Now, as we already know, angle I is equal to angle R. Can I basically say alpha is also equal to beta? Yes, sir. I can also say that alpha is also equal to beta. Very, very important result, people. Very, very important result. That angle alpha is also equal to angle beta. That means the glancing angle of incidence is also equal to the glancing angle of reflection. Cool. Very cool. 100% clear. Now we're going to study about Two things we're going to study. Okay. Now we are going to study about the deviation angle. So what is the deviation angle? Let us understand. Now people, if this mirror was not present, if this mirror was not present, let us assume that the mirror was not present. So the incident angle would travel something like this, and it will travel something like this. Yes or no? Just a second. Yeah, the incident ray would travel something like this. Yes, it would travel something like this if the mirror was not present. It would travel something like this. But due to the mirror being present, it got deflected by this angle. Yes or no? It got deflected by this angle. Can I basically say it got deflected by this angle? And this angle I'm going to call as del. If the mirror was not present, the incident ray would travel in a straight line without getting deflected. But due to the mirror being present over here, it got deflected by some angle, and this is del. And this is del over here. Now, how to calculate this angle? Very easy to calculate. Very, very easy to calculate. See this. Okay, very, very easy. Very, very easy. It's very, very easy. Okay. I'm going to basically extrapolate. I'm going to extrapolate this normal over here. I'm going to extrapolate this normal over here. And now this is very simple geometry. This is simple geometry. See this. If this is angle I, can I basically say, sir, this is also angle I? Yes or no? Yes, sir. I can basically say this is also angle I. Just a second, people. Just a second. Yeah, hello. Yeah, I think I'm back. Good evening. Okay. Yeah. So I want to calculate this del over here. So if this is angle I, can I basically say that this angle right over here is 90 minus I? Yes, sir. This is 90 minus I. Okay. And I also know that this angle right over here is 90 minus R. This is also 90 minus R. So can I basically say the del comes out to be 90 minus I plus 90 minus R. Yes, sir. So this comes out to be 180 minus I minus R. Now I already know that angle I is equal to angle R. So I can definitely say del is basically equal to 180 minus 2I. 180 minus 2I. Yes or no? 180 minus 2I. Very, very important. Very, very important. Okay. Yes or no? Very, very important. Very, very important. Okay, there is a reason ray optics is called as geometrical optics also, because if your geometry is strong, that means your ray optics is also strong. Very important to understand this, people. See, this is vertically opposite angle, so this also will be angle I. This is 90 degrees, so this becomes 90 minus I. This is already 90 minus R. So this deflection can be told as 90 minus I plus 90 minus R. And we already know angle I is equal to angle R. So this becomes 180 minus 2I. That is basically your net deflection of incident ray. And if you want, you can also give it a direction. If you want, you can give it a direction that is anti-clockwise. Okay. Clear? If you have understood this, some fire in the chats. Now, next point which I'm going to say. The next point which I'm going to say is a very important point. Is a very, very, very important point. Very, very important point. Very, very important point. Okay. Don't worry, it's already there in your notes. Okay, it's already there in your notes. Okay, it's already there in your notes. People, I'm gonna basically do some vectors over here. So vectors, yes, vectors over here. Can I basically say that this vector over here, this vector over here is I vector, that is incident vector. I can basically say this is incident vector. Very good. Now, can I basically say that this vector over here is R vector or the reflected vector? Okay, the reflected ray vector. You can basically say that. and this is the normal over here. Can I basically say that this is the normal vector? Normal vector, है ना? So this is I vector, this is R vector, and this is N vector for you. Okay. Now you need to know a little bit of cross product and dot product over here. Okay, you need to know a little bit of cross product and dot product over here. Now let's understand. Okay, now let's understand. See, I bought many things for you all to understand this, hai na? Just a second. See this. Okay, see this, people. Okay, I think I'm visible. Yes, I think I'm visible. Okay, if this is the incident ray, this is the reflected ray. Okay, this is the reflected ray. Incident ray, reflected ray. This is basically the normal, hai na? So just a second. Yeah, this is basically your normal, this white line. Okay, so see this. This is the incident ray, this is the reflected ray, this is the normal. Very good. Angle I is equal to angle R. Okay. Now, do we know what is I cross R? Sir, I cross R, I think right hand rule. है ना? I cross R. So I cross R, I cross R. So I get a vector which is perpendicular to this, or R cross I, R cross I, R cross I, perpendicular to this. So I get a vector which is perpendicular to I and R over here. So the vector would be something like this, this red pen towards you. Towards you. I cross R would be this, or R cross I would be this. Would be this. Are you all able to understand this? Are you all able to understand this? Yes or no? Yes or no? So this is I, this is R for you all. So I cross R would be this red line. Or yeah, I cross R would be this red line. Or R cross I would be just opposite to this. Yes or no? Clear? Clear? Are you all able to understand this? Okay, now see this. Now see this. Can I basically write that I vector cross R vector dot N vector is basically going to be 0? Sir, I did not understood this. I did not understood, sir. Don't worry. You are going to understand this. What is I cross R? Sir, I cross R is a vector which is perpendicular to the plane. Which is perpendicular to the plane. है ना? Which is basically perpendicular to the plane. Now, this vector, है ना? This vector is perpendicular to normal itself. So I cross R, let me say this I cross R gives me C vector. This C vector is basically perpendicular to normal, and if this C vector is perpendicular to the normal, and if you do C dot N, you'll get 0, because dot product C N cos theta is 90, it will become 0. Yes or no? Yes or no? Yes or no? Clear? Are you all able to understand this? How to find direction? Just use your right hand rule. So see, this is I, this is R, no? And I cross R. So this is I cross R. See this I R towards, just bend your palm towards your vector. So this is I and this is R for you also. This is the direction. Or R cross I, this is your direction. Did you understood this? Did you all understood this? Yes or no? Yes or no? Again, I'll explain. I cross R, that is I cross R inside the plane or outside the plane, R cross I. You can even write it as R cross I. You can even write it as R cross I. You can even write it as R cross I. Yes or no? Yes. Dot N vector is basically equal to 0. Yes, that is R cross I. It will give you a perpendicular vector. And this perpendicular vector is 90 degree with the normal. So dot normal is basically 0. Are yes or no? Now the fun fact is any combination of this will give you 0. Any combination of this will give you 0. That means you can even write N cross R dot I vector is basically 0. This is also true. This is also true. Or N cross I dot R vector is also 0. Any combination is 0. That is the beauty of it. That is the beauty of it. So if you cross any two vectors and then you do the dot product with it, you'll basically get 0. You'll basically get 0. And in mathematics, it's called as scalar triple product, but that is not something that you have to learn. But I need that you should understand basically the logic behind it. I want you all to understand the logic behind it. If you have understood it, can I have some fire in the chat box? Can I have some fire in the chat box? If you want to find N cross I dot R, sir, N cross I. So this is a perpendicular vector, and obviously this perpendicular vector is is perpendicular to R also. That is the reason you are getting the scalar triple product as 0. Simple. Now, how many of y'all were learning this for the first time? How many of y'all were learning this for the first time? I've already told you that I would be teaching you a lot of new things. Okay. Tell me how many of y'all were learning it for the first time. I can understand Kannada a little bit. Yes, I can understand Kannada a little bit. Okay. Yeah. Okay. Yes, me. Okay. So I hope so you have understood this. Okay. I hope so you have understood this. Now moving on, people. Now let us understand the crux of the chapter. Now when I'm telling you the crux of the chapter, I mean the crux of the chapter. Now what do I mean by that? Ray optics, it just revolves around object and image. If you do not understand object and image, you're not going to understand the chapter. Okay, let's focus. Okay, now let's focus. Why we make dot? We make cross also. No. So this has to be dot. Okay, this has to be a dot. So this is the cross of these two vectors and dot of the third vector. Okay. Moving on. Very simple, people. Now it's a very important part that I'm going to explain. So all your focus should be on the board. Sir, how to identify an object? First of all, let me just write the definition over here. Object. Okay, now this is something that we can write in your running notes. Okay, I want you all to write this in your running notes. What is an object? Object is basically an intersection. Object is basically an intersection of incident rays. It is basically an intersection of incident rays. Are you all able to understand this? What is an object? An object is an intersection of incident rays. Now, how to understand whether it's a real object or a virtual object? If the rays actually meet, it's a real object. If the rays they do not actually meet, they are appearing to meet, we are just assuming that it will meet, then it's called a virtual object. Now let us understand it in a little bit. Okay, so this is basically object for you all. Now what is image? Image is basically everything is same. Everything is literally the same. Just a second. Intersection of reflected or refracted rays. Are you all able to understand this? Yes. Now what do I mean by this? See, very easy to understand. Now first let us understand object. See this. This is an object over here. These are the incident rays. Now, where are all these incident rays intersecting? Sir, they are intersecting at this point, sir. So that is the reason we can call this as the object. Now, right over here. Sir, this is the incident ray. It is appearing as if it's going to intersect at this point. That is the reason this is called as the object. Now, right over here, the rays are actually meeting. That is the reason this is called as a real object. Over here, the rays are not actually meeting. We are assuming that it will meet at this point. That is the reason it's called as a virtual object. Is this clear? Yes or no? People, you have to like the video. Okay, you have to like the video. This is quality content that I'm providing. Now, if you have understood object and image over here, now let's move on to the image. Okay, see this. If you can see with the help of ray diagram also, or with the help of the direction of the arrow itself, you are able to understand these are reflected rays or refracted rays. The reflected rays or the refracted rays are meeting at this point. That is the reason this is called as image. Over here, see this. This is basically after reflection or refraction, they're appearing to meet over here. They're appearing to meet over here. That is the reason this is called as image over here. Now, over this point, the rays are actually meeting. The reflected rays or the refracted rays are actually meeting. That is the reason it's called as a real image. And over here, the reflected rays or the refracted rays are appearing to meet. That is the reason it's called as a virtual image. Yes or no? Yes or no? So again, I'm going to explain because this is the crux of the chapter. If you do not understand this, then you're not going to understand the rest of the chapter. So one more time, just one more time, and then we are through. Sir, what is object? Sir, object is intersection of the incident rays. So these are the incident rays. They're going to incident obviously at some glass slab, some mirror or something. So they are intersecting at this point. All of the incident rays are intersecting at this point. That is the reason it's called as an object. Now it's actually intersecting. That is the reason it's called as a real object. At the same time, over here, this is the incident ray. The incident rays appear to meet at this point. That is the reason it's called as an object. But as they are appearing to meet, it's called as a virtual object. Now over here, these are the reflected rays, the refracted rays. It can be anything. It depends upon the situation. They're actually meeting at one point. That is the reason it's called as a real image. Now over here, this is basically again reflected rays, refracted rays. It can be anything. They appear to meet. They are assumed to meet at this point. That is the reason it's called as a virtual image. Clear? Clear? Everybody. So what is object? Intersection of incident rays. What is image? It is intersection of the reflected or the refracted rays. Clear? Yeah. Can I move ahead? Yes. I need your confirmation. I need some fire in the chats if I can move ahead. See this. Let us understand this with the help of one more example. See, this is your object. Yes, sir. This is your object. This is incident rays for you all. Okay. It gets incident over here. This is a plane mirror. This is the reflected ray. Angle I is equal to angle R. The observer is able to see. But observer knows, our brain knows that light can only travel in straight line. That is the reason we think that the image is basically getting formed over here. What does our brain know? Our brain knows that light can only travel in straight lines. We know that light can only travel in straight lines. So after getting reflected, when it reaches our eye or when it reaches the retina of our eye, we think, light can only travel in straight lines. So our object must be somewhere over here. And that is the reason we are able to get an image over here. Now, see this over here. Let us use our definition of incident rays and reflected rays. See this. This is incident rays. The intersection of incident rays is basically an object. So this is a real object because the rays are actually meeting over here. Yes or no? Okay. These are the reflected rays. The reflected rays appear to meet at this point. That is the reason this is called as a virtual image. This is a virtual image. Are you all able to understand this? Intersection of incident rays is the object. Intersection of the reflected or the refracted rays is called as the image. Now they are appearing to meet over here. That is the reason it's called as a virtual image. Okay. Very good. Now some properties of a plane mirror. Now I'm going to ask you a question. Okay. The question is, here it is written that the image obtained by a plane mirror is virtual. Now the question is, is it always virtual? That is the question. Now come on, answer me in the chats. That the image formed by a plane mirror, is it always virtual, or there can be a case where you can get a real image? Okay, new student, very good. Okay, I want to see the answers in the chat. Next, it's written that the image is laterally inverted. Obviously, the image is laterally inverted. So if you are able to see, that this is lateral inversion. Okay, yeah, this is lateral inversion. See this is lateral inversion. I'm moving this finger. That is, just a second. Yeah, I am moving this finger over here, है ना? I am moving this finger, that is, this is my left finger, है ना? That is my left finger, but the image, the right finger is basically getting moved, है ना? This is lateral inversion, this is lateral inversion for you all, and basically you can see, है ना, something also written, please keep the door closed to avoid AC disruption. Lateral inversion, है ना? Are you able to see the ulta, the opposite thing, है ना? You are able to see, you are able to understand. Yes, left appears as right and right. Okay. Okay, people. Yeah. Laterally inverted. That is something that we know that it is true. Okay, it is true. Okay. It can be virtual only. Okay, so let's see. Only one person has answered. Again, I'm gonna repeat the question, that the image obtained by a plane mirror, is it always virtual? That is the question. Okay. Next. The image is erect. The image is erect. Obviously, the image is erect. Obviously, the image is erect. है ना? So see, this is an erect pen. है ना? This is the erect pen. And the image also that you are getting is also erect. The image is also erect. It's not ulta. No, it's not ulta. It's erect. Same orientation. Same orientation. Yes. It is erect as well. Yes. The size of the image is also the same as size of the object. Yes. Size is also same. Size is also same. है ना? Okay. The distance between the image and the object, is also the same. That means if this is the mirror and if this tree is some 10 meter far, and 10 meter far, the image also that you're gonna get is also some 10 meter far from the mirror. Tamal Terium, है ना? Yeah, you know the answer. White only forms only virtual. Let's see, है ना? Okay, see this. Now the answer to this question is, in the next page. Plane mirror always a virtual image? The answer is no. Not always a virtual image. The answer is no. The answer is no. See, I'll tell you. See this. When you use a virtual object over here, you actually get a real image over here. Sir, I did not understand it, sir. What is a virtual object? First of all, tell me what is an object. Sir, an object is basically an intersection of incident rays. Okay. What will be in a virtual object? A virtual object is basically when the incident rays actually appear to meet at a point. And they assume to meet at a point. They appear to meet at a point. So, how is this a virtual object? These are the incident rays. These are the incident rays. These are the incident rays. They appear to meet at a point. That is the reason this is a virtual object. And this virtual object gives you a real image over here. Sir, why is this a real image? Because all the reflected rays, they actually meet at this point, and that is the reason you get a real image. Now, obviously, independently a virtual object can't exist, but you can basically form a virtual object. Are you all able to understand this? With some other experiment or with some other mirror, you can basically form a virtual image over here, and this virtual image can act as a virtual object for this plane mirror. Are you all able to understand this? Meaning with some other mirror or with some other lens or with some other any apparatus, you can basically form a virtual image over here, and that virtual image will act as a virtual object for this plane mirror. Clear? Now that is the doubt which everybody has, sir. How to form a virtual object? Obviously, you can form a virtual image, and that virtual image will act as a virtual object for this plane mirror. Simple. And that is the time that you get a real image as well. So, a plane mirror, does it always form a virtual image? No, it does not always form a virtual image. It can form a real image as well. Okay. Yes. In order for you to get this virtual object, obviously you have to use some other apparatus as well. But the question was, can plane mirror form a real image? Yes, it can form a real image. Yes or no? Okay, let's go. If you have understood this, can I have some fire in the chats, people? Can I get some fire in the chats? Very, very important property. Very, very important property. Okay. Now people, in physics, है ना? Obviously, see, Gopi, I will not say that it's impossible. It's very difficult though, okay? But you have to give your all, you have to give your all, okay? Okay. So see people, in physics there are a lot of laws actually, है ना? And these laws actually govern physics. So if you understand this physics or these laws, then 80% of your work is over, है ना? And the rest 20% is just numericals. Okay, now let's understand what is principle of reversibility. Okay, what is principle of reversibility? Meaning what happens is that, है ना? What happens is if I keep a plane mirror over here, है ना? If I keep a plane mirror over here, just let me draw a plane mirror, just a second, a plane mirror, yeah, this is the plane mirror over here, है ना? Yeah, this is the plane mirror. Okay, this is the plane mirror over here, है ना? This is the plane mirror over here. I'm going to use this plane mirror here as well. Okay, see this, okay? Okay, see this. And if the incident rays is actually incident perpendicular to the mirror, okay, I'll tell you, see this. This is the incident ray, it gets refracted due to some reason, we'll look upon it in some time. So this is the incident ray, gets refracted. Now this ray or this incident ray right over here is incident perpendicularly to the mirror. Now what will happen? If a ray is incident perpendicularly to a mirror, it will again retrace the same path. It will again retrace the same path. So what happens is, if a ray comes like this, if it hits perpendicular to the mirror, it will again retrace the same path. Now this property of mirror, I am going to use it multiple times in the upcoming slides. This is called as principle of reversibility. That means if I have a mirror over here, this is the mirror over here, and if the incident ray is striking perpendicular to the mirror, the reflected ray will also retrace the same path of the incident ray. Are you all able to understand this? But only if it is striking perpendicularly to the mirror. That is basically the condition. Okay. Are you all able to understand this? Mirror, incident ray, perpendicular, then it will retrace the same path. No matter what the condition is. So this is the mirror, incident ray is perpendicular to the mirror. So it will retrace the same path. That is called as principle of reversibility. Yes. It is very interesting to study physics with the help of apparatus and experiments, right? Am I right? Yes or no? It is interesting, right? Okay. Now, let me, okay, very, very important people. I think this is also something new for you, है ना? This is also something new for you because again, I'm telling you. Okay. Okay. Okay, let's understand. Okay, let's understand. Now what is happening over here? That is rotation of mirror and incident ray. What is happening? है ना? Okay, now let us understand over here. I'm gonna make you understand with the help of a visualization. Very, very important visualization coming up. Now see this people, है ना? Okay, I want your focus to be only in one point. That is this point. Okay, I want all your focus to be on this point right over here. Okay. Now see this. Okay, this point. If you are able to see the incident ray, है ना? I'm going to rotate the incident ray with some theta. See this. I'm rotating the incident ray with some theta. See this. I'm rotating the incident ray with some theta. Yes or no? See this. I'm rotating the incident ray with some theta. Yes or no? Yes or no? Yes. And by the same angle or the opposite angle, the reflected ray is also getting rotated. So if the incident ray is getting rotated by 30 degrees in this direction, the reflected ray is getting rotated by 30 degrees in the opposite direction. Are you all able to understand? I'll help you visualize it again. That means if I am rotating this by 30 degrees over here, the reflected rays will get rotated by 30 degrees in this direction. So the angle is same. The angle by which it is getting rotated is same, but the direction is opposite. If incident ray is clockwise, reflected ray is anti-clockwise. See this? See this. This is theta and this is also theta. Only the direction is changing, people. Only the direction is changing. So incident ray over here and reflected ray over there. That means that is it. So I can basically say that if the incident ray is rotated by some angle theta over here, the reflected ray will get rotated by the same amount of theta, but in the opposite direction. See, earlier incident ray was, reflected ray was here. I rotated it by some angle theta, reflected ray also get rotated by some angle theta, but in the opposite direction. Good evening. So basically, can I say theta incident? That is, if I rotate the incident ray by some angle theta, the reflected ray will also get rotated by the same angle theta, but with a negative sign. Now, what does this negative sign actually mean over here? The negative sign actually means over here that the angle by which the reflected ray is getting rotated is basically just opposite. Simple. Background noise. Background noise. Now good. Okay. Voice is breaking. The angle by which the reflected. Now is it clear, people? Is it clear? Voice break was there, but I think it's clear now, है ना? I think it's clear now. Now, okay, very good. So again, see this, very important to visualize, people. See this, just focus your attention at this point, है ना? I'm gonna rotate the incident ray by some angle theta. Now see this, no, the same angle by which I am rotating the incident ray, the reflected ray is also getting rotated, but in the opposite direction. See this? So if this is theta degree rotated, this also gets rotated by theta degree, but in the opposite direction. Yes, I will be covering JPYQs. Okay. So if I am rotating the incident ray by some angle theta, the reflected ray also will be rotated by the same angle theta, but in the opposite direction. That is the reason minus sign over here. Are you all able to understand this? People? Okay. Now this is rotation of the incident ray itself. Now I'm going to rotate the mirror itself. So I'm just going to give you a basic formula of this. Don't worry about the visualization. I'm going to give you the basic formula of this. The basic formula is, if you rotate the angle or the mirror by some theta angle, the reflected ray will basically get rotated by twice the angle. It will get rotated by twice the angle. This is basically the formula that you have to keep in mind. That means if you rotate the mirror by some 30 degrees, the reflected ray will rotate by 60 degrees. That is what the case is. If you rotate the mirror by 15 degrees, the reflected ray will rotate by 30 degrees. That is exactly the cases. Are you all able to understand this? Background noise. People, I am not able to understand. Sound aa raha hai. With sound. Background noise. Okay, just a second. Okay, voice breaking. Okay, just a second. Understand. Sound aa raha hai. With sound. Background noise. Yeah, I hope so. Okay, I hope so. Now this is clear, है ना? I hope so. It's clear. Yes or no? Okay. Yeah, I think someone is also taking the class from the adjacent studio as well. है ना? Okay, I think it's very less, है ना? Okay, now I think it's sorted. I think it is sorted. Yes or no? I think it is sorted. Yes, it is sorted. Okay, clear. Clear. Okay, very good. So theta I is equal to minus theta r, and theta r is equal to 2 times of theta m. Okay, people? Yes or no? Okay, chill. let's move ahead. Let's move ahead. Okay, let's move ahead. Now, people, I want you all to basically note this question now. Note this question now. This is basically the foundation that I'm going to lay for your geometrical optics. Okay. Yeah, this is the second case name is basically rotation of mirror. This is rotation of mirror, and that is rotation of incident ray. Okay. Very, very important question. Very, very important question. Please note it down. Please note it down, people. Please note it down. This question. What is the question? Incident ray is parallel to M2. Okay. And the final reflected ray is parallel to M1. That is mirror 1. Find the angle between the two mirrors, that is theta, and also find out the net deviation. And also find out the net deviation. Please note it down. Okay. So this is a mirror M1. This is mirror M2. They both are incident at some angle theta over here. Now, according to the question, we have to find this theta over here. Okay. We have to find out this theta over here. Okay. See this. They've already told you that the incident ray is parallel to M2. The incident ray is parallel to M2. What do you mean by that, sir? That means the incident ray is something like this. This is your incident ray. Yeah, this is your incident ray. M2 is parallel to this incident ray. Okay, yes or no? Let's see. So, people, if this M2 is parallel to this incident ray, this is your incident ray. This is your incident ray. If this is parallel, so obviously if this is angle theta, this is also angle theta. Simple. This is also angle theta. This is also angle theta. Now let me draw a normal over here. This is basically your normal. Yes or no? Yes, sir. This is your normal. So, can I basically say that this becomes your 90 minus theta? This is your 90 minus theta. Yes, sir. This is my 90 minus theta. And this will be my reflected ray. This will be my reflected ray, something like this. Yes, this is my reflected ray for you all. This is my reflected ray. And this is my reflected ray. This is angle of incidence. So this also will be angle of reflection. This also will be 90 minus theta. This also will be 90 minus theta. Okay. Sir, parallel to M1. No. Incident ray is parallel to M2. We have still not. No. Don't worry. It's not incident on M2. Incident ray is parallel to M2. It's not incident on M2. It is incident on M1 itself. It's just parallel to M2. Okay. Next. Draw a normal again. Draw a normal again over here. Okay. I've drawn a normal over here. Now what they have said? Now this ray should be parallel to M1. This ray, this ray should be parallel to M1. Something like this. Yes. This is the final reflected ray. Yes or no? Final reflected ray. Are you all able to understand this? Are you all able to understand this? So see this. This incident ray is parallel to M2. So this is theta. This is also theta. It gets incident over here. I draw a normal. So this becomes 90 minus theta angle of incidence. Angle of reflection also 90 minus theta. Reflected ray goes as an incident ray for mirror M2. This is your point of incidence. Okay. Now obviously this angle and this angle would be equal. But how to find out? Simple. See this, people. This is also angle theta. Can I say that this angle is also theta? Yes or no? Can I basically say that this angle is also theta? Obviously, this is also parallel. This is also parallel. Corresponding angles. This is also theta. This is also theta. Yes or no? Okay. Now, as this is the normal, obviously this whole angle along with the normal will be 90 degree. So can I basically say that this is 90 minus theta? Yes, sir, this is 90 minus theta. And if this is 90 minus theta, this is also 90 minus theta. Yes, sir, this is also 90 minus theta. So if this is 90 minus theta, I know glazing, that is the glancing angle of reflection is equal to glancing angle of incidence. Alpha equal to beta, alpha equal to beta. If this is also theta, this is also theta. Yes or no? Yes or no? And people over here as well. This, if this is angle theta, this is also angle theta. Are ha ya no? Yes or no? Yes or no? Yes or no? Very, very important to understand. Very, very important to understand. This is also theta, this is also theta. This is also theta, this is also theta. This is 90 minus theta, 90 minus theta. And if this is theta, this is also theta. Are yes or no? Now people, I want your focus to be in this triangle. I want your focus to be in this triangle. What is the angle sum property of a triangle, people? I know that the sum of angles of a triangle should be equal to 180 degrees. So 3 theta is basically equal to 180 degrees. Theta comes out to be 60 degrees. Theta comes out to be 60 degrees. Are you all able to understand this? Did you all understood the geometry? Did you all understood the geometry? Did you all understood the geometry? Very, very important. Very, very important. And it should be neat, okay? It should be neat. It should be neat. Yes. Okay. Now, what they've told us to find. What have they told us to find? We have to find the net deviation. We have to find out the net deviation. That means, people, see, originally I can say that the incident ray was coming something like this. And finally, it is going something like this. है ना? One more time. Originally, it was coming something like this. And finally, after all the reflection, it is going something like this. So basically, can I say that it got deviated by some angle something like this? This is the angle that I have to find. Or you can also say, sir, this is the angle that I have to find. Both are equal. Both are same. Both are same. Not both are equal. Both are same. Both are correct. Both are correct. Both are correct. Okay. Okay. See this? Initially it was coming like this, finally it is going something like this. So I can basically say it got deflected by this angle, or I can even say it got deflected by this angle. Both are correct. Both are correct, and we're going to find it out. We're going to find it out. See this? Can I basically say, people? Can I basically say, if this is angle theta, this is also angle theta. Yes, sir, this is also angle theta. This is also angle theta. Huh. Now, this is a straight line that I'm talking about. This is a straight line that I'm talking about. If this is theta, can I basically say that this angle is 180 minus theta? Yes, sir. This is 180 minus theta. And this is basically the deviation that I want. This is basically the deviation that I want. Are ha, sir. It should be 180 minus theta. Theta comes out to be 60 degrees. So this comes out to be 120 degree. This comes out to be 120 degree. But in which direction? But in which direction? In this direction. In this direction that I'm talking about. In this direction. That is the anti-clockwise direction. Anti-clockwise direction. Now, I can even say, so this should also be the deflection. This is also a deflection. Yes, this is also a deflection. I'm not saying it's wrong. It's also right. It's also right. Yes or no? Can I calculate that? Yes, I can calculate that. Yes, I can calculate that. That is just basically how much? 360 minus 120. That's it. 360 minus 120. Yes or no? So I can even say del comes out to be 360 minus 120. That is 240 degrees. 240 degrees. But in which direction? In clockwise direction. In clockwise direction. Clear? 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 Is it logical, people? Is it logical? Is it logical? Is it logical enough? Are you all able to understand it? Are you all able to understand it? Yes or no? Are you all able to understand it? Yes or no? Okay. Once again. So see this. I'm just explaining it one last time. Incident ray parallel to M2. So this is theta. This is also theta. Incident ray, reflected ray, normal. If this is theta, this is also theta, because I've already told you alpha equal to beta. So this becomes 90 minus theta. This is also 90 minus theta. Okay, sir. Very good. This goes, the reflected rays goes over here. This becomes an incident ray for M2. Then it's written the reflected ray, the final reflected ray is parallel to M1. So this is parallel to M1 over here. Okay. Now, people, understood. Very, 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 very easy to understand. If this is theta, this is also theta. Yes, sir. Sir, if this is theta, this should also be theta. Again, alpha equal to beta. 90 minus theta, 90 minus theta. Very easy. Theta plus theta plus theta should be 180 degree. So I get theta as 60 degree. I get theta as 60 degree. Clear. Now I want to find the deviation. Earlier it was coming like this. Finally it is going something like this. So basically, can I say that the deviation is this angle or this angle? I need to find these angles. It's very easy. I just need to use simple geometry. This is a straight line. This whole angle is 180 degree. This is angle theta. This is also angle theta. So basically, can I say that this angle is 180 minus theta? That is basically your deviation, but in anti-clockwise direction, 120 degrees. I can even find out this direction. That is 360 minus this. That is 360 minus 120. That is 240 degrees. Finish. Clear? Can I get some fire in the chats if you understood this? Fire in the chats if you have understood this. Fire in the chats if you have understood this. And please like the session, people. In clockwise direction, why 180 plus theta? No, it's not 180 plus theta. Who told you it's 180 plus theta? Delta is 180 plus theta. No. Why 180 per? This whole angle is 360. I just subtracted 120 from here. So this is the angle that I'm getting. Okay. ठीक है. चलिए. Moving on. Okay. Now. Yeah. Complete image in a plane mirror. Okay. Yeah. So see, if in your test, they give you without any sense of rotation, because obviously they need to give a sense of rotation over here. So you need to calculate both the cases, because they would not give you both the cases over here, both the answers over there, because both the answers are correct. So even if you take anything, they should give you marks. They should give you marks. But if I say mathematically, if I say most of the time, they'll give you the acute angle over here, the smaller angle, and not the acute angle, they'll give you the smaller angle over here. Okay, they'll give you the smaller angle. Okay, okay. Complete image in a plane mirror, very, very important, people. Many questions asked. So what do you mean by this topic? The meaning of this topic is what should be the minimum length of a plane mirror, so that I can see completely from head to toe. I can see myself completely inside this plane mirror. That is exactly this topic. Again, I'm repeating. What is this topic? This topic is basically what should be the minimum length of a plane mirror, so that I can see from head to toe completely. Minimum length. Okay. Okay. Chaliye. People, this is your plane mirror. This is your plane mirror. Okay. Now, I'm gonna assume that this plane mirror is x plus y, some x plus y. The length of the minimum length of the plane mirror should be x plus y. This is your minimum length. And the total height, okay, the total height of this fellow, the total height of this fellow is capital H. The total height of this fellow is capital H. So the relation that you get over here, is x plus y is basically equal to h divided by 2. This is basically the relation that you get, and this is the relation that you must know. What is x plus y? So x plus y is basically the minimum length of the mirror. This is basically the minimum length of mirror for you to see from head to toe. What is height? H. That is basically height of the man. This is basically height of man. Now people, many of you all know only one condition. Many of you all know only one condition. There are actually two conditions that you should satisfy. There are two conditions to satisfy over here. So what is the second condition? Arey bhai, just knowing the minimum length of the mirror, will not solve your problem. Sir, why, sir? Arey yaar, you also need to know na what should be the height at which you have to place the mirror. You also need to know at what height you have to place the mirror. At any height you can't fix the mirror, right? Otherwise you'll not be able to see. Now you know the minimum length of the mirror. What is the minimum length? The minimum length is h by 2. That is half of the total height of the man. But at what height you should place the mirror, that also you should know. That also you should know. Otherwise, what is the use of it? What is the use of it? So over here, I'm also writing and. There is one more height that you have to keep in mind. This is height Z. What is height Z, sir? What is height Z? I'll tell you. That is height of mirror. No. Distance of lower part of mirror from ground. Distance of lower point of mirror from ground. Should be equal to Z divided by 2. This is your condition. This is also your condition, people. This is also your condition. That means this height over here, this height should be Z by 2. If this is your ground, the lower point of the mirror should be at a distance of Z by 2. What is Z? I'll write Z. What is Z over here? Z is basically the height from I to feet. Okay, I to feet. That is basically your definition. So basically, people, come on, let us revise. Very, very easy to understand. Sir, what is the minimum length? What is the minimum length of the mirror that should be there so that I can see full? Sir, it is h by 2. Half of my height. That should be the minimum length of the mirror that should be there in order for me to see myself completely. But what should be the height at which the mirror should be placed from the ground? It is Z by 2. And what is Z? Z is basically the height from your eye till your feet. Z by 2. Are you all able to understand this? So the minimum length is x plus y, that is h by 2, and the minimum height at which it should be placed, or the appropriate height at which it should be placed is Z by 2 over here. And what is Z? Z is basically height from the eye to the feet. Clear? Yes or no? If you have understood this, fire in the chats, people. Question for you all. It's a 2000 NEET PYQ. Very, very easy PYQ, people. Very, very easy PYQ. A tall man of height 6 feet wants to see his full image. Then the required minimum length of the mirror should be how much? Very, very easy. We know that the required length is x plus y, which is basically equal to h by 2. That is 6 divided by 2, that is 3 feet. Option B is your right answer, and plus 4 marks guaranteed. For you. Very, very easy question, people. They have not asked you what should be the minimum height at which the mirror should be placed. So no need of calculating. But in order for you to calculate that, you need to know the height from the eye till your foot. Okay, that is something that you should know. Okay. B, very good, people. Very good. Now we are going to understand the number of images. So what is number of images? That means if I have two mirrors inclined over here at some angle theta, and I have an object over here. How many images will be formed? Now obviously there is this formula over here. Which you all know. But I am not a fan of that because I don't get feel from it. I don't understand it. And because this formula, I don't like when people or when students, they just mug up physics. Physics is not just about mugging up people. It is actually not about mugging up. It is about understanding. So if you want, you can use this formula. I don't have any problem. That means 360 divided by theta is equal to m, and if m is an even number, then the number of images is just subtract 1 from it. That is the number of images. If 360 by theta is equal to m, and if m is odd, there will be two cases. If it is not on the bisector, then the number of images is n is equal to m, and if it is on the bisector, you have to again subtract it from -1. I did not get the feel, sir. है ना? I did not get the feel. That is where the crisscross method comes into play. है ना? That is where the crisscross method comes into play. Are you all ready? Are you all ready to understand the crisscross method? Yes or no? The crisscross method. If you want, you can use this formula, people. I don't have any issues. I don't have any issues. You can use this formula. But if you want to understand, if you want to have a genuine feel for it, an intuition for it, then crisscross method for you all. Let us understand the crisscross method with the help of many diagrams. Many diagrams. People, now it's your chance. Please draw this diagram in your notebook. Please draw this diagram in your notebook. I am going to explain you how to basically calculate the number of images. I'm going to basically help you calculate the number of images over here. Please. So I have two mirrors over here. Both are inclined at 50 degrees. है ना? Both are inclined at 50 degrees, and I have an object over here. I have an object over here, O. So O is at an angle of 30 degrees with M1 and O is at an angle of 20 degrees with M2. ठीक है? Formulas are time saving, but what if in your NEET 26 paper they ask you at what angles they are getting formed? At what angles they are getting formed, then formula is of no use. This method, you can calculate the angle at which the images are formed, and you can also calculate the number of images that are getting formed. Okay? And it's very easy to understand. Okay? Done? Okay, see this. This is M1, this is M2. Okay? M1 is 30 degrees. Okay, M1 is 30 and this is 20 degrees. Okay? What is the angle between them? 30 plus 20 is 50. है ना? 30 plus 20 is 50. Now what do you have to do? See what do you have to do? See what do you have to do? Okay? 30 plus 50 is 80. 20 plus 50 is 70. Very good. Again, crisscross. 50 over here. 50. 70 plus 50, 120. 80 plus 50, 130. है ना? I hope it is right. है ना? 110. Yes, it's right. है ना? 80 plus, yes. Again, 50. Again, add 50. 130 plus 50, it is 180. 120 plus 50, it is 170. That's it. Then you stop. Then you stop. Sir, how to know that we have to stop? If you get an angle which is equal to 180 or greater than 180, है ना? Reject angle greater than or equal to 180 degree. You have to reject that angle. Okay? So this is basically the number of images which are formed. So this is the first image, second image, third image, fourth image, fifth image, and sixth image, and seventh image. So what is the number of images that are formed over here? Don't worry, we'll do many examples. Don't worry. So number of images in this case is equal to 7. 7 is your answer. So 7 images will be formed in this case. And at what angles? 30 degree, 20 degree, 70, 80, 130, 120, 170, and no, not 180. You have to reject 180. And reject 180. Reject 180. Clear? Did you all understood it? Don't worry. We're going to do many examples. We're going to do many examples. Don't worry. We're going to do many examples. I hope so it is clear. So the number of images is 7. So you have to reject the angle which is greater than or equal to 180 degree. Okay? Next. This is your second example. Please note. And if you have noted it down, just type done in the chat box. Please write done in the chat box. Okay. I hope so you have done it. Now let's repeat it again. है ना? So the object right now is over here. Object is at 45 degrees with M1 and M2 25 degrees. Okay. Okay, chalo. M1, M2. M1 is 45, है ना? M1 is 45. M2 is 25. Angle between them is how much? This is 60. 40 plus 20, 60, 70. Okay, angle between them is 70 over here. Chalo, let's start. है ना? 45 plus 70, how much it is? It is 115, I guess. है ना? 115, है ना? 70 plus 40, 110. Yes, 115. 70 plus 25, I think it is 95 over here. Then again add 70. Again add 70 over here. है ना? 95 plus 70, how much is it? I think it's 165. 165. 115 plus 170. How much is it? I think this is 5, 8. Yeah, I think this is 185. No? This is 5 and this is 8. Yeah, this becomes 185. This becomes 185. Yes or no? Have you all done? Have you all done with this? Okay. Chaliye. Now let's understand. है ना? Let's understand. Okay, see this. So we have to reject 185 because it is greater than 180. है ना? So the number of images are 1, 2, 3, 4 and 5. 5 is the number of images. 5 is the number of images over here. 5. Number of images 5. Very good, people. Very good. I think you are getting a hold of it. I think you are getting a hold of it. है ना? है ना? Yes, very good, very good, very good, very good, very good, very good. Okay, but still the method is still not complete. Don't worry, है ना? The method is still not complete. We will be solving many problems. One more, people, one more for you all. Chalo, let's do this. 45, 45, 45, 45. Let's do this. 45, 45. 45, 45. I hope so you have drawn this. I hope so you have drawn this. है ना? Very, very easy. Very, very easy. Let's start. Let's start. M1, M2. This is 45. This is 45. Cross, crisscross. This is 90 for you all. है ना? Object is kept over here. Object is kept over here. Okay, very good. Now, let's calculate, people. Let's start calculating. 90 plus 40, 45 is 135 for you all. Same goes over here, 135 for you all. Crisscross, sir. Crisscross. 90, 90, 90. How much is this? How much is this? That is 135 plus 90. That is 225. And 225 and 225. So obviously you have to reject. You have to reject 225 over here. You will reject 225 over here because it is much more greater than 180. It is much more greater than 180. Yes or no? Yes or no? Now people. No. 4 is not the correct answer. I'll tell you. 4 is not the correct answer. There is one more rule that I'm going to teach you. One more rule that you have to keep in mind. So the first rule was what? Any angle which is greater than 180 degrees or equal to 180 degrees, you have to reject. The second rule that you have to keep in mind, is basically this. This one. This is the rule. I'll tell you what the rule is. This is the rule. That means if you add all of these up, sir, what? If you add all of these up, 135, 135, 90. Sir, what is 135? What is 135 plus 135 plus 90? What is this? I think this is 360. If you add all three angles together and if you get the sum as 360, you have to consider them. You have to consider them as one image. You have to consider them as one image. You have to consider them as one image. Is this clear? Is this clear? So if the addition of these three angles is 360, you will only consider it as, sir, it is not 250, it is 270. 250? From where are you getting this? Okay. Okay, did you all understood this? So if you add all of these three angles together and if you get the sum as 360, you are gonna consider it as only one image. So what is the total number of images? This is 1, this is 2 and this is 3. That is it. So the number of images over here, the number of images over here is equal to 3. 3 is the number of images. Okay, now how, why are we telling, why are we saying that we'll only get one image? Because both these images, that is 135 degree and 135 degree, they are overlapping with each other. They are basically the same image, overlapping with each other. So that is the reason we are counting it as only one. Okay, that is the reason we are counting it as only one. Clear? Okay. Is it okay? Is it clear? Is it understood? So, two rules, people. Greater than 180, rejected. And if the sum of three angles is 360, you have to consider that one thing as one image. Clear? Okay. Moving on. Last question. Last question, people. Last question. Last question for this number of images. Last question for this number of images. Last question for this number of images. That is 20 and 40. 20 and 40. Object is over here. Object is over here. Okay. Let's solve. Let's solve it, people. Now you know all. Now you know all the rules. Now you know all the rules. 40 and 20. Okay. 40 and 20. This is 60 for you all. Hai na? 60 for you all. 40 plus 60 is 100. This is 80. Next. Again 60. 80 plus 60 is 140. 100 plus 60 is 160. Again crisscross. Again crisscross. So 160 plus obviously this is greater than 180. And 160 plus 60 that we are talking about. So this becomes 220 for you all, and this becomes 200 for you all. This becomes 200 for you all. Okay. So obviously you're gonna reject this. You're gonna reject this because it is greater than 180. You're gonna reject this. Now let's check for this. No? Let's check for this also. Let's check for this also. If you check it over here. If you check it over here. If you check it over here, what is the addition? 160 plus 140 plus 60. How much is it? I think it comes out to be 360 degree. So this is an overlapping image. So you have to consider it was only as one image. You have to consider it only as one image. So first, second, third, fourth, and fifth. So the number of images over here is 5. Is 5 because 160 and 140 degree are overlapping images. Okay. Okay. Just a second, people. Just a second. I'll just come. Okay. I'll just come. Just a second. Yes, I will complete the I will complete the whole chapter. If you have understood this, fire in the chats. If you have understood this, fire in the chats. Yes or no? Very good, people. Very good, very good, very good, very good. Okay. So I think you have understood this very clearly. Yes, I think you have understood this very clearly. Okay. So now you also know the number of images, and you also know where all the images are also getting formed. Very good, people. Very good. That's a good response that I'm getting. Amazing response. Now, velocity of image. Don't worry, we're going to solve a lot of problems. We're going to solve a lot of problems. And I mean a lot of problems. Even if you do not solve DPPs, no worries. That is the amount of problems that I have. But you have to solve it on your own. That is the key over here. Okay. Now let's understand the velocity of image. Okay, people. Let us understand velocity of image. If this is the plane mirror, if this is the plane mirror that I'm talking about, this is the plane mirror that I'm talking about. Okay. This is the plane mirror that I'm talking about. Okay. Okay. I have kept an object over here. I have kept an object over here. So obviously an image will be formed if this distance, if this distance is d, at the same distance d, an image will be formed. An image will be formed right over here or something. This is the image. This is the image. Yes or no? Now, if I want to write the coordinates of this object and image, coordinates. This is in the negative x direction, right? So can I write the coordinates as minus x comma y comma z? This is basically the coordinate of this object. And at the same time, the coordinate of the image would be x comma y comma z. That's it. This would be the coordinate of the image. Yes or no? So basically, can I say that the position of the object with respect to the mirror is basically negative of position of the image with respect to the mirror. Can I basically say this, people? can I basically say this? Now, whatever calculation that you're going to do, you have to calculate with respect to the mirror itself. So what I'm trying to say over here is, that means the position of the object with respect to the mirror is equal to negative of position of image with respect to the mirror. If this is minus x, that is x. Yes or no? X minus x. Why 3 dimensions? Because this is 3 dimension, nobody. This is 3 dimensions. This is 3 dimensions we are talking about, no? And this is 3 dimensions that we are talking about. That is the reason 3 dimensions. Hai na? Hai na? Okay. Very, very important, people. Now, if I differentiate this, differentiate with time t. If I differentiate with respect to time t, what I'm getting? What am I getting? I am getting velocity of object with respect to the mirror is basically equal to negative of a velocity of image with respect to the mirror. This is something which I'm getting. Now, this is everything which I'm writing it over here. Hai na? Everything which I'm writing it over here, I'm writing it with respect to the mirror itself. But obviously I want to make things easier for me, hai na? Sir, I want to make things easier for me. Please make this formula easy for me. Sir, I'm not able to understand with respect to mirror and everything. I'll make it easier for you. We have already studied, and you have already studied in motion 1D and 2D. Yavar sir has already taught you about relative motion. I can write this as velocity of object minus velocity of mirror. Yes or no? And this I can write it as negative of velocity of image minus velocity of mirror. Yes or no? Can I write this something like this? Can I write this? Can I write it something like this? क्या हो गया? अरे, what happened? Okay, can I write it something like this? Huh. Clear? Yeah, I'll explain again. Don't worry. So this becomes velocity of object minus velocity of mirror, which is basically minus of Vi plus Vm over here. Yes or no? Ha, sir. So this becomes velocity of object plus velocity of image is 2 times of velocity of mirror. This is basically the formula that you have to keep in mind. But from where it has come, that also you have to keep in mind. That also you have to keep in mind. See this, people. I've already told you this is the object and this is the image over here. Object coordinate, can I write it as minus x comma y comma z? It is because in the negative x direction. So the image I can write it as x comma y comma z because the distance should be same with respect to the mirror. So I've written xom, that is the position of the object with respect to the mirror. Obviously we are writing with respect to the mirror, right? We are writing with respect to the mirror is equal to negative of position of image with respect to the mirror. Okay. I'm differentiating with respect to t. So position becomes velocity. So velocity of object with respect to the mirror is equal to negative of velocity of image with respect to the mirror. Now this is just relative motion. I've just basically broken it up. So VO minus VM is equal to negative of VI minus VM. Just do the calculation over here. You'll get the formula. This is the formula with respect to ground. Now, even if you don't understand this, what you can do, you can basically memorize this formula. What is the formula? VO, that is velocity of object, plus velocity of image is equal to twice of velocity of mirror. Clear? Okay. Okay. Yeah, no need of derivation, but I wanted you all to understand the crux of this thing. I wanted you all to understand the crux of this thing. Okay. So this is the formula that you have to keep in mind. Okay. Is this okay, people? Is this absolutely clear for everyone? This is absolutely clear for everyone. Absolutely clear for everyone. Okay, clear? Can I get some fire in the chats if you have understood this? Okay, very good, very good. Now let's solve some problems. What is the formula, people? VO plus VI is equal to 2 times of VM. Object plus image is equal to 2 times of mirror. Okay, object plus image is equal to 2 times of mirror. Let's solve it. Let's solve it. Okay. So as this is velocity, this is a vector quantity. It's a vector quantity. So you have to assign directions over here. You have to assign directions over here. So I'm going to consider this direction as positive and I'm going to assign this direction as negative. Okay. This direction as negative. Very okay. Very, very clear, sir. So velocity of object plus velocity of image is basically 2 times of velocity of mirror. This is exactly that you have to use the formula. This is the formula. What is the velocity of object, sir? It is at rest. So this is 0. Okay, sir. This is 0. Plus velocity of image, sir. That is exactly what we have to calculate. That is exactly what we have to calculate. Let's assume that this is image over here. Hai na? That is exactly what I have to calculate, is equal to 2 times of velocity of mirror. Velocity of mirror is over here in the positive direction. So this becomes 2 into 2. So VI becomes 4 centimeter per second. And as this is positive, it will travel in this direction. So the velocity is basically in this direction. In this direction with 4 centimeter per second. Clear? Clear? Clear, people? Draw the second diagram. Draw the second diagram. Draw the second diagram. So over here, one more thing. One more thing, people. One more thing. One more thing. Before you solve the second diagram, I have to make you understand one thing. I have to make you understand one thing. See this, okay? Very, very important. Very, very important. Okay? Okay, very, very important. See this, people. This is a plane mirror. This is a plane mirror. This is a plane mirror. If you notice, see this, very, very important to understand. This is the plane mirror. This is x-axis. This is y-axis. And this is z-axis. Again, this is x-axis, that is perpendicular to the plane of the mirror. This is x-axis. This is y-axis. And this is z-axis. Okay, see this. If I move parallelly to the plane of the mirror, that means if this is the pen, if I move in the y direction or if I move in the z direction, are you all able to see the image also has the same velocity? The image also has the same velocity. See this? Okay, it's very difficult to, yeah. See this? It's very difficult to understand. Okay, yeah, see this. In the y direction or in the z direction, the velocity of the image is also same. Are you all able to understand this? Are you all able to understand this? See this? In z direction, also you are able to see the image. You are able to see the image, right? Image also has the same velocity. And in the y direction also same velocity. Y direction also same velocity. Yes or no? Yes or no? Yes or no? But in the x direction, it has different velocity. X direction, it has different velocity with respect to the mirror. Are you all able to understand this? Are you all able to understand this? So, what I mean is, any velocity in the plane of the mirror will be same. Not everywhere same, not everywhere it's not same, everywhere it's not same. Any velocity in the plane of the mirror would be same. Any velocity in the plane of the mirror. So, if this is the plane, this is a plane. So, in this direction or in this direction, in the plane of the mirror, the velocity would be same. Velocity would not change. But in x direction, in the perpendicular direction, it's going to change. In perpendicular direction, it's going to change. Perpendicular direction, it's going to change. So you can also write it as a point over here that this is perpendicular to the principal axis. Perpendicular to the principal axis or perpendicular to the plane of the mirror. So see, If you have drawn this, not understanding, don't worry. Don't worry, don't worry, don't worry, don't worry, don't worry, don't worry. With the help of this problem, you will understand. See this? See this? So this is the plane mirror. This is the plane mirror. Something like this. It's kept something like this. है ना? It's kept something like this. Something like this. Object is going something like this. Object is going something like this. So the image also. Without any formula, you can write this is the image. It will also go 1 centimeter per second. It will also go 1 centimeter per second. Clear? Now are you able to understand it? Now are you all able to understand this? The formula you have to apply. The formula you have to apply if you are moving perpendicular to the plane of the mirror, perpendicularly in this direction or in this direction. If you are moving in this direction, in this direction, in this direction, then you don't need to apply. Don't need to apply. If it moves in this direction, this direction, this direction, this direction, you no need to apply. If it moves in this direction or in this direction, you have to apply it. Okay, clear? Clear? Okay. Okay, so you have understood this. Okay, you have understood this. Moving on. Okay, this is the question. So obviously in this question you have to basically use the formula. And you have to use the formula because the object is moving perpendicular to the plane of the mirror. है ना? What is the formula? So the formula is velocity of object plus velocity of image is twice of velocity of mirror. This direction is positive, this direction is negative. Very good. Sir, velocity of object is 1 centimeter over this in this direction. So this is plus 1. Velocity of image, that is something that I have to calculate. Plus Vi, which is equal to twice of velocity of mirror. Velocity of mirror over here. So this becomes 2 into minus 2 because it's traveling in this direction. So this becomes minus 4. 1 goes over there. So Vi becomes minus 5 centimeter per second. Minus 5 centimeters per second. That means the image is going to travel in this direction. In this direction with 5 centimeter per second. 5 centimeter per second. Clear? Clear? Yeah, please draw this diagram. This is the last question. This is the last question of this topic. Last question of this topic. है ना? Last question of this topic. Last question of this topic. See this. Very, very, very important to understand. So the image would be over here. Image would be over here. है ना? This is the object. Now, before we do that, we have to break them. We have to break them into corresponding perpendicular vectors. है ना? So see this. This is 10, 53. So this becomes 10 cos 53. है ना? Yavar sir has already taught you. 10 cos 53. And this is 10 sin 53. This is 10 sin 53. Now you need to remember what is cos 53, what is sin 53 and everything. Even if you don't remember, it's very easy to calculate. This is a right angle triangle. है ना? This is 37. So this is 53. है ना? This is 4, this is 3 and this is 5. You need to have this in your mind. You need to have this in your mind. Okay. Simple people. Now see. This 10 sin 53. How much is 10 sin 53? Sin 53 is opposite by hypotenuse. That is 4 into 5, right? Sorry, 4 by 5. So 10 into 4 by 5. That is how much? 8. So this becomes 8 over here. है ना? 8. 10 cos 53. What is cos 53 people? 3 by 5. है ना? So 10 into 3 by 5. So this becomes how much? 6. है ना? 6. Yes, this becomes 6 over here. This becomes 6 over here. Now, it's very easy. It is moving upwards with 8. It moving upwards with 8. So obviously this image will also move upwards with 8. Upwards with 8. We don't have any problem with that. No need of formula. No need of formula. We don't need any formula. We only need to use formula when it is traveling in this direction. In this direction. Okay. Now, in this direction it is traveling with 6. Now we need to use formula. It is velocity of object plus velocity of image is 2 times of velocity of mirror. What is velocity of object? 6 in this direction. So it is plus 6. Plus velocity of image is equal to 2 times of velocity of mirror. In this direction it is moving. So 2 into minus 1. Yes or no? Yes sir. So velocity of image comes out to be minus 2 minus 6. It comes out to be minus 8. it comes out to be -8. That means it is traveling in this direction with 8 meter per second, or 8 centimeter per second. 8 centimeter per second. So what should be the resultant? What should be the resultant velocity? Obviously, the resultant velocity would be something like this, and it would be equal to 8 root 2. This is something which I've already learned in vectors. This is something that you have already learned in vectors. Simple. 8 root 2. Understood? Understood, people? Understood, people? Yes or no? Clear? Are you all able to understand this? Are you all able to understand this? Yes or no? Yes or no? If you have understood this, some fire in the chats. If you have understood this, some fire in the chats, people. Fire in the chats. Okay. Now, one more type of question that may come, can come, will come in your exams. है ना? Sir, how 10 cos 53? This is 10, nobody. This is 10. This is 10 cos 53. This is 10 sin 53. As resolution of vectors, please revise it. Okay. Very good. If I start now, can I get 560 plus? Yes, you can, but you need to do a lot of hard work. You need to do a lot of hard work. Okay. One type of question that may come in your exams. What is the question? Find the distance of images formed from mirror M1. Formed from mirror M1. That means this is mirror M1, this is mirror M2, and object is kept over here. The distance between both the mirrors is 10 centimeter. And is 10 centimeter, and I'm going to call this something called as D. The distance between the two mirrors is 10 centimeters. This is 2, this is 8. Okay. Okay. Now I need to find out the distance of images formed from mirror M1. So what are the number of images that will be formed? Infinite number of images. Number of images will be infinite. है ना? Number of images will be infinite. Obviously, all the boys will relate over here. है ना? All the boys will relate over here. Whenever you go to barber shop and everything, they have two mirrors, no? They have two mirrors, and obviously you are able to see infinite number of images which are getting formed. Same case over here. Same case over here. And an infinite number of images will be formed, but you need to tell me the distances at which our images will be formed. Distances at which images will be formed. Okay. Someone is speaking. Arey yaar, who is it? Just a sec. Same case. Yeah, I think other people are taking classes. That is the reason only some of their voices are coming, है ना? अच्छा, why only boys? Girls can only. अच्छा, ठीक है, चलो, है ना? I mean, that is the only example that comes to my mind. Barber shop. So yeah, है ना? Okay, see this. How to calculate this, people? है ना? How to calculate this? This value, this 2 centimeter is A. है ना? This A is equal to 2 centimeter. I'm just assigning values. And B is basically equal to 8 centimeter. B is basically equal to 8 centimeter. Okay. Now people, see how to calculate it. I'll basically tell you first how to calculate it, then I'll give you the logic behind it. Okay. Then I'll give you the logic behind it. Okay. First let me show you that how to calculate it, and then we'll see the logic. Okay. Just a second. Okay, see this. See this. Okay. First of all, write A over here. And write A over here. Write B over here. Okay. Then write B A over here. And write A B over here. Okay. Then write B plus D. This becomes 2D. This becomes 3D. And this becomes 4D. This becomes D, this becomes 2D, this becomes 3D, and this becomes 4D. Okay. Now, let's calculate. Let's calculate. This is easy. Let's calculate. The value of A is 2. The value of D is how much? 10 centimeters. Value of B is 8 and value of D is 10 centimeters. Let's calculate. B plus D, what is B? B is, sir, 8 and plus 10, so this becomes 18. Very good. Sir, A, what is A? It is 2. 2 times of 20, so this becomes 22. Hai na? 2 plus 22, 22. B, what is B? It is 8, sir. 8 plus 30, that becomes 38. Now, see this pattern, no, those? See this pattern. See this pattern. 1, 2, 3, 8, 2, 8. So the next one will be 42. You can check it. You can check it. A is how much? A is 2. 2 times of 40, that is 42. 2 plus 40 is 42. Similarly, over here, A is 2. So 2 plus 10 becomes 12. B is 8. 8 plus 10. 8, no. So 8 plus 20, this becomes 28. This, see the same pattern. 1, 2. So this is 3 and this is 4. 2, 8, 2, 8. Khatam. Khatam. Yes or no? 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 This is how you can calculate. This is how you can calculate. So these are all the distance of images from the mirror. Distance of images from the mirror. This is how you calculate. Clear? Clear? Clear, 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 clear. Please note it. Please note it. Please note it. Please note it. Very, very important. Okay. Very, 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 very important. Can I move ahead, people? Can I move ahead? Can I move ahead? Very important. Can I move ahead? Yes, infinite number of images. Obviously, you can write more. Hai na? You can write more. You can write more. That is something that you know. Hai na? Now, people, we have completed spherical. We have completed plane mirror. Everything about plane mirror, I have told it to you. Everything about plane mirror. And I hope so you have understood it. If you have understood it, fire in the chats. Now we are going to start spherical mirrors. Okay. Now we are going to start spherical mirrors. We're going to start spherical mirrors. People. Now, okay, you want to copy? You want to copy? You can copy. Okay, you can copy. Yeah, see this. Now we are going to start spherical mirrors. Okay, spherical mirrors. People, I'm going to tell you. I'm going to teach you spherical mirrors in a very, very interesting way. In such a way that nobody else has taught. Okay. So even if you know nothing about spherical mirrors, if you are confused about sign conventions, just reset your brain and sit in this class, solve numericals with me. I'll assure you that after this ray optics class, you are going to love this chapter. You're going to love this chapter. Okay. You can love this. You are going to love this chapter. Okay. Okay. Let's move ahead and let's start with spherical mirrors. Okay. Yes, you can do more distances, people. You can do. Now, I have just written 4 over there. You can write till infinity. Okay, don't worry. You can write till infinity. Okay, chaliye. Let's start. What is spherical mirrors? Spherical mirrors. So obviously there are 2 types of spherical mirrors. Hai na? There are 2 types of spherical mirrors. That is concave mirror and convex mirror. What is a concave mirror? If the inside surface of the mirror is polished, it is a concave mirror. What is a convex? If the outside surface of a mirror is polished, it is a convex mirror. Hai na? Yes, atoms, nuclei completed in modern physics. Okay. No, advanced questions are not necessary to do, but there are some advanced questions that are necessary to do. You need not do every advanced question out there, but you need to do some questions out there. Okay. Approx duration 9-10 hours. 9-10 hours. Okay. So see this, people. This is a concave mirror. This is a concave mirror because see this. This is the polished side. See, it is like a cave, right? It is like a cave. So this is concave mirror. Okay. This is a concave mirror. Over here, the polished side is at the outer surface. The polished side is at the outer surface. So this is a convex mirror. This is a convex mirror. Hai na? So concave mirror, convex mirror. This is called as the focus. This is called as the center of curvature. Hai na? You can also write this as capital C. This is the focus. This is the center of curvature. At the same time, this is the focus. This is the center of curvature. Don't worry, we'll be looking upon each one thing in a very detailed manner. Don't worry. I'm just basically revising all the simpler concepts for you all. Hai na? This is the principal axis and this is going to be the x-axis in our questions. Okay, this is going to be the x-axis in our questions, the principal axis. This right over here is the origin or the pole, है ना? Origin or pole of the mirror, है ना? Origin or pole of the mirror. Okay. Okay, people. ठीक है? ठीक है. I think so. You have understood this. Now, people. Now, tell me, how many of you all have problem with sign convention? Sir, this sign convention I'm not able to understand, sir. I know the formula, I know how to apply it, but I am very much confused about sign conventions. When it is minus, when it is plus, I'm not able to understand. How many of you all out here have confusion with the sign? I want to know. But I assure you, after this, just give me 10-15 minutes and you will be master in sign convention. You will be masters in sign convention. Okay. Me, sir, first attendance. Okay. Me, okay. Yes, sir, I have. Okay. Okay. You know, I've already told you, just reset your brain, forget everything that you know. I am gonna tell you one way, and that is gonna be the most best way that you will be able to understand sign conventions. Okay, chaliye, let's understand. Always it's a headache. Let's understand. Okay, see this. Okay, let's understand. People, sign convention always, and this convention is valid for mirror, this is valid for lens, this is valid for refracting surfaces, everything. Whatever I'm going to say, this is valid for everything. Refracting surfaces, lens, mirror, slab, everything. है ना? Anything that you have, it's valid for everything. है ना? It's valid for everything. Okay, see this. Sir, I have a concave mirror over here. है ना? Now, always look for the incident ray. Always look for the incident ray. Now, people, see this. What do I mean by this? Now, the pole is always the origin. So, if this is the pole that I'm talking about, just let me just draw it in a much more good manner. Yeah, this is the pole. Okay, this is the pole. So, this is the pole. This is pole, and this is always the origin. This is always 0, 0. This is always 0, 0. Okay, now always look for the incident ray. That means, sir, if the incident ray is coming in this direction, the head of the arrow points towards the positive direction. That means all of the things which come in this direction are going to be positive. All of the things which are coming in this direction automatically will be negative. That's it. That is the rule. Just look for the head of the incident ray. Wherever is it pointing, that is positive, and the other direction is going to be negative. That is it. Simple. I'll tell you again. Over here, this is convex mirror, this is the pole. So this is going to be origin 0, 0. Sir, incident ray is coming over here, sir. This is the incident ray. Arrow head is pointing towards that side. So this is positive and this is negative. That's it. This is incident ray. Sir, what if I invert this convex mirror, sir? What about that? No problem. I'll tell you. Sir, what about this case, sir? Something like this. This is your mirror, sir. This is your convex mirror, and this is your principal axis, sir. Right now, and so this becomes your pole, no, sir? है ना? This becomes your pole. This becomes your origin 0, 0, sir. What about in this case, sir? No problem. Just look for the incident ray. So incident ray is coming in this direction. Where is the head of the incident ray? Sir, in this direction. This is positive, this is negative. That's it, people. That is sign convention for you all. Look for the incident ray. Where is the head of the arrow pointing? That is your positive direction, and the other automatically becomes your negative direction. If you have understood this, fire in the chats, people. If you have understood this, fire in the chats. Doesn't matter. It doesn't matter how the mirror is getting oriented. Doesn't matter. Just look for the incident ray. Where just look where the head of the arrow is getting pointed out. That direction is your positive and the other direction is your negative. Simple. Don't worry, we're going to use it in our questions. You'll be able to understand it much better. Okay? See this. So you don't have to basically confuse yourself. So no, so this is 0, 0, this should be positive, this should be negative. No. That is not the rule. That is not the rule. That is not the rule. The rule is that you have to look for the incident ray. The head of the incident ray points towards the direction. This is not positive direction, this is not negative direction. Now, if incident ray is coming from this side, this is positive, this is negative. Case over. Case over. Don't worry, if you want that I should repeat it, don't worry. There are hundreds of numericals coming up. Don't worry, I will be solving it. Okay? Don't worry. Hai na? Now people, now let us talk about the mirror formula. Okay, when is the dinner break? I'll give you dinner break around 9:30. Okay, I'll give you dinner break around 9:30. Okay, but before that, see people, I'll tell you. Okay, some around 9 o'clock. Okay, I'll give you around 9 o'clock or something. Okay, people, see, I'm telling you, if you understand a mirror, you know, if you understand mirror, you have already understood lens. Trust me on this. Just trust me on this. If you have understood mirror, you have already understood lens. And if you have already understood lens, then obviously you have understood refracting surfaces. Just trust me on this. Just trust me on this. Okay? Okay? See this. People, the formula. What is the formula? The mirror formula is 1 by V plus 1 by U is equal to 1 by F. Sir, do you even use this formula? I'm not a fan of this formula actually. And honestly speaking, I'm not a fan of this formula. I'm not a fan of this formula, or I can even write it as 2 divided by R. I'm not a fan of this formula. So, sir, which formula do you use? I use a different formula. Just basically manipulation of this formula. The formula that I use is V is equal to oof divided by oof. This is the formula that I use. This is the formula that I use. Oof divided by oof. This is the formula that I use. It's the same. It's the same. Even if you rearrange this formula, you'll get this. I don't like using this because you have to take reciprocal, you have to take that and this. Very time consuming. I like this formula. I like this formula. But if oof, this is oof, right? Oof, oof, uf, oof. है ना? So oof divided by oof. Okay. So oof divided by oof. But yeah, with a negative sign, है ना? So why bother taking reciprocal and everything? You know, just put all the values inside and you'll get the value, है ना? But है ना? Yep, oof the best though, है ना? So see, even if somebody is comfortable with the first formula, I don't mind. You can use that formula, है ना? But I'm going to use this formula. Okay, I'm going to use this formula. Okay, okay, people. Okay, and also one more relation that you all know and you have already studied in your previous classes, that F is basically R by 2. है ना? You have already studied this in your previous classes. Not going to repeat it. है ना? Already studied in your previous classes. Very easy thing. Very easy thing. Okay. Now, people, you don't have to remember all of this. You don't have to remember all of this. I'm going to basically say, I'm going to basically make you understand. Physics is not just about remembering things. It's actually nothing about remembering things. It is about understanding things. Okay? Okay, chaliye. People, first tell me what is this U, what is this V, what is this F? What is this U? What is this V? What is this F? What do you? I just want to know, because I want to basically delete this huge misconception about this formula. What is this U? What is this V? What is this F? Okay, very good. You can become an ophthalmologist, है ना? Okay. Tell me, people. Tell me. What is the meaning of U, F, and everything? What do you mean by this? Image distance. Akshita, you're wrong. Vagisha also wrong. Akshita wrong. 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 What is U, V and everything? Wrong. Anybody else who wants to try? Anybody else who wants to try? No. I understand it is object or something. I want to understand object distance. Shiva, you're also wrong. Shiva also wrong. It is wrong. No. You can't be object. No, it has to be something that is of length, distance. What is it? Like, what is it? I'm talking about. Wrong. Okay, see this. I'll tell you, people. People, you have already studied it in your kinematics. You have already studied it in your kinematics that distance can't be negative. You have already studied that in your kinematic, that distance can't be negative. But we are getting values, sir. V is equal to -2, U is equal to -2 and everything. So obviously U and V and F and R are not distances. They are not distances. They are not distances. Exactly. Sujay is right. Absolutely right. They are not distances because they can't be negative. They are basically x coordinates. They are basically x coordinates. They are coordinates. Coordinates can be negative. X coordinates of object. X coordinates of object. Very important point, people. Very important point. Very important point. What is V? It is again x coordinate. It is again x coordinate. But of image. But of image. But of image. Yeah, it is. So similarly, x coordinate of focus, and this is x coordinate of center of curvature, COC. I told you I'm going to clear a very big misconception. It is not distance, people, it is coordinate. And that is the reason you make mistake in your sign conventions, because you have understood that these are distances. These are not distances, these are coordinates. These are coordinates. Are yes or no? Are yes or no? Did you all understood it? Did you all understood it? Yes or no? Please mark it. Please mark it in your notes that these are not distances, these are coordinates. These are coordinates. Okay. Okay. Now, people, just some revision of your 10th class, है ना? Just some revision of your 10th class. If any ray is parallel to the principal axis, it will pass through the focus. If any ray passes through the focus, it will pass through the parallel to the principal axis. If it passes through the center of curvature, it will retrace its path. Why it will retrace its path? Because it is forming 90-degree over here. Principle of reversibility. Principle of reversibility. है ना? Why is it retracing? Because if it passes through center of curvature, it will strike the mirror at 90-degree. That is the reason it retraces its path. Next, if it strikes the pole, then angle I equal to angle R. है ना? Simple. We all know. Yes or no? Very good. Very good. Now let us learn a little bit more about sign conventions. है ना? Let us learn a little bit more about sign conventions. See this, people. Now you will not have any problem whatsoever. You will not have any problems whatsoever. If this is concave mirror, है ना? If this is concave mirror, I'm gonna also draw a concave mirror, something like this also. Something like this. This is also concave mirror. This is also concave mirror. And one more mirror, convex. Let me draw a convex mirror for you. No, this is not convex. Okay. Now you are going to do. Now you are going to do it. I am absolutely sure that you have understood it. Now you are going to do it. See this. Sir, very simple, sir. Very simple. Very simple, sir. So this is concave mirror. So focus is over here, sir. है ना? Sir, focus is over here, sir. And sir, center of curvature will be over here. है ना? This is center of curvature. Okay, sir. Sir, this is something like this. So this is also concave mirror, sir. Sir, focus will be over here. है ना? Focus would be over here. Center of curvature over here. Okay, sir. Sir, this is convex mirror, sir. So, sir, very simple, sir. So this is focus over here. Center of curvature over here. है ना? Okay. Okay, clear? Now, see this, people. How to do it? Sir, incident ray is in this direction. So this is negative, this is positive. The head of the arrow points towards the positive direction. So automatically focus becomes over here minus r by 2 comma 0. This is your coordinate. Similarly, center of curvature becomes minus r comma 0. Is it clear? Is it clear? Now you will not make mistake in your sign conventions because you have understood it right now. You have understood it right now. Over here, this is also concave mirror, but incident ray is in this direction. Incident ray is in this direction. This becomes negative, this becomes positive. This becomes negative, this becomes positive. So right now this becomes minus r by 2 comma 0. This is minus r comma 0. Sir, convex mirror, sir. So convex mirror, incident ray in this direction. This is negative, this is positive. So this becomes r by 2 comma 0 and this becomes r comma 0. Radius of curvature, no? R is radius of curvature. Radius of curvature. Radius of curvature. People, can I get some fire in the chats? I know you have understood it. I know you have understood it. Can I get some fire in the chats? Can I get some fire in the chats? See, even in concave mirror, even if the orientation is like this or like this, doesn't matter. Just look for the incident ray and that's it. I know you have understood it. I know you have understood it. I know you have understood the sign conventions now. Yes, Nandini, what happened? What happened? Didn't you understood it? Yes, you have not understood it yet. Just look for the incident ray where the head of the incident ray is. That is your positive and the other is negative. That's it, clear. Yeah, I will teach. Don't worry. I will teach solids, fluids, everything for you. Don't worry, है ना? Again, I'm just repeating it. This is concave mirror, incident ray in this direction. So this is positive, this is negative. So every coordinate in this direction is negative. So minus r by 2 comma 0, minus r comma 0. Over here, incident ray is over here. So this is negative, this is positive. So every coordinate is going to be negative over here. Minus r by 2 comma 0, minus r comma 0. This does not mean that this is positive direction, sir. No. Who said this is positive direction? You have to look for the incident ray. Sir, incident ray is in this direction. So in minus over here, plus over here. So every coordinate over here would be positive. Would be positive. Clear? 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 Now, if you have understood this, people, now I can come back over here. Now, I just want you all to just keep in your mind. I'm not even asking you to memorize. You will be able to understand the logic behind it. Don't worry. Just give me 15 more minutes. You will be able to understand. I just want you all to basically just keep it in your mind that if you get the V negative, if you get the value of V as negative, that is the image coordinate as negative, it will be a real image. If you get it as positive, it will be a virtual image. That's it. That is the only thing that you have to keep in your mind. Why? You will understand the reason. Just give me 15 minutes. Just give me 15 minutes. You will be able to understand the reason. Just 15 minutes. But just for right now, if V comes as negative, is a real image. If V comes as positive, it is virtual image. That's it. Ready for some problems? Ready for problems, people? Are you ready from problems? Problems nu vendittu thayyarano. Problems vendittu thayyarano. Namukku ipo problems cheyam. Okay, let's do some problems. First one. Don't worry, I'll be very slow. Okay, don't worry, I'll be very slow. See this. Sir, this is a concave mirror. This is concave mirror. Object is over here, sir. So if object is over here, incident ray is in this direction. So this is positive over here, this is negative over here. हाँ sir. So this is radius of curvature is 40 centimeter. है ना? Radius of curvature is 40 centimeter. So that means center of curvature will be at 40. Center of curvature will be at 40. So this is center of curvature. So focus will be over here. focus would be over here, and center would be over here. Yes or no? And what would be the coordinate, people? What would be the coordinate? Negative direction, no? So this would be just half of it. So this becomes minus 20, 0. And this becomes minus 40, 0. That's it. That's it. That's it. Clear? Clear? Clear. Now let's try to find out the image. Let's try to find out the image. What is the formula? V is equal to oof by oof. V is equal to oof by oof. है ना? V is equal to oof by oof. This is the formula. Or you can use 1 by V plus 1 by U is equal to 1 by F. No problem. No problem. Okay. U, what is U, people? What is U? Coordinate of U is going to be what? Sir, minus 50, 0, sir. Minus 50, 0. Minus direction, minus 50. So this is minus 50 for you all. Into focus X coordinate, minus 20, divided by U. U is how much? Again, minus 50, minus. Focal length is how much? Minus 20. So minus, plus. It becomes plus over here. So this becomes 5 2s are 10. And this becomes minus 50 plus 20. Minus 50 plus 20, no? Minus 30. Minus 30, cutting, minus 100 by 3. Minus 100 by 3. Yes or no? So we are getting the value of V as minus 100 by 3 centimeters. Or I can even say this is minus 33.33 centimeters. Now, as this is negative sign, what does this negative sign mean, people? Negative sign means that this is a real image. A real image. Real image. How 30? U minus F. No, people, this is U minus F. U is minus 50. Focus is minus 20. So minus 50 minus 20. So this is plus 20. Real image. Now, how did we find it out? Now, if you want the ray diagrams, you can even draw the ray diagrams. No problem. You can draw the ray diagrams. Sir, how to do it, sir? Simple. Object is at minus 50. So, you are getting image at minus 33.3. So, somewhere over here, you are getting the image. So, this is the ray diagram. Something like this. Like this. Yes. This is the ray diagram that you will get. This is the image. This is the image. Clear? Yeah, don't worry. I have a lot of questions. Don't worry. This is just the start. But I hope so you are able to understand the sign conventions right now. Okay? I hope so you are able to understand the sign conventions. Clear? Is it clear, people? Okay. Let's go. R is equal to 40. Okay. Object is right now at 30 centimeter, people. Sir, very easy to understand, sir. Okay. Sir, incident ray over here, sir. So this is negative, this is positive. The head of the arrow points towards the positive side. Okay, sir. Sir, radius of curvature is 40, sir. That means if this is 30, the center would be here, something like over here. No, this is the center. And focus would be over here. Focus would be something over here. This is the focus. This is center and this is focus. Somewhere at 20. Sir, what would be the coordinate, sir? Coordinate is very easy. Everything in negative. So minus 40, 0. And over here, focus would be minus 20, 0. And what about U? U is, what is U? U coordinate. It is minus 30, 0. Simple. Chalo, let's do V. What is V? Sir, V is equal to oof divided by oof, but with a negative sign. Oof by oof. Sir, what is U? U is minus 30, sir. Sir, what is F? F is minus 20, sir. Very good. What is U? U again is minus 30. No, minus 30 minus 20. Khatam. So 3 2s are 6. This becomes 600. And this becomes minus 30 plus 20. So minus 10. So this becomes minus 60. Minus 60 centimeter. Now, what does this minus mean? Minus means, sir, real image. Minus means real image. Clear? Clear? Very good, very good, very good. I think now you are able to understand sign conventions. I think, no, it's not a virtual image, it's a real image. It's negative, no? It's negative. It's negative. Okay. So minus 60, sir, this is 20, minus 30, minus 40. So image will be somewhere over here. Image is over here, minus 60, 0. This is the image. Sir, how did it form, sir? Arey, very easy, very easy. It goes over here and strikes something like this. Goes over here and strikes something like this. Image is formed. Clear? Yes or no? Yes or no? Do you want more problems? Do you want more problems? Do you want more problems? Sir, how 20? How 20? Arey, it's very easy to understand. How 20? See this, radius of curvature is 40, no? Radius of curvature is 40. So center will have minus 40, 0. Focus is just half of it, so minus 20, 0. More problems? Do you want more? Do you want more problems? Let's go to more problems. Let's go to more problems. Let's go to more problems. More problems. Chaliye, let's go. Okay, this is one more question. This is one more question. This is one more question. This is a good question actually. This is a good question actually. Many people, they don't understand what exactly is this. Many people, they don't understand exactly what is this. Okay, see this people. If you know, if you understand, don't worry. This is not some wrong diagram or anything. See this. This is a concave mirror. This is a concave mirror, but object is over here. Object is over here. Yes, it's a virtual object. It's a virtual object. You'll understand. You'll understand why it's a virtual object. Just give me some time. Okay, just give me some time. But sir, incident ray will come from here only, na? Sir, incident ray will come from here only. Yes, it will come from here only. Sir, this is negative. This is positive, sir. Yes, sir. Yeah, same. It's not same question. It's not same question. It is not same question. It is not same question. Okay. Okay. Sir, so we know if this is negative, this is positive. Radius is 40. So that means, sir, this is F and sir, this is C, sir. What would be the coordinate of F, sir? It would be minus 20, 0 and C would be minus 40, 0, sir. Okay, very good. Sir, what about object, sir? Sir, object would be at plus 20, 0. Plus 20, 0. Object. Okay. Now, formula. Oof by oof. Oof by oof. Chalo, oof by oof. So, V is basically oof divided by oof. Oof divided by oof. What is U, sir? What is U? Sir, U plus 20, sir. Right now it's plus 20. Oh, sir, F is minus 20. Oh, sir, U again 20. Sir, minus. F is again minus 20. So minus plus. Are yes or no? Are yes or no? Yes or no? So this becomes minus 400 divided by 40. Divided by 40. So this comes out to be minus 10. This comes out to be minus 10 centimeter. So that means I'm again getting a real image. I'm again getting a real image. Now I'll help you understand with a diagram. I'll help you understand with a diagram. Okay. I'll help you understand with it. But I hope so you have understood why it is 20, 0, not minus 20. Hai na? I hope so you understood it. Why is it plus 20, 0? Because it's in the positive direction. Positive direction. Positive coordinate. Hai na? See this. Now, how to draw? Now, see, it is in minus 10, 0, no? So, minus 10, 0, matlab image would be somewhere over here. This is your image. This is your image with minus 10, 0 as your coordinate. Okay? Now, how to draw, sir? How to draw? Arey Baba, very simple. Very simple. See, incident ray. Okay. Incident ray was something like this. Incident ray, just a second. This is your incident ray, something like this. And I'm going to extrapolate it. Extrapolate. Yeah. Yes or no? And one more. One more over here. Extrapolate. And then it goes over here. Khachak, khachak, khachak. Image. Did you all understood it, people? See this. Sir, intersection of incident rays is object, sir. But it's actually, is it actually meeting? No, it's not actually meeting. It's appear to meet. That is the reason virtual object. Virtual object. Virtual object. Then real image. Appear, their reflected rays are actually meeting. So real image. Yes or no? Yes or no? Yes or no? Yeah. Does it feel good? Does it feel good that, oh sir, now I'm able to understand, sir. Okay, sir, now I am able to visualize. Now I'm able to visualize. Now I'm able to understand. Very good. Very good, people. Very good. है ना? Yeah. Very good. See this. Now, one more question for you all. Now, this is a convex mirror. It's a convex mirror, sir. Convex mirror. No problem, sir. Convex mirror, concave mirror, no problem. Now we know what to do. Now we know what to do. Sir, very easy. Sir, incident ray is in this direction, sir. This is your incident ray. So automatically this becomes negative, this becomes positive side. Kya baat hai? Sir, this is convex mirror, sir. This is convex mirror. So obviously, sir, focus would be over here. So center of curvature would be over here. Sir, focus would be now pull. It is plus, people. It is plus. It is plus. So this is basically 20,0, and this would be 40,0. 20, 0, 40, 0. Yes or no? 20. No, not minus 40. Not minus 40. You have to understand it. Acha, object is at minus 40. Yes, Nandini, you're right about it. Yes. Just a second, people. I've just received some message or something. Just let me check. Okay. Now, sir, object, what about object coordinates, sir? Array simple. Object coordinate is minus 40, 0. Minus 40, 0. Calculate it. Come on. I want the answer. I want the answer. Now you know I've already solved 3 problems. Please solve it. Please solve it. Please solve it and give me the answer. Also tell me whether it's a virtual image or it's a real image. Also tell me the position. Tell me everything. Tell me everything. Come on. Come on, tell me everything. 13.3. Let's see. Let's see what is the answer. I don't know. I have not solved it yet. I don't know. I have not solved it yet. So I don't know. Please. Solve it. Solve it fast. Solve it fast. Virtual image, is that what you're getting? Let's see. Let's see. Sir, what is the formula, sir? Sir, formula, sir, is very simple, sir. Uff by uff. है ना? Formula is uff by uff. What about? क्या बात है? क्या formula है ना? Let's see. Sir, what is U, sir? U is minus 40. Okay, minus 40 multiplied by F. F is plus 20. Okay. Divided by U is again minus 40. Focus is plus 20, no? So this becomes plus 20, है ना? Minus plus, है ना? So this becomes 4 2s are 8. Minus 800 divided by minus 60, है ना? 0 0 cancel, plus cancel. So this is 2 3s are 40 by 3. 40 by 3 centimeter. Sir, this is plus, sir. So what does plus mean? Sir, plus means a virtual image. Yeah, obviously. Yes, everybody. Did everybody get this, people? Everybody. 40 divided by 3 is 13.33. Yes, you are right. Yes, you are right. Yeah, very good. Everybody has understood it. Matlab, image is somewhere over here, है ना? Image is somewhere over here. So this is your image. Sir, how will it form? Simple. It will go something like this, है ना? And appear to meet. Understood, people? Spherical mirrors confirm, done. Spherical mirrors confirm, ekdam. Yeah, full confidence, yes or no. Now, no more errors in sign conventions. No more errors. Make sure this sign convention which I've taught you is applicable everywhere, and I mean everywhere. Be it spherical mirrors, be it plane mirror, be it lens, be it slab, be it anything. Can I get some fire in the chats? Can I get some fire in the chats? Can I get some fire in the chats? Confirm. But people, who told you? Who told you that I'm done with problems? I have more problems. Don't worry, I have more problems. Yeah, ray optics is one topic. Theory is only 10%. Theory 10%, problems 90%. Okay? Okay. Okay, let's go. Chalo, let's start with transverse magnification or lateral magnification. है ना? Okay. Okay, let's understand, है ना? Let's understand what is transverse magnification or lateral magnification, है ना? How to remember, sir? How to remember what magnification, which magnification? You have to remember this by this T. Sir, what is this T, sir? Just make it ulta, है ना? Just make it opposite. Sir, what is transverse magnification? So, in transverse magnification, object is perpendicular to the principal axis. Is this clear? Is this clear? Okay. So, transverse magnification is basically the object is perpendicular to the principal axis. The object is perpendicular to the principal axis. Sir, what do you mean by that? Sir, what do you mean by that, sir? Arey, very easy to understand. Very easy to understand. See this. Something like this. If this is your concave mirror, hai na? If this is your concave mirror, this is your concave mirror. If this is your focus, if this is your center of curvature, okay, and I have an object over here, the image would be formed something like this. Okay, so this is U for you, hai na? This is U for you, and this is V for you, this is V for you, and this is height of object, and this is height of image for you. Okay, perpendicular, hai na? So see, object is kept perpendicular to the principal axis. That is the reason, that is the time you have to use transverse magnification. Very easy formula. That is, magnification is basically minus V by U, or you can use F divided by F minus U. I use both the formulas. Okay, I use both the formulas, so you can use any one of the following that you want. Okay, any one of the following that you want. And yeah, one more thing, that is height of image divided by height of object. This is basically the formula that you have to use. This is the formula that you have to use. Okay, clear? Okay, this is the formula. Now, sir, if it is cross C or right C, when yeah, see, this is cave, no, this is like cave, so this is concave, hai na? Okay, so F divided by F minus U, or height of image divided by height of object. Now, I know many of you all, just like you had problems in sign convention, hai na? You also have problems in understanding sign conventions of magnification also. Sir, what is this -2, sir? What is this +2, sir? What is the difference, sir? I'll tell you, hai na? Don't worry. Take care, I'll tell you. Okay, I'll tell you. See this. See this. If magnification, hai na? If magnification is positive and if magnification is negative, what does this mean? What does this mean? If magnification is positive, that means the image is erect. The image is erect. Sir, if it is negative, that means it is inverted. That's it. This is basically the use of plus and minus. That is basically, okay, that is basically the use of plus and minus. If it is plus, then the image is erect. If it is minus, then the image is inverted. Sir, what about then the magnitude? What about magnitude? I'll tell you. See, if magnification is greater than 1, if it is greater than 1, or magnification is equal to 1, or magnification is less than 1. Magnification is less than 1. Okay. In this case, you will get magnified image. You will get magnified image. Magnified. Okay. In this case, you will get same size. You will get same size. In this case, you will get diminished. Diminished. Clear? 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 So what does the sign indicate? What is the use of sign? The use of sign is only for erect or inverted. The image, if the image is erect or inverted, that's it. That is the only use of plus and minus. Then you have to use only the magnitude part of it. Only the magnitude part of it. If it is greater than 1, it is magnified. If it is equal to 1, it is same size. If it is less than 1, then it is diminished. Clear? Okay. Yes or no? Yes or no? Okay. Thick, chali. I hope so this is clear. I hope so this is very much clear. People, question for you all. Solve people. So what is the question? What is the question? Find the position, nature, magnification of the image. This is what you have to do. Okay, this is what you have to do. Hana? So you have to find out everything. You have to find out everything. You have to find out everything. Convex mirror, radius of curvature is given, height of the image is, height of the object is given, 20 centimeter away from convex mirror. Okay, find out everything. Chalo, let's start. Let's start. Hai na? You also should solve along with me. Draw the diagram, solve along with me and check whether if you are getting right or not. Okay, chaliye. Sir, simple sir. Incident ray in this direction. Incident ray in this direction. So this becomes negative, this becomes positive. Simple. Okay. Now I'm not going to use coordinate system and everything. Not going to write everything because now we have done enough practice. We have done enough practice. Okay. See this. I'm going to use V is equal to oof divided by oof. Okay. V is equal to oof divided by oof. Sir, U is minus 20. Minus 20. Hai na? U is minus 20 multiplied by focus. Focus is over here. No, focus is over here in the positive direction. So half of radius, that is 20 plus 20 divided by minus 20 minus 20. So this comes out to be minus 400 divided by minus 40, which comes out to be how much? I think it comes out to be 10 centimeter. 10 centimeter. 10 centimeters. Yes or no? Everybody got it as 10 centimeters. Now what does this 10 centimeter mean? So plus 10. This means it's a virtual image. Virtual image. Now magnification. Let us find out magnification. Magnification. Sir, magnification is basically, sir, minus V by U. Minus V by U. Hai na? It is already there in the formula. Okay, we have to keep in mind. Okay, minus V by U. What is minus V? Minus 10. This is minus 10 divided by U. What is U? What is U? U is minus 20, sir. U is minus 20. U is minus 20. So this comes out to be half. Half. First of all, what is the sign? Sir, it is positive, sir. So that means if this is positive, that means the image would be erect. The image is erect. Now you have to see whether it is less than 1 or greater than 1. Sir, it is less than 1. So that means the image would be diminished. The image would be diminished. Now by how much? By how much it would be diminished? So very easy. You already know that magnification is minus V by U, which is basically equal to height of image divided by height of object. Now this you have got it as 1 by 2. 1 by 2. Hai na? So height of image is basically equal to height of object divided by 2. This is what you are getting. What is height of object? Now one more thing, people. The upward direction is considered positive, the downward direction is considered negative. Okay. So height of object is plus 1 centimeter. So this is 1 by 2. So this comes out to be 0.5 centimeter. So height of image is half centimeter. Half centimeter diminished. Okay. So what would be the... Achha, it's a virtual image as well. Hai na? It's a virtual image as well. And it is getting formed at 10 centimeters. Hai na? So it would be somewhere around over here. This is 40. So this is, I guess this is F. This is C for you. This is 40, this is 20. It is forming a 10, no? Yeah, it is forming somewhere over here. This is the image that is getting formed. It is also erect. It is also erect, but half of this size, and a half. So half centimeter. This is the size, है ना? And it is erect. So how will be the ray diagram? The ray diagram is going to be something like this. The ray comes over here, strikes something like this, and yes or no? Clear? Ray will strike something like this. Little something like, and yeah, that is what we are going to get. Everybody? Yeah. Don't worry. Understood? Understood? Yes or no? Everybody? Those who were having problems with sign conventions, now are you comfortable with sign conventions? Are you comfortable with sign conventions? Yes or no? Tell me. Tell me. Now we are going to pick up speed. We're going to pick up speed. Yes or no? Yes, crystal clear. Very good. Now, okay, people. I'm just gonna give you just basically 3 minutes break. Okay. Okay. I'm just giving you a 3 minutes break. I'll just fill my water bottle and come. Okay. I'll just fill my water bottle and come. Just a 3 minutes break. Okay. Then we'll continue. Okay. Then we'll continue. We'll have break at 9 o'clock. Okay, people. I'll just fill my water bottle and come, and then we are going to continue because a very important thing. Okay, very important thing is going to come up. Break is at 9 o'clock. I'm already told you that because if I give you break, the momentum will get destroyed. Okay, the momentum will get destroyed. I need to have a continuous form over here, है ना? Then only you will be able to understand. Trust me on that. Okay, trust me on that. Just a 3 minutes break. I'll just fill my water bottle and come. Break at 9 o'clock because if I give you break now, the momentum will get destroyed. We need this momentum so that we can reach lens and everything. Okay, just 3 minutes break. Okay. Hello, 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 hello. Wish. Can you just confirm? Can you just confirm whether I'm audible or not? Am I audible? Am I audible? 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 Am I audible? Yes or no? Audible? Audible? Am I audible? Am I audible? Yes or no? Am I audible? Yes. Okay. Chalo, let's go. So people, now very important people. Now see this. See, it's very important. Okay. Now all the problems. Okay. Now all the problems that we are going to solve are not just for your practice, but is also for your analysis part. Okay, so it is also for your practice, it is also for your analysis part. Sir, why the analysis? Because I'm going to give you a trick, not a trick, actually it's a concept actually. Okay, actually I'm going to give you a concept by which you can solve ray optics numericals without even lifting the pen, just by visualizing. But for that, this practice part should be perfect. And then this practice part, we're going to analyze it and draw some conclusions, and these conclusions are going to be your concept by which you can solve any problem. Sir, how will I know the position of FC if only R and O is given? Joel, radius of curvature is 40 centimeters. What is radius of curvature? From pole till C, that is the distance. That is basically the distance. So this is 40, so center of curvature is 40 and half of it is focus, 20. Simple. Okay, clear? Can we move ahead? Can we move ahead? Very important people, very important, very important. Okay, now the analysis part. So we are going to start with the analysis. Okay, but for that just a sec people. Okay, now we're going to start with the analysis part. Okay, very important. ठीक है, चलो, let's. Okay, can you just give me some chats? I just want to see if the chat is working or not. Okay, Kirti. Okay, yeah, chat is working. Chalo, let's go. Question, people. Question. What is the question? You have a concave mirror over here. Object is at 50 centimeters. 2 centimeter height of the object. Radius of curvature is 20 centimeters. Okay. You have to find out everything. Position. Everything. Basically position, virtual, real, diminished, everything. है ना? You have to find out everything. Okay. You have to find out everything. Let's solve. Sir, incident ray in this direction, sir. So this is negative, this is positive, sir. Simple. है ना? Okay. Sir, let's use UF. है ना? So UF will be V is equal to UF divided by UF. है ना? Very good. Sir, U is in the negative direction, sir. So that will be minus 50. Minus 50, sir. Very good. Minus 50 multiplied by focus. Focus also in negative direction. How much? Half of this. That is minus 10. Minus 10 divided by. This is minus 50. This is minus plus. So this becomes 10. So this becomes 500 divided by minus 40. 0 gets cancelled out. So what are you getting? Are you getting minus 25 by 2? Minus 25 by 2 centimeters. So what does this minus mean, people? So this minus means that this is basically a real image. You are basically getting a real image. Okay? Hena, you are getting a real image. That's what all of you are getting. I want the answers in the chat. Hena, I want the answers in the chat. So this is V that you are getting. Hena, this is the V that you are getting. Sir, what about the magnification? Sir, magnification is going to be minus V by U. Minus V by U. Hena, minus is already there in the formula. Minus of V. So V is minus 25 by 2. So minus of minus will be 25 by 2. That is plus 25 by 2. Yes or no? Or you can write minus 25 by 2, that is V. And what is U? U is minus 50. U is minus 50. So this is minus 50. So this minus and minus gets cancelled out. Hai na? So 25 ones are 25 twos are. This becomes 1 by 4. This becomes 1 by 4. Yes or no? Okay, very good. So magnification is 1 by 4. Now what does magnification 1 by 4 means? Sir, first of all, sir, it is positive. So if it is positive, so that means it's an erect image. It's an erect image. So it is less than 1 also. So I can basically say we are going to get a diminished image. We are going to get a diminished image. है ना? Very good. So now what about the height of the image? Simple. It is very simple. I know that 1 by 4 is basically equal to height of image divided by height of object. है ना? So height of image basically becomes height of object divided by 4. What is height of object? It is 2 centimeters. So 2 by 4 becomes 1 by 2. Becomes 1 by 2. So this is basically the height of the image that you are getting. Height of the image that you are getting. So basically you are getting a real image, an erect image, a diminished image. That is what you are getting. है ना? Sir, how plus 1 by 4? See, no, this is 1 by 4, no? V minus V by U. What is minus V? Minus V is plus 25 by 2. So plus 25 by 2. है ना? And what is U? What is U? एक second. Just a second. So minus V is 25 by 2. Oh. Yeah, it should, I think it should be minus. I think it should be minus, right? I think it should be minus, है ना? Or are we right? Yeah, I think it is minus. Yes. It should be minus, है ना? ये 50 पे ना? Yeah, it should be minus. Yes, it should be minus. Yes, we did a calculation mistake over here, है ना? Yes. Very good, Thima. Yes, very good, है ना? Okay, let's solve again. No problem, है ना? It happens. Okay. Okay. So magnification becomes minus V by U. है ना? What is minus of V? It is 25 by 2. Minus plus. So this becomes 25 by 2. What is U? U is minus 50. So this is 20. This becomes minus 1 by 4. Yes, very good, Thema. Very good. है ना? Now this is negative, sir. So if this is negative, we are gonna get an inverted image. And as this is less than 1 also, we are gonna get a diminished image as well. Okay. Yes or no? Okay. This is what it is. Then height of image divided by height of object is basically equal to minus 1 by 4. So height of image becomes height of object divided by 4, but with negative sign. What is height of object? Plus 2 centimeters. So this is minus 2 divided by 4. This becomes minus 1 by 2 centimeters. What does this minus sign give? Minus sign is basically that it is ulta, है ना? It is downwards. है कि नहीं? Joel, I have already explained it very clearly. Please go back from the basics, from the sign convention. You will be able to understand. है ना? I can't repeat everything na multiple times. So yeah, height of image is minus half centimeter. So what does this mean? It means that where is the image getting formed? At minus 25 by 2. है ना? So if this is 50, this is 25. Okay, it's somewhere over here. This is where the image is getting formed, है ना? Minus 25 by 2, and this is where the image is getting formed. And it is basically a real image, inverted and diminished. Okay, it is going to be inverted and diminished, something like this. Yeah, this is the image. If this is 2 centimeter, the height would be half centimeter over here. Half centimeter. This is the height. Okay, how did it form? Very easy to understand. Tini, है ना? And tini, okay, something like this. Okay, and tini and tini. That is how it is being formed. Okay, clear people? Are you all able to understand it? Yes or no? Yes or no? है ना? Yes or no? है ना? See, I'm basically removing the ray diagrams over here. If you want to know, you can just basically note the ray diagrams, because I want to write something else. Okay, this is something what we are getting. That means, so R is 20 centimeter. R is 20 centimeters, है ना? R is 20 centimeters. So 20. So this is center of curvature, है ना? So let me assume that this is center of curvature, and this is focus. Focus should be at 10, है ना? Focus should be at 10. 12.5. Okay. Yeah. This is focus. This is focus. Yes, this is focus. Okay. Okay, people. So center. This is center. This is center is where? This is where? This is minus 20, 0. Minus 20, 0. And this is minus 10, 0. है ना? And image we are getting at minus 12.5. Minus 12.5. Okay. Clear? Clear? Can we move ahead? चलिए. Next. Second question. What is the second question? Everything is same. Everything is same. Just the object distance is at 30 centimeter. Object distance is at 30 centimeter. Okay. Object distance is at 30 centimeter. Object distance is at 30 centimeter. Let's solve. Okay, see this. See this. This is 20 centimeter. So center of, if this is 30, center of curvature would be somewhere over here. Yes or no? Yes, sir. If this is center of curvature, this is focus. Focus would be somewhere over here. है ना? Okay. So this is basically center of curvature. This is focus. So center of curvature, sir, incident is something like this: negative over here, positive over here. So this is center and this is focus. Okay, clear? Let's move ahead. So sir, V is equal to UF by UF. है ना? V is equal to UF by UF. What is U? Sir, U is in the negative direction, minus 30. Minus 30. Sir, focus also negative direction. What is it? 10. Minus 10. Na? Minus 10. Divided by minus 30 plus 10. है ना? Simple. This becomes 300 and this becomes minus 20. Yes or no? Cutting, cutting. So this becomes minus 15 centimeter. So what does this minus mean? Sir, minus means, sir, real image. Minus means real image. Yes or no? Minus means real image. Yes or no? People, I want answers in the chat. What is it? है ना? I want answers in the chat. है ना? This is not just me who is solving. I want you to solve. I want you to solve. No, this is a real image. Real image. Real image. Okay, real image. I want you to solve much faster because I want to understand if you are able to understand or not. Okay, okay, real image. Next, then sir, magnification. Sir, magnification is minus V by U, sir. Minus V by U. Or we can even use F by F minus U. You can even use that. No problem. No problem. है ना? So minus V by U. Minus of V. So minus of V will be plus 15. Yes, sir. Sir, U value is minus 30. Minus 30. So this comes out to be minus half. What does minus half signify, people? First of all, minus half signify that this is going to be an inverted image. Inverted image, and it is less than 1. So it's going to be a diminished image as well. It's going to be a diminished image as well. Very good, people. Very good. Very good. You are able to understand. You are able to understand. Very good. Now, minus half can also be written as height of image divided by height of object. है ना? So this comes out to be height of object is So height of object is basically, or not height of object, height of image, है ना? Height of image comes out to be minus of height of object divided by 2. What is height of object? Plus 2 centimeters, है ना? Plus 2 centimeters. So plus 2, so this is minus 2 divided by 2. So this comes out to be minus 1 centimeter. Minus 1 centimeter. Very good. Minus 1. What does this minus say? It is ulta. It is inverted. है ना? No, Akshita. No, Akshita. Why? See, what is, it is minus V by U, no? Akshita, the formula is minus V by U. What is the value of V? It is minus 15. So minus of V, minus of 15, minus of minus 15 would be plus 15. So plus 15 divided by minus 30. Okay. So that is basically what we are getting. So where are we getting the image? The image is at minus 15 centimeters. So see, this is, so see this. This center of curvature is at 20. This is 20, this is 10. So somewhere over here I am getting the image. I am getting the image somewhere over here. This is the image that I am getting. And how I am getting? This is 2 centimeters. So this will be 1 centimeter. 1 centimeter. And this is the image that I am getting. Okay. Yes or no? Yeah, you need more questions. Do you need more questions? If you need more questions, you need to say that yes sir, we need more questions. We need more questions. Okay, next. This is the question again. Now everything is same, only the object is at 20 centimeter. Object is at 20 centimeter. Object is at 20 centimeter. Chalo, let's solve. Sir, V is equal to UF divided by UF. है ना? Sir, this is negative, this is positive, है ना? Because incident ray over here, है ना? In this direction. U is minus 20, sir, है ना? U is minus 20 into. Sir, focus also in this direction, no? So that will be half, that is minus 10. Very good. Sir, U is minus 20 and this becomes minus plus 10. Very good. So this becomes 200 divided by minus 10. Cutting. So this becomes minus 20 centimeter. So this becomes, this minus means that what we are getting is a real image. Okay, very good. Now let's calculate the magnification. It is minus V by U. What is minus of V? It is plus 20. It will be plus 20 divided by U. U is minus 20 again. So the magnification is minus 1. Minus 1. Sir, what does this mean? First of all, what does minus mean? Minus mean inverted, sir. Sir, what does 1 mean? Sir, same size. This is same size, sir. Same size. So if see, you already know it's same size. So if you want, you can calculate, but okay, no problem, I'll calculate. Height of image divided by height of object is equal to minus 1. From here you are getting height of image is basically negative of height of object. That is what you are getting, है ना? So it would be something like this. See, R is at 20. So this is center of curvature. This is focus. And this is focus. You are getting at V as minus 20. So image is basically somewhere like this. This is your image. Exactly at C. Yes or no? Exactly at C. And same size. 2 centimeter. Exactly at C. Clear? This is also 2 centimeter. 2 centimeter. Same size. Yes or no? Very good. Yeah, I think you are all able to understand what I mean to say, है ना? People, please like the session. Yeah, more problems. Chalo, let's solve more problems, है ना? Everything is same now. Object is coming closer. 15 centimeters, है ना? 15 centimeters. Chalo, let's solve again. Sir, this incident, this direction, this is minus, this is plus. Chalo, let's solve. V is equal to UF by UF. So, sir, V is equal to UF divided by UF. है ना? So, what is U? Sir, U is minus 15. Focus also this direction, sir. That is minus 10. है ना? Minus 10 divided by minus 15 plus 10. This comes out to be 150 divided by minus 5. है ना? Minus 5. So this comes out to be minus 30 centimeters. Sir, what does this minus signify, sir? Sir, this minus signify this is real image. How same size? No. Who told you minus? See, Baba, I've already told you. If M is positive, then it is erect. If it is negative, it's inverted. Then forget about the sign. Forget about sign. Only magnitude you have to see. You have to see magnitude. Only magnitude. If M is equal to 1, then same size. M is equal to greater than 1, magnified. M is less than 1, diminished. Only magnitude you have to see. So, this is negative. So, that is the reason inverted. But magnitude is 1. So, same size. Okay? Okay. So, this is real image that we are getting. है ना? Real image. Okay, what about the magnification, people? Magnification is basically minus V by U. Negative of this is basically 30. 30 divided by U. U is minus 15. Minus 15. So this comes out to be minus 2. What is minus 2, people? First of all, minus 2. Negative sign means this is inverted. Then 2 is greater than 1. That means this is enlarged. It's not diminished. It's enlarged. It's magnified. It's magnified. Okay, yes. So it's enlarged. We are getting it enlarged. Yes or no? We're getting enlarged. 10. Yeah. Yes. Inverted and enlarged. Yes, it's right. It's right. Okay. Next, we know -2 is basically height of image divided by height of object. है ना? So what is height of image over here? Height of image will be -2 times of height of object. So -2 into height of object. It is 2 centimeter upwards. So this becomes -4 centimeter. Height of image is -4 centimeter. है ना? -4 centimeter. That means, sir, R is 20, sir. This is 15. So C is over here, है ना? C is somewhere over here, and so focus would be somewhere over here, है ना? Yes, focus would be somewhere over here, है ना? This is 10. This is 20. Where are we getting? -30. We are getting somewhere over here. This is the image that you are getting. Image would be double the size. No, double the size. We are getting double the size. Double the size. So something like this. Yeah, I think this is double. Yeah, I think this is double. Just invert it and damn. Yes or no? Clear? And what is the size over here? What is the size? This is basically 4 centimeters. No, Baba. Pallavi, I've already told you. You have to see. What does the sign mean? Plus means erect. Minus means inverted. That's it. Then forget the sign. Forget the sign. Only look for the value. Only look for the value. Okay? Only look for the value. Forget the sign. So over here also, minus means inverted. Then forget the sign. You have 2. So 2 is greater than 1, no? So it's enlarged. Over here, see this. Minus sign means inverted. Then forget the sign. Half is less than 1. That is the reason it's diminished. Now people, है ना? Now I want you all to understand, if u is equal to f, what about u is equal to f? Hey? Sir, u is equal to f. Sir, let us think, sir. Let us think. Sir, concave mirror. Sir, concave mirror. Principal axis. Radius of curvature is how much? It was 20, na? Yeah, it is 20. Radius of curvature is 20. So that means, sir, this is center. This is focus. This is focus. Object is kept at focus, sir. Sir, object is only kept at focus. Matlab, V is basically UF divided by UF. Sir, U is equal to F. Sir, if U is equal to F, this denominator is 0, sir. So, if this denominator is 0, I am getting V as infinity. I am getting V as infinity. Oh, matlab, if I keep the object at focus, the image is formed at infinity. The image is formed at infinity. Infinity. You'll get it at infinity. Yes or no? See this. Aisa? Infinity. Image is formed at infinity. Clear? U is equal to F. No, it's not diminishing. See, you can't comment about infinity. No, you can't comment about infinity. How will you comment about infinity? Huh? You can't comment about infinity, no? So just leave the magnification part of it. Last question, people. Last question, and then we'll start our analysis. Last question, then we'll start about analysis. We'll start analysis, okay? We'll start our analysis. Last question, and then we'll start our analysis. Okay, see this. Sir, R is equal to 20. So, sir, center of curvature, acha, theek hai. So, this is center of curvature over here. This is 20. So, 10 would be somewhere over here and in the middle. This is focus. This is 5. Okay, no problem. Chale, next. Sir, incident ray over here. This is negative. This is positive. Chalo. V is equal to UF divided by UF. Okay, U. What is U, people? -5. -5 multiplied by focus. Focus is also negative. -10 divided by -5 plus 10. This comes out to be 50. 50 divided by 5. That is basically plus 10 centimeter. Sir, what is plus 10 centimeter? Sir, virtual image. virtual image. Sir, sir, let's calculate magnification. No, okay. Minus v by u. What is minus v? Minus 10 divided by u. U is minus 5. Sir, magnification is 2, sir. Plus 2. Plus 2. Sir, what does plus 2 mean? Sir, first of all, it is positive. So, it is erect. We are getting erect image. Second, sir, it is greater than 1. So, it is enlarged also. Or magnified. Anything. Enlarged or magnified. Very good. Not minus 2. Not minus 2. It is plus 2. Plus 2. Plus 2. Plus 2. Now, height of image. Height of image divided by height of object is basically equal to 2. So you are getting height of image as twice of height of object. So what is height of object is 2 centimeters. So 2 into 2 is basically 4 centimeters. So you are getting the height of the image as 4 centimeters. Now people, v is plus 10. This is negative side. Plus 10 matlab idhar. Over here we are getting the image. Acha. Over here we are getting the image. Acha, matlab we are getting somewhere over here. We are getting somewhere over here. Yeah. Image. This is image for you all. This is where image is getting formed. So this is 10 centimeter from the pole. 10 centimeter from the pole. And it is erect also. It is erect also. Erect and double the size. Erect and double the size. Erect and double the size. Yes, something like this. And the height is basically how much? 4 centimeters plus. Now, everybody who is watching, sign conventions tick, formula tick, ray diagram tick, confusion X, no confusion tick. Fire in the chats if you have understood everything. And if you think, sir, this was everything, no, this was not everything. Now wait for the analysis part. I'm gonna blow your minds off. Okay, chalo. I'm gonna blow your minds off. ठीक है, ठीक है. Okay, this was nothing. This was nothing. Just wait for 15-30 minutes. Your concepts will go through the roof. Your concepts will go through the roof. Okay? Chaliye. Very good. Very good. Very good. Very good. Very good. Yeah. Are you all enjoying the session? Are you all enjoying the session, people? Are you all enjoying the session? Okay. Now, people. Now, whatever I'm gonna say or whatever analysis I'm gonna do is valid everywhere. Is valid everywhere. Okay? See this. People, this is, I'm taking an example of a concave mirror. But this is valid everywhere. Okay? So, see this. I want you all to draw this diagram. Okay? I want you all to draw this diagram. And also keep it as, you should have this in your front. Okay, you should have this in your front. What is it? So basically I have divided the whole plane into different parts. This is the concave mirror from plus infinity to C. Okay, just a sec. Okay, this is plus infinity, and this is minus infinity. Okay, this is minus infinity. Okay, now you have to understand, people. You have to understand. Okay, see, you have to understand in ray optics, minus infinity and plus infinity are the same thing. Like it's something like this. If this is minus infinity and this is plus infinity, it is something like this. It is something like this. You have understood it. Something like this. So if this is minus infinity and this is plus infinity, just overlapped over, and it's the same thing. Yeah. Okay, you have to understand it. It's the same thing. Okay. Okay, see this. So from infinity, plus infinity to C, it is region 1. From C to F, region 2. From focus to the pole, region 3. And from pole to the minus infinity, it is region 4. Regions 100% clear. Sir, one more time. From plus infinity to C, region 1. From C to F, region 2 or 3. From C to F, region 2. From F to P, region 3. And from P to infinity, P to minus infinity, region 4. Now comes the analysis part. Now comes the analysis part. See this. Okay? Are you all ready? Now I want you all to go to this question, the first question that we solved. The first question that we solved, that is after analysis part, the first question that we solved. First question. Okay, first question that we solved. See this? See this, people, see this. Very, very, very important, very important. Sir, this is, object is lying from minus infinity to C. Object is in region 1. Image is formed at region 2. Yes or no? Yes or no? Yeah, the murmuring voice will go after some time. Don't worry. What did I say? Object is in region 1. Image is in region 2. Sir, over here also. Object is in region 1. Image is in region 2. Yes or no? Yes, sir. Sir, now this is an interesting case. Sir, if the object is at center of curvature, image also at center of curvature. Next. Sir, if object is at region 2, image is at region 1. Just swap the things. I'll tell you again. See this. If it's very easy to understand. Very easy to understand. See this. If object is at region 1, image is at region 2. Always. If object is at region 1, image is at region 2. But if object is at region 2, image is at region 1. Just clear. Okay. Sir, what about, and in focus it is infinity. Sir, what about region 3? If object is at region 3, image will be at region 4. Are you all able to understand the analysis? And if you think, sir, did not understand, sir, I need visualization. I'll tell you visualization. I'll give you visualization. See this. I'll give you, don't worry, this is just a start. See this. Object at region 1, image at region 2. Object at region 2, image at region 1. Object at region 3, image at region 4. And object at region 4, image at region 3. So region 1, region 2, region 3, region 4. This is exactly what is it. Now, sir, more visualization. I'll give you more visualization. See this. If you want, you can open this website also. After the class, you can open the website. You can just type PHET geometrical optics. Just type in your Google PHET geometrical optics. Okay, and that is the first link that you can find. Okay, see this. Let's start with the visualization part. People, eyes on the board. Okay, eyes on the board. Very important thing. Very important thing. Now, whatever I'm gonna say, whatever I'm gonna say for concave mirror, it will also work for convex lens. What did I say? Whatever analysis I'm gonna do for concave mirror, it will also work for convex lens. Exactly the same. Okay, you can keep a note of it. Just a second, people. Just let me. Okay. This is your center of curvature. Okay, people, see this. Okay, see this. Very important. People, this is center of curvature. This is focus. This is pole. Now see this, very, very important to understand. Sir, object is at region 1, image at region 2. Object region 1, object region 1, 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 region 1. Array, center of curvature, both are same size, both are same size. Now see this, now see this. As soon as object comes in region 2, image comes in region 1, 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 image comes in region 1. See this, image comes in region 1, image region 1, region 1, region 1, region 1, and as soon as we reach focus, it reaches infinity. It reaches infinity. Now, object is at region 3, so image should be at region 4. See, it is coming from that side. I have already told you minus infinity and plus infinity are same. They are just overlapping. So the object is going to come from that side. Object is going to come from that side. People, I want you all to play this animation in your head. It's gonna make your life very easy. It's gonna make your life very easy. See this again. See this again. See this again. Center of curvature, focus. Okay. See this. Sir, region 1, object region 1, image region 2. Object region 1, image region 2. Same. Okay, done. Then center of curvature. As soon as object is in region 2, image is in region 1. Image in region 1. Okay. At focus, it is at infinity. It is at infinity. Minus infinity plus infinity, jo bhi ho. Nah, it doesn't matter because it's gonna travel again and come from here. Sir, object at region 3. Sir, object at region 3, image at region 4. People, play this animation in your head. Play this animation in your head. Play this animation in your head. Now, one more analysis we'll do. Don't worry. One more analysis we'll do. One more analysis we'll do. Ready? See this. Okay. Ready? See this. Okay. See this. See, if the object है ना, if the object is far from the mirror, the image will be small. The image will be small. Okay. If you bring the object near, the image size will increase. Now see, now notice the size. Okay. Now notice the size. See this. Okay. Yeah, this is the size, very diminished size, because it's very far from the mirror. Now, as I'm bringing it near the mirror, what is happening? The image size is increasing. Image size is increasing, increasing. And at center of curvature, both have the same size. Both have the same size. That is exactly what we did over here. That is exactly what we did over here. Where is this? Where is the case? This case. Exactly same, center of curvature, same size, magnification -1. Magnification -1. Next. Now I'm moving more near to the mirror. So obviously the image size would increase. The image size would increase. See, it is increasing, and at infinity it has reached. Oh. Now see what happens. In region 3, what is happening? See this? Now people, did you all understood this? Did you all understood this? Yes or no? Did you all understood this? Yes or no? Or should I play the animation one more time? People, tell me fast. See this right now. So, sir, what is the analysis that you want us to do? I'll tell you. See this. So, sir, region 1, object is at region 1, image is at region 2. And as we are coming closer, the image size is also increasing. And everywhere it's real image. Everywhere it's real. Center of curvature same size. At center of curvature it is same size. At center of curvature it is same size. Then as we are moving towards region 2, image will be at region 1. Image will be at region 1. Very good. Very good. And the magnification is increasing. Still real image. Magnification increasing. At focus it is at infinity. Now it will go round and come from here. Now people, you have to understand, when the, I'll tell you, when the object is at region 3, the image is at region 4, but it's going to be a virtual image. So the only time a concave mirror gives you a virtual image is when the object is kept at region 3, that is between pole and focus. Rest everywhere it will give you a real image and an inverted image. The only time it will give you a virtual image which is also erect is between pole and focus. And it's still magnified. Yes or no? Yes or no? Now let us do analysis of our problem. Sir, very easy, sir. Sir, I don't need to solve this also. See this. Sir, object is at region 1. So obviously image will be in region 2. So somewhere between 10 and 20, that's what I'm getting. Somewhere between 10 and 20, 12.5. Yes, sir, I'm getting somewhere over here. Sir, what about erect or inverted? So obviously, sir, it would be inverted. Because in concave mirror, I'll only get erect image when the object is at position 4 or region 3. Obviously it's inverted, it's going to be inverted. Sir, what about magnification? Obviously this magnification would be what? It would be diminished because object is far from the mirror. It would be diminished. That's what we are getting. See, I did not even solve the problem and yet you told me everything. Second, now see this people. It is at 50 centimeters. Okay, and the magnification that I'm getting is -1/4. Now the distance has decreased 30 centimeters. Obviously the magnification will increase. It has become -1/2. Obviously, because object is coming near the mirror. So magnification has to increase. Sir, but still the object is at region 1. So image will be in region 2. It will be inverted. Sir. As soon as it comes at center of curvature, magnification is -1, inverted, same size, real. Next, now object will become at region 2, image at region 1, and now the image size is much more greater. That is the reason magnification is -2. Then at focus, it is at infinity. Then at focus, between focus and pole, virtual image but magnified. Crystal and clear, yes or no? I already told you that you may not have studied ray optics in this way. I've already told you. Yes or no? I mean, you have to like the video now, yaar. I've given you quality content pro max. Yes or no? Yes. Okay. Now, don't worry. Now, sir, what about now? Whatever I've told you, just as I said, whatever I've told you, it's all valid for concave mirror and convex lens. Everything. Don't worry. You'll understand. Everything. Okay. Everything is valid. Exactly the same for concave mirror. That's exactly what we did right now. And also valid for convex lens. Okay. Also valid for convex lens. We're gonna look, don't worry. We're gonna look upon it, don't worry. Now, now you will say, sir, what about convex mirror then? Why are you forgetting convex mirror? Because convex mirror is very easy. Convex mirror is very easy. I'll tell you why. See this. I'll tell you why. Very easy. See this. Convex mirror, wherever you keep the object, you'll always get virtual image. See, you'll always get virtual image. Anywhere you keep the object anywhere, you'll always get. You'll always get. Just a second. Just a second. In convex mirror, anywhere you keep the object, anywhere, you'll always get virtual image and you'll always get diminished. Always. What did I say? Always. Anywhere you keep the object, it is always going to be virtual, always going to be diminished. See this? Always virtual. It is always virtual. Always virtual. Always virtual and always diminished. Simple. Uses of convex mirror. You say, no? You say it. Why do you use convex mirror? Arey simple. Arey dekho yaar. Yes or no? This animation should play in your head when you're solving paper. Always virtual, always diminished, and always erect. Always erect also. Always erect, always diminished, always virtual. Finished. Story finished. Now people, I want you all to draw this graph, draw this table. Yeah, I'm going to fill this table, don't worry. Okay, I'm going to fill this table. Okay, please fill this table, people. Please make 3 columns: position of object, position of image, and nature. Chalo, let's do it fast. Chalo. Let's do it fast because we have more half an hour. We have more half an hour. Then we can move on to the next part. Then I can give you break and then we can move on to the next part. Okay. Yeah. So the 3 columns: position of object, position of image, and nature. These things we have to do. Okay. Let's go. Yeah, have you all made the table? Did you all make the table? Just give me 2 minutes, people. Just give me 2 minutes. Yes, just give me 2 minutes. I'll just order my food, yeah, so that I can also eat at 9 o'clock. You can also eat at 9 o'clock, and then we can come fast, hai na? Yes or no? Okay. Okay. Yes. Did you all make the table? Okay. And also the rows and the columns, please do it. Okay. Just give me 2 minutes. Okay. Just give me 2 minutes. But I hope so. Whatever we are doing right now is very much fruitful for you all. Yes, it's very much fruitful for you all. Yes, I hope so. Okay. I hope so. It's very much fruitful for you all, and I hope so. I have cleared all of your misconceptions. Also cleared your doubts. Also made you practice numericals. Okay. So don't. Okay. Okay, just give me 2 minutes. Okay, just give me 2 minutes. Okay, just give me 2 minutes. I'll just order my food and then we can continue. Okay. No, I'm not a vegetarian. Yeah, I'm not a vegetarian. Yeah, I love non-veg. Yeah. Yeah, done. Yeah, I think you also heard the confirmation of the Google Pay. Yeah. So my order has been ordered, है ना? My food has been ordered, है ना? ठीक है, चलिए. Okay, let's start people. ठीक है, चलो, let's start. Okay. You're pure veg. Okay, no problem. I have no enmity towards pure veg people. Don't worry. I teach everyone, है ना? I teach everyone. Okay, चलो. position of object. Sir, if the object is between minus infinity to C, sir, between minus infinity to C, or we can basically say it is at region 1, है ना, it is basically at region 1, है ना, I can basically say where will be the position of the image. Sir, position of the image will be between C to F, or I can basically say it will be at region 2. Region 2. Yes or no? Yes or no? See this. See this. Sir, see this. See this. See this. Arey, chi. Just a second. Just a second. Center of curvature. This is center of curvature. है ना? Yeah, see this. Sir, region 1, region 2. What about next? Sir, it's real image, inverted image, but diminished. Diminished. Okay, sir. So this is basically real image, inverted, and diminished. And diminished. Okay? Yes or no? Okay. Okay, next people. Or you can basically say something like this, that real object, real image, yeah, you're getting the real image of a real object, that is Rory, and you are getting diminished, and you are getting inverted image as well. Okay, that is what you are getting. Okay, next. So position of object. Now the position of it at C. Now this is at exactly at C, exactly at center of curvature. Arey, chi. Ha. Exactly at center of curvature. Exactly at center of curvature. So image is also at center of curvature. So this is also at C. At C. So this is also real object, real image, and this is same size. है ना? Same size but inverted. But inverted. Okay. Very good. Next. Sir, C is over. Now object is at region 2. That is from C to F. C to F, region 2. C to F, region 2. So image will be at region 1. That is from minus infinity to C. That is region 1. Region 1. So what will be, obviously this is also real object, real image. Now but over here this is not same size. This will be enlarged. है ना? This is be enlarged but inverted. Enlarged but inverted. See this. This is enlarged. Between this is enlarged, inverted. Yes or no? Yes or no? Chi. Okay, clear. Next. Now at focus at F. So position of the image will be at infinity. And nature, obviously, baat hai, you don't have to write, but obviously this is a real object and real image, hai na? We can't comment over enlarge and magnification and everything when it's at infinity, hai na? So just real object and real image. Okay, then it's at region 3. What is region 3? From F to P. From F to P, that is region 3. Region 3 over here, hai na? That is between focus and pole. Between focus and pole. So it is at region 4. It is at region 4. That is from pole to plus infinity. Region 4. Image will be formed at region 4. And this would be a real object but virtual image. But a virtual image. The only time that you will be getting. Hai na? The only time that you will be getting a virtual image when the object is at region 4. Sorry, region 3. Okay. And this is going to be enlarged. Obviously, this is going to be enlarged. And this is going to be erect. This is going to be erect. The only time that you will get a virtual image and an erect image. Okay. Yeah, you can follow it for JE. This is JE level content. Yes, you can follow it for JE. Okay. Next is from pole to infinity. From pole to infinity, or the object is kept at region 4. Sir, what is this region 4? That is meaning a virtual object. So over here in this animation, virtual object is not there, so I can't show you. But if the object is over here in region 4, image will be in region 3. Image will be in region 3. Okay. See, some spammer has come to basically, disturb the class, but just ignore, hai na? Just ignore. So this will be at region 3. Region 3, and this is virtual object, real image, erect and diminished. You don't have to worry. You don't have to worry about the last column, the last row. Hai na? You don't have to worry about the last column or last row. That is just you know, don't worry, it will not come in your exam, है ना, it will not come in your exam, है ना. So yeah, this is exactly what you want. Yeah. Am I clear? Am I clear now, people? Now do you want ekdam I don't know, I don't have words to say, a great amazing question. Obviously it has come in JEE. I think it has also come in NEET. I think it can come. Amazing question based upon what all we have learnt. Based upon what all we have learnt. Okay. Okay. Yeah, don't worry, just ignore the spammers. No, ignore the spammers. है ना? Ignore the spammers. Ignore. है ना? If we give them too much attention, no, then they'll spam more. Just ignore, just study, they'll leave on your own. They'll leave on their own. Ignore, ignore, ignore. है ना? Okay. I hope so you have filled the table. है ना? I hope so you have filled the table. People, this is your question. What is the question? I'm going to explain it. I have a concave mirror over here with radius of curvature 40 centimeters. I have a rectangular slab over here. Okay, I have a rectangular slab over here with a length of 20 centimeter, and one of its end is at center of curvature, and the breadth height is 2 centimeters. है ना? This is 2 centimeters. 2 centimeters. Okay. I want you to find out the area of the image, not the area of this thing. I want to find out the area of the image. Okay. Now, first of all, I want you to, है ना? I want you to first draw the image. Can you draw the image? I'll help you draw the image. Don't worry. Let's solve. है ना? Have you all taken down? Have you all taken down the question? Yes or no? Have you all taken down the question? See, this spammer doesn't know, no? The more he spams, the more this video will get recommended. So that's exactly what we also want. And more students should gain the knowledge. So please spam more. Okay. Yeah. Have you taken down the question, people? Have you taken down the question? Yes or no? Yes. Okay. Very good. Chaliye. Yeah, magnetics will get covered, don't worry. Okay. Chalo. Now let us understand how to solve this. Now let us first visualize, sir, how, sir? How to understand the image, sir? It's very important. How to understand the image? Very, very important. People, what you can do is, you can consider this object made up of different objects. Okay? You can basically assume this one whole thing to be made up of different objects. That means, can I basically say, this is one, see, this is one object over here, this is one object, this is second object, this is third object, fourth object, fifth object, sixth object, seventh object, eighth object, ninth, and so on. Basically, it is made up of different objects. It is made up of different many objects basically. है ना? It is made up of many objects. Okay. Now, people, concave mirror. First object is at center of curvature. First object is at center of curvature. Where will be the image, sir? Where will be the image? What will be the magnification? What is the property? Tell me fast. Tell me fast. No, it's not at infinity. It's not at infinity. Infinity you get at focus. You get it at focus. Sir, center of curvature. Sir, center of curvature. Center of curvature. Sir, animation please. Sir, center of curvature. Center of curvature. Center of curvature. Sir, same size. Same size. We get the image at same size. At center of curvature, inverted real. This animation should play, people. This animation should play in your head. This animation should play in your head. Okay? Okay? So that means, can I basically say, the image that would be formed of this object would be over here, something like this. Same size but inverted. Inverted but same size. Yes sir, this is true. Now tell me people, I have already told you in concave mirror. I have already told you in concave mirror, and basically you can write this also. Basically you can write this also, है ना? Nearer the object, more magnified the image. More magnified the image. That means the closer the object is to the mirror, the size of the image will increase basically. That's what happens, no? See, that's what happens over here. See this? It's far from the mirror. The object is far from the mirror. So the image is very, very small. But as you are going nearer to the mirror, the image size is increasing. The image size is increasing. Yes or no? Yes, 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 yes. Yes, it is increasing. So see over here. See over here. See over here. The object is going far, no? The object is going far. So the image size should increase or decrease? The image size should increase or decrease? Image size should increase or decrease? Yes or no? Should increase or decrease? As the object is moving far, the image size should decrease or increase? Yes, tell me. Decrease. Obviously it is going to decrease. See, as the object is going far, the image also will be small. Yes, or you can visualize something like this. You can visualize something like this, parallel to the principal axis. Then this ray would pass through the focus. This ray would pass through the focus. Now, the image would be formed something like this. The image would be formed something like this. Yeah, this is basically the image that is going to get formed. This is the image that is going to get formed. This. See, passing through the focus. And obviously it will not touch the focus. Why it will not touch the focus? Because in order for the image to be formed at the focus, the object should be at infinity. It is not reaching till infinity. That is the reason I stopped over here. That is the reason I stopped over here. Are you all able to understand? Are you all able to understand? Yes or no? So this is a rectangular slab, but over here I'm getting a trapezium. So make sure of that. Make sure of that. Now how to find the area? So obviously I need to find out the length, no? I need to find out the length. I need to find out the length. Also I need to find this length also. Do I need to find this length? No, I don't need to find this length, because this size and this size would be same. It would be same. This is 2. This is 2 centimeter. Now I need to find this. We can calculate it. Don't worry, we can calculate it. But sir, how to find this, sir? How to find this? With this thing I'm not able to understand, sir. This thing I'm not able to understand. This thing. How to find this? No problem. So this right over here, this image that we are getting formed, is basically the image of which object? The last object, right? So the object right over here, its image is getting formed over here. So can I basically say that the u over here, the value of u over here is basically, this is r is 40 centimeters. So this is 40, this is 20, the 60. So u will be over here, u will be minus 60 over here, because incident ray in this direction, this is minus, this is plus. How to? Because center of curvature same size, no? This is also 2 centimeter. The breadth is 2. The breadth is 2. The breadth is 2. Clear? Clear? So u is minus 60. U is minus 60. So let's find out v over here. Let's find out v over here. Sir, v is basically oof divided by oof. Oof divided by oof. U is minus 60. Focus is how much? Minus 20 divided by minus 60 plus 20. Minus 30 centimeter. This comes out at minus 30 centimeter. Minus 30 centimeter. So this is basically minus 30. That means this is 30. This is 30. This is 30 centimeter. People, this is center of curvature. This is center of curvature. No, this point is center of curvature. Center of curvature. This is 40. This is 30. So obviously this becomes 10 centimeter. This is 40. this is 30, this becomes 10 centimeter. Are ha ya na bolo. Are ha ya na, yes or no? Yes or no? Yes, you are able to understand. Now I need to find the height of this thing. Can I find the height of this thing? Yes, sir, I can find the height of this thing. Sir, how to find out that? Magnification. We can basically use magnification over here. Yes or no? Yes, sir, we can use magnification. Sir, magnification will be minus V. Sir, what is minus V? Minus V is 30. So this becomes 30. So magnification is basically minus V by U. Hai na? Okay. Sir, what is V? V is basically minus 30. So this becomes 30. And what is U? What is U? What is U? U is basically 60, minus 60. So this is minus 60. So this comes out to be half, minus half, minus half. So from here I can say height of image divided by height of object. So height of object is basically height of image. Height of image is basically height of object divided by 2 but negative sign. What is height of object? 2 centimeter. The divided by 2. So this comes out to be minus 1 centimeter. So height of the image is minus 1. So this height is minus 1 or 1 centimeter in height. Clear? Now we need to find the area of trapezium. We need to find out the area of trapezium. What is area of trapezium, people? If you don't know, please write the formula. What is it? Half into sum of parallel sides. Hai na? Sum of parallel sides into multiplied by distance between them. Distance between them. This is basically the formula. This is basically the formula. Meaning half into sum of parallel sides. 1 plus 2, that is becomes 3. 1 plus 2, 3. Into distance between them. What is the distance? It is 10. It is 10. So 2 5s are, this becomes 15 centimeter square. That is your answer. Everybody clear? If you have understood this, can I have some chamka? Oh, sorry. Can I have some fire in the chats, people? Can I have some fire in the chats? If you have understood this, fire in the chats. If you have understood this, some fire in the chats, people. Yes, understood. Very good. Very good, very good, very good. You can mark this question. It's a very good question for revision and everything. You can mark this, okay? Mark this question, very good question for revision. We have applied every concept over here, hai na? Applied every concept over here. Literally applied every concept over here. Now see this, people. I'll just show the animation one more time. One more time, just to make things everything clear, okay? Center of curvature. Object at region 1, image at region 2. This is inverted, diminished also. But as the object is coming nearer the mirror, the image size is also increasing. And at the center of the curvature, both have the same size, but this is inverted but real. Now, when the object is at region 2, the image is at region 1. But as the object is more closer, this image size would be much more larger. But this is still real and inverted. At focus, it would reach the infinity. But once the object is in region 3, the image will be in region 4, enlarged, virtual and erect. Okay, that is for convex mirror. What about, sorry, that is about concave mirror. What is about convex mirror? That is the simplest one. Anywhere you go, it is erect, virtual and diminished. Anywhere you go, it is erect, virtual and diminished. Clear? U is equal to 60. I did not give the value, Akshata. I did not give the value. I calculated the value. See, this is center of curvature, no? This is center of curvature. That is, this is 40. This is 20. So this has to be 60, no? That's it. Okay? Clear? Clear, 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 clear. So, just as I said, people, convex mirror and concave lens, both, everything is same. Hai na? Yeah, I'll give you break. I'll give you break. Don't worry. Don't worry. Don't worry. Hai na? Yes. Just we'll solve one more numerical and then I'll give you a break. It's a small numerical. It's a small numerical, very small numerical. Okay. Then I'll give you a break. Okay. So see this. Anywhere always virtual, erect, whatever be the position of the object, and m is always positive, है ना? That is what I have said, है ना? Everything, है ना? तो this I've already, ठीक है? Yeah, just one more numerical and then I'm gonna give you break. So what is that numerical, sir? Sir, longitudinal magnification. No need of formula. No need of formula. No need. No need of formula. So then what we need, sir? We only need logic, and that I have already instilled in your brain, है ना? Installed in your brain, है ना? Yes, 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 है ना? और निलय कुछ समझ इसलिए नहीं आ रहा है क्योंकि टीचर है आपके पास सारा समाधान है ना? बट एक चीज आपके पास नहीं है जो आपके पास होना चाहिए, वो है दिमाग लेके आइए, समझ जाएगा, है ना? ओके, चलो people, what is longitudinal magnification? Very easy to understand. I'll help you understand with the help of a numerical, है ना? I'll help you understand with the help of a numerical how to understand longitudinal magnification. See, what is transverse magnification, people? I've already made you understand. In transverse magnification, है ना? In transverse magnification, where is transverse? हाँ, in transverse magnification, object is perpendicular to the principal axis, है ना? Okay. So object is perpendicular to the principal axis. Okay. But in longitudinal, है ना, in longitudinal magnification, you have to understand the object is sleeping along the principal axis, है ना? Okay, sleeping along the principal axis. Now we have to find out the magnification, how long or how short the image is going to be. Do we need formula for this? No, I don't need formula. I only need logic, and logic I know. How to calculate it, sir? I'll tell you. See this. Right now the length of the image is 3 centimeters and this point B is at 12 centimeter away from the pole of the mirror. So this point A is basically 15 centimeter away. Yes, logical enough. Let's calculate. Okay. Let's find out the image of B. Let's calculate the image of B. Sir, incident ray over here. This is minus, this is plus. Sir, this is VB is equal to UB into F divided by UB minus F, है ना? Is equal to UB. What is UB, people? For B, minus 12, sir. Minus 12. Okay, very good. Focus, sir. Focus is again this side, half of this, minus 10. Minus 10 divided by minus 10 plus 10. Minus 12 plus 10. So this becomes 120 divided by minus 2. This becomes minus 60 centimeter. Minus 60 centimeter. So that means the image of B I am getting at minus 60. I am getting at minus 60. So minus 60 means somewhere over here, है ना? Somewhere over here or something. Much more here. Okay. Sir, what about? So we have completed mirrors. Now lens, refracting surfaces. That is the thing that we have to understand. Okay. Now what about VA? Okay, image of A. So see, image of A, if you are able to understand, A is 15 centimeters away, है ना? See, this is 12, this is 3, so 15 centimeters away. So UA is F divided by UA minus F, है ना? So this becomes, what is UA? Minus 15. Minus 15 into minus 10, the whole divided by minus 15 plus 10, है ना? So this becomes 150 divided by minus 5. So this becomes minus 30 centimeter. Minus 30 centimeter. Yeah. I know. Break. I know. The last question, then break. Okay, don't worry. Hello. सर आप सेकंड फ्लोर आ गए क्या? हाँ सर, आप वो सिक्योरिटी को दे दो ना, मैं खाना ले लूंगा. सिक्योरिटी को दे दो. हाँ, अनअकैडमी सिक्योरिटी. हाँ, थैंक यू. हाँ जी. Okay. So VA is at minus 30. So that means, see, something like this is happening over here. Something like this is happening. Something like this is, something like this is happening. This is 15. Well, position of B, image position of B is at 60. Achha sir, 60 is over here, है ना? This is V is equal to minus 60. Okay. And of A it is at minus 30. Achha, I'll consider this as minus 30. minus 30. So the object that is getting formed is something like this. This is B, this is B, and this is A. Something like this it is getting formed. This is the image that is getting formed. What is the length of the image? If sir, very easy in time. This is 30, this is 60, so this is also 30 centimeter. Length of the image is 30 centimeter. 30 centimeter. Yes or no? Yes or no? Yes or no? This is 30 centimeter. So I can even find out the magnification. That is minus length of image divided by length of object. What is the length of image? Sir, minus 30, sir. Minus 30 divided by length of object, sir, 3. So this comes out to be minus 10 centimeter. Sir, how? Why minus? Because see, it has inverted, no? It has got inverted. That is the reason minus. And magnification is 10 times. Earlier it was 3, right now it is 30. So 10 times. Khatam? That's it. Longitudinal magnification also over. Longitudinal magnification also over. Now people, I'm gonna give you break. Okay, I'm gonna give you break. Then we're gonna just solve one or two problems. Then we're gonna start with refraction of light. Okay, we're gonna start with refraction of light. Okay, okay. Now tell me, how many of y'all will join for refraction of light? Tell me. How many of you all will join for refraction of light? Tell me. Yeah? How many of you all will join for refraction of light? Not over, it's not over. Mirror is over, but yeah, refraction we have to start. Practice questions I'll give you, don't worry, it's not over, don't worry. Hana, don't worry. Okay? So right now it is 9-5. It is 9-5. Yes. Yeah, yeah, like half, yeah. Okay, it is 9 right now. Okay, I can give you some 50 minutes break. Is 50 minutes break enough for you all? Can we move? Yeah, 50 minutes break. Yes. 50 minutes break. 50 minutes break is more than sufficient. 50 minutes break. Yes, I guess 50 minutes break is more than sufficient. Okay, 50 minutes break is more than sufficient, I guess. Okay, 50 minutes break is more than sufficient. Okay. 50 minutes break. Okay, 50 minutes. Okay, 50 minutes. Yes, 50 minutes break is more than sufficient, people. Yeah. Okay, 50 minutes break. And yeah, not 15, 50. Okay, so you can all eat your food. And okay, okay, chalo. Well, we'll meet by 9:55. Yeah, 9:55. Okay, 9:55. Okay, by 9:55 I want everybody to be here. Okay, people, 9:55. ठीक है, चलो, bye bye. 9:50 everyone should be here. Okay, bye. Yes, so hello, we're back. Back again with the same energy. Yes, long way to go, people, long way to go. Yes, I've already told you that this is a big chapter, but Hanji. Hello, 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 hello. What's up? What's up? Yes. So can you just confirm? Can you just confirm that everything is clear? I'm audible. I'm visible. Everything is clear. Hello, 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 hello. So yeah, very good, very good. Everybody is back. So people, we have to understand that um, we have covered. If you ask me, what is basically the percentage that we have covered? Still a long way to go, because we have to complete lens, we have to complete refraction at plane surface, we have to complete refraction at curved surface, we have to complete prism and everything. So all of these topics are remaining, but I have laid the foundation for you guys. Okay, the foundation has been set up. It is very strong. I also know that, you also know that, and I also know that you guys have understood this very clearly. You are very confident with this, and with this confidence I will move forward, because the foundation is laid. This was the tedious task that is done. Now we are moving forward. Okay, now we are moving forward. Okay, ठीक है. तो चलिए, with again this same energy, this same spirit, we are gonna move forward, and we are gonna complete this session. Okay, we are gonna complete this session. Okay. Now people, why do you take long break? Because you needed a long break, right? I only need half an hour. It's okay, we need to eat food and everything. No, it's okay. Now people, what happens when a mirror is cut? Okay, what happens when a mirror is cut? So see, very simple to understand, people. Okay, what happens when a mirror is cut? Okay, see this, very easy to understand. Let's say this is the concave mirror that I have over here. Okay, just a second. Yeah, this is the concave mirror that I have over here. I have a concave mirror over here. Okay, and if this is the concave mirror, this is basically the principal axis. Okay, this is basically the principal axis. Okay, okay. Now, obviously, no, I mean, this is very easy to understand right now. If this is the focus, this is basically the center of curvature, है ना? So I already know that if this is the object that I'm looking forward to, है ना? If this is the object that I'm looking forward to, what will be the ray diagram? The ray diagram is going to be very easy. This is the incident ray parallel to the principal axis. This will pass through the focus, है ना? This will pass through the focus. Now we all know, as this is in region 1, the object, है ना, is as the object is in region 1, the image will be in region 2. So let's see whether it happens or not, है ना? So this goes parallel to the focus, sorry, cutting through the focus. So it has to be parallel to the principal axis. Yes, we are getting the image. We are getting the image inverted, real, and between C and F, and that is exactly what we are getting. Very good. But sir, the topic is mirror is cutting, है ना? Mirror is cut. What happens after that? So people, if I basically cut the mirror, what happens? If I cut this part of the mirror, I remove this. I have removed this portion. Okay, I have removed this portion. So what happens over here? What happens over here? Will the image will be still formed? Yes, the image will be formed. Okay, so yes, the image will be formed. Yes, the image will be formed. How? And I'll tell you. Okay, yes, the image will be formed. Okay, it will be formed, because these are the only two light rays that we are representing, but there are infinite number of light rays which are coming over here, है ना? Infinite number of light rays. For example, in this case, I'll just show you. See, these are infinite number of light rays which are coming. See this, infinite number of light rays. I am only showing two of them. There are infinite number of light rays. So even if you cover one portion, if you cut the mirror in half, or even if you cover one portion, still you will get the image. Only the only difference being but the intensity of the image will be less. But the intensity of the image will be less. This is basically that you have to understand. Okay. Okay, people. Yes or no? Yeah, I don't look for the watching and everything. Don't worry. I look only for the concepts. Okay. So those who want to study, they can study over here. Hai na? So obviously this is very much intuitive to understand. I'm so sorry. This is very much intuitive to understand, obviously. So this ray will not be here. So I can give one more ray over here, something like this, that a ray strikes over here, and this is passing through something like this. Yes, this is one more ray which can pass over here. But obviously, baat hai. Okay, are you all able to understand this? So even if a mirror is cut, the image will be formed, but the intensity of the image will be less, because obviously it is very much obvious, if the mirror was here, more light rays would have reflected and formed a much more clearer image or much more intensified image over here. But as the mirror is not over here, clear? Okay. Now people, one more question that people may ask over here. Sir, is still the pole of the mirror at the same place or at some different place? I mean, people may ask, sir, is the pole right now over here or over here? No, the pole does not change position. The pole is still where it was already. Okay, so pole does not change position. So pole, this is still the pole. Okay, this is still the pole. Pole doesn't change position. Clear? Clear? Okay, very much clear. Chalo, let's move ahead, people. Okay, so this we have completed. So cutting of the mirror. Now people, we are going to solve a 2016 NEET paper. 2016 NEET question over here. It was a very good paper. 2016 also was a very good paper, much less than 2025, but it was a very good paper. And if you want to rank NEET papers 2025, then comes 2016. So 2016 was a very good paper. So can we solve this? Can we solve this question using our analysis method? Yes, we can solve it. Chalo, let us see. Okay, chaliye. Now people, see this. We need magnification -2. What do you mean by magnification -2? Sir, magnification -2 meaning it is inverted and also it is magnified. Hai na? It is inverted and magnified. Sir, I know. Hai na? I know in convex mirror, I don't get any inverted image. I only get virtual image and erect image. So this is very much clear. M is equal to -2 matches with concave mirror. So A matches with 2. And obviously, if the magnification is -2, it has to be inverted and magnified. And that you get in concave mirror. And it is a real image that you're getting. Yes or no? If you want to visualize, then you can visualize. See also. Arey, what is this? Just a second, people. I'll just reload it. Yeah. See this. See this, people. Hai na? So I need a magnification of -2. So this is magnification of -2. See, this is inverted also, magnified also, real image also. I get it for concave mirror. See this, that is the thing. That is the thing I was able to tell you, that you have to keep the animation in mind. The animation has to keep on playing. Okay. So -2 is 2 and 3. Done. Sir, m is equal to -half, sir. Sir, -half matlab, what do you mean by -half? First of all, it has to be inverted. So convex mirror is out, because convex mirror only gives me erect image. Convex mirror will only give me erect image. No, it only gives me erect image and diminished image. Only erect image. So convex mirror is out. So obviously B has to be again concave mirror again. It has to be concave mirror again. And if it is concave mirror, I know it has to be inverted and real also. It can't be virtual. But because in concave mirror, virtual, when were we getting virtual? When it was in region 3, hai na? So this has to be again what? B23, same thing, B23. So B23 also same thing again same thing. So can we mark right now? Yes, we can mark. So 1 and 3 wrong, 1 and 4 wrong, 3 and 4 wrong. Option A is your correct answer. So 2 and 3 is your correct answer. Hai na? Yes, you can. Then let's talk about C. Let's solve the question full. No, let's solve the question full. Okay. Now let's talk about C. Now what is C? C is +2 people. C is +2. Now again you have to understand. What do you mean by +2? +2 matlab erect and also magnified. Convex mirror does not give you magnified image. So again it has to be concave mirror. It has to be concave mirror. So 2. Now when does concave mirror give you a magnified image and also an erect image? Virtual, region 3, yes or no? See, region 3. This is +2 magnification, erect image, yes or no? Yes sir. So this is virtual image. So C is 2, 4. Then D. What is D? What is D? What is D? Okay, this is basically square root of 2 by 3, है ना? Square root of 2 by 3. So this is less than 1, है ना? So this is something less than 1, and it has to be erect image and also demagnified, है ना? It has to be diminished. Erect and so this is convex mirror. This is convex mirror because this is positive. So it has to be erect. It is erect and as well as diminished. So this combination you will only get for convex mirror. You will only get for convex mirror. So it has to be 1, 4 because convex mirror always gives a virtual image. Okay, clear? Optical instruments is the last topic, people. Optical instruments is the last topic. Okay. Now we're going to start with refraction of light. Everybody clear? Was this understood, people? Was this understood? Yes or no? Yes or no? Was this understood? Okay, chalo. Refraction. Again, what is refraction? Refraction, we already know, people, what is refraction and everything. Refraction is basically the bending of light when light changes its medium. When light goes from one medium to another medium, it changes its speed as well due to its refractive index. And due to the speed being changed, the light bends when it goes from one medium to another medium. And this bending of light is called as refraction. Okay. So the deviation or bending of light rays from their original path while passing from one medium to another is called as refraction. Hai na? It is due to the change in speed of light as light passes from one medium to another medium. Okay. If the light is incident normally, then it goes to the second medium without bending, but still it is called as refraction. Matlab, it is very simple to understand. If this is a medium that I'm talking about, okay. It's like, for example, this is medium 1 and this is medium 2. So if a light is incident perpendicularly, hai na, it can pass without bending. But still this is called as refraction. Now we all know what is law of refraction also. We all know what is laws of refraction. What is the law of refraction? Sir, the incident ray, the refracted ray and the normal, they all lie in the same plane. That is the first law. Hai na? That is the first law. I don't have to talk about it in much detail because you already know about it. The second law. The second law is also called as the Snell's law. Hai na? It is also called as the Snell's law. I'm not going to use N1 over here. I'm going to use mu1 over here. Okay. I'm going to use mu1 over here. Mu1. Okay. Mu1 and mu2. Okay. Okay. So what does Snell's law say? Snell's law basically tells you, hai na, this is angle of incidence. Hai na? This is angle of incidence. So not theta1, I'll say it I, and not theta2, this is R. Okay. So what does Snell's law say? Snell's law basically says that sine of the angle of incidence, hai na, sine of the angle of incidence into mu1 is basically equal to sine of the angle of refraction into mu2. This is basically Snell's law for you. Hai na? This is basically Snell's law for you. Yes or no? Clear, people? Okay. Now one more thing that you have to note over here. One more thing that you have to note over here. One more thing that you have to note over here. What is the thing? People, if over here light has some wavelength lambda, it has some frequency f, and it has some speed v. It has some speed v. If it changes the medium, the lambda changes. It becomes lambda dash. The frequency remains the same, but the speed also changes. It becomes some v dash. So the frequency, you have to understand, frequency does not change with the medium. Yeah, frequency is constant. Frequency is constant. Doesn't change with medium. Doesn't change with medium. Doesn't change with medium. Okay, it doesn't change with medium. Okay. Okay, it doesn't change with the medium. Frequency is constant, doesn't change with the medium, but the wavelength and the speed of the light, it changes. Okay, why it doesn't change with the medium? Because frequency, it depends upon the source. It can be only changed if you change the source. Depends on source. One more relation that you should know. This is one important relation that you already know, that the speed of light v is basically equal to f lambda, or speed of light is basically equal to frequency into the wavelength. This is one relation that you should know. One relation that you should know. Okay. Okay, v is equal to n lambda. Clear? Is this clear, people? All basic things that you already know, but I've already listed it down as your theory. Okay, clear. Now let us talk about refractive index. Very, very important to understand, people. We are going to talk about refractive index. Now, refractive index also has two categories to understand. Two categories to understand. I can basically divide the refractive index into two things. One, okay. One is basically called as the absolute, okay, the absolute refractive index. This is the absolute refractive index, and this is called as the relative refractive index. Okay, the relative refractive index. Two things. First of all, let us understand what is refractive index. Refractive index is basically a number. It is unitless, it is dimensionless. It is number. What does it say, sir? It is basically the ratio. Sir, it is ratio of what? It is basically the ratio. It is basically the ratio of speed of light in vacuum divided by the speed of light in that medium. That means I can basically, so refractive index is basically, I will denote it by mu. It is basically speed of light, है ना? It is basically speed of light in vacuum, divided by speed of light in medium. In that medium in which you want to find out the refractive index. Okay, no problem. Okay, so I can write this as speed of light in vacuum is basically c, divided by speed of light in medium is v over here, and this is mu. This is basically called as the refractive index. So if you know the refractive index, you can also calculate the speed of light in that medium. Sir, how to understand that? I'll tell you. Basically, you can also write this as, v is basically equal to c by mu. V is basically equal to c by mu. Yes or no? Yes. So if you know the refractive index of that material, you can basically divide speed of light by that refractive index to get the speed of light in that particular medium. Yes or no? Yes or no? Clear? Clear, people? Am I clear? I think so. This is very much clear. Now, what is called as relative refractive index? Now, over here, you are comparing with the speed of light in vacuum. Over there, you are basically comparing speed of light in different medium. Like, for example, if somebody writes something like this, mu 2, 1. What do you mean by this? This is refractive index of medium 2 divided by refractive index of medium 1. So, Ri of medium 2 divided by refractive index of medium 1. Clear? Can I write refractive index of medium 2? Can I write refractive index of medium 2 as C divided by V2? Yes, sir. And I can write this as C divided by V1. C and C get cancelled out. So what I get is V1 by V2. This is one more relation that you should know. This is one more relation that you should know. Clear? So absolute refractive index, relative refractive index, I have already told you. So this is refractive index of medium 2 with respect to 1. Okay. Clear? Can I move ahead? Can I move ahead, people? Yes, if you have understood this, some fire in the chats. Clear? Now let us solve. है ना? Okay, now let us solve an equation. Sorry, a problem. Okay, now this problem you will not find it anywhere. It's a problem made by me itself. है ना? So let us solve. है ना? I'll just explain you the question, whatever it is. So I have a glass sphere over here. है ना? I have a glass sphere over here with a refractive index of √3. The angle of incidence is 60 degree over here. I need to find out the angle of refraction R1. I need to find out the angle of R2 over here, deviation over here, angle of emergence over here, and also del 2 over here, the deviation over here, and also the total deviation also. Okay. Acha, one more thing. There are some values which you need to remember also. Like for example, mu of glass is taken as 3/2. And mu of water, है ना, that is mu of H2O is taken as 4/3. These are some of the values that you can remember. Okay, I mean they will give you in exams, but still you need to remember these two values. Okay, people. Okay. No. See, even if it's a flat surface, don't worry. Even if it's a flat surface, you don't have to worry about it. है ना? If it's a curve, you don't have to worry. You can just use simple Snell's law over here. है ना? Okay. Now, let us solve this. I'm going to use Snell's law over here. Okay, now the surrounding is air, okay? The surrounding is air, and you already know that mu of air, hai na? Mu of air is considered as 1, okay? Mu of air is considered as 1, okay? Now, let us start. Snell's law over here, people, okay? This is air, okay? This is air. So, first of all, 1 into, that is mu of air, into sine 60, okay, into sine 60 is basically equal to the refractive index of this, that is √3 into sine of R1, into sine of R1. This is something that we are getting over here. What is sine 60? So sine 60 is √3/2. This is √3 over here, and this is sine R1 over here, okay. So √3 and √3 gets cancelled, so this is basically half over here. So when do we get the value of sine R1 as half? You all be like, sir, R1 should be equal to 30 degrees. That's when we'll get sine R1 as half. Okay, very good. So R1 is 30 degrees. R1 is 30 degrees. Very good. Sir, R1 we have calculated, sir. Very good. Now, geometry. See, people, this is, after all, this is geometrical optics. So you need to have geometry. You need to command over geometry. Now, people, see this. This is very interesting to know. This is also the radius of the circle. This is also the radius of the circle. Okay. This side is equal to this side. If this side is equal to this side, and in this triangle, if this is the triangle that I'm looking for, these two sides are equal. And if these two sides are equal, this R1 should be equal to R2. This is one property. This is one property. And this is one property that I'm looking forward to. So I can definitely write that R1 is equal to R2. So the value of R2 also comes out to be 30 degrees. 30 degrees. Very good. Very good. Very good. Now let's talk about over here. Just apply Snell's law. That's it. Applying Snell's law over here. So I get, what is the refractive index? √3 into sine of R2 into sine of R2 is basically refractive index of the outer surrounding is 1 into sine of the emergence angle, sine of emergent angle, okay. √3 into sine of R2. What is R2? Half over here. Sorry, R2 is 30 degrees. So sine of 30 is half. So this becomes half and this becomes sine E. Now, when do I get sine E value as √3/2? You all will be like, Sir, the value of E should be 60 degrees. The value of E should be 60 degrees. Cool. Cool. Very good. Yeah. Array, these are all JEE main PYQs itself, buddy. I just don't say it. See, this is a mains PYQ. This is also a main PYQ actually. Don't worry. This is also main PYQ. I'm just not saying it. I'm just covering it. Don't worry. Okay. So E is equal to 60 degree over here. So we have calculated R1, R2, E also we have calculated. Now we need to find the deviation and everything. We need to find out the deviation and everything. See these people. If the refraction was not taking place, if refraction would not have taken place, this incident ray would have just traveled over here in this direction. Yes, it would have just traveled over here. But it got bent over here due to refraction. So basically, can I say that this is the deviation that I'm talking about? Yes, sir. This is the deviation that I'm talking about. So can I basically say that if this is angle I, this is also angle I, this complete angle, because vertically opposite angles. No, vertically opposite angles. Vertically opposite angles. Okay. This is also I, this is also I. I know already the value of R1. So I just need to subtract R1 from it to get del 1. Yes or no? To get del 1. So basically, can I say that del 1 is basically I minus R1, which is basically what is I? What is I? It is 60 minus R1, that is 30 degree for you all. So this comes out to be 30 degrees. 30 degrees. Clear? Clear. Very good. Very good. Very good. Now we need to find out the deviation over here. We need to find out the deviation over here. Okay, we'll find out the deviation over here. Now, if refraction would not have taken place, this yellow light would have just followed this straight path, but it got bent over here. It got bent over here. So this is the deviation that I'm talking about. This is the deviation that I'm talking about. Now, this complete angle is E. This complete angle is E. This is R2. This is also R2. See, vertically opposite. No, this is also R2. So what is this angle? Can I say it is E minus R2? Can I say this is E minus R2? What is E? 60 degrees. So 60 minus 30, which is basically 30 degrees. 30 degrees. Yes or no? Very good. Very good. Now I need to find out the total deviation as well. Total deviation that I can basically calculate del 1 plus del 2. Just add the total deviation. That is 30 plus 30. 60 degrees your deviation. Now obviously you also need to find out the direction as well. Del 1 is over here, del 2 is also over here, hai na? So net deviation also over here. Simple. Clear? We have found out everything, hai na? We have found out everything. Clear? Okay. Very good. Very good. Very good. Very good. Very good. Very good. 2007 PYQ. The frequency of a light wave in a material is this much. Wavelength is this much. The refractive index of the material will be how much? Very good, people. I already know the formula. That is V is basically equal to F into lambda. Hai na? I know frequency. I know the wavelength. I can calculate the speed of light in that particular medium. So V is basically frequency is 2 into 10 ki power 14 into lambda. Lambda is 5000 angstrom. I need to convert angstrom into meter. So that becomes 10 ki power minus 10 meters. Okay. So this becomes 5 2s are 10. This becomes 10. 5 2s are 10. No. So this becomes 15, 16, 17, 18. 18 minus 10. 10 ki power 8. Yes. This becomes 10 raised to 8 meter per second. That is the velocity of light in that particular medium. Hai na? Now, I need to calculate the refractive index. I already know the formula that V is basically C divided by mu. Hai na? So if you need to find out, so see, C is basically the speed of light in vacuum. So in one particular medium, the speed of light decreases. Decreases by how much? Just divided by mu, you will get your answer. So we already know the value is over here 10 ki power 8. And the value of C is 3 into 10 ki power 8 meter per second divided by mu. So the value of mu comes out to be 3 into 10 ki power 8 divided by 10 ki power 8, which is basically 3 itself. Option B is your correct answer. Clear? Clear? Yes or no? Yes or no, people? Yes or no? Chaliye, moving on. Another good question. Another good question. It's a 1996 PYQ, but it's a very good question. Light travels through a glass plate of thickness T having refractive index mu. If C is the velocity of light in vacuum, the time taken by the light to travel this thickness of glass is. Now, let me assume that this is glass. This is the glass slab that I'm talking about. This is the glass slab that I'm talking about. What I'm going to do, I'm basically going to assume perpendicular incidence. So light travels over here as this is perpendicular. This is perpendicular, right? This is perpendicular. No refraction will, refraction will take place, but no bending will take place. It will just travel along. It will just travel along straight. It will just travel along straight. Simple, the simplest case. Simplest case I'm taking. And over here, they have already told that the thickness is T. The thickness is T over here. Okay, no problem. This is vacuum, so the speed of light over here is C. But this is not vacuum. This is not vacuum. It has some refractive index of mu. So what will be the speed of light at this medium? Sir, it will be V, which is basically C divided by mu. Simple. Now simple speed is equal to distance by time. Speed is equal to distance by time. That is exactly what we need to find it out. Simple or not? We need to find the time. So time is basically distance divided by the speed. This is what exactly we need to find it out. What is distance? Distance is T over here. What is the speed? C divided by mu. C divided by mu, or which comes out to be mu into T divided by C. Mu T divided by C. Option A. Clear? Simple? Simple or not? Yes or no? Can we move ahead? Can we move ahead? Okay, chaliye. Now we are going to understand lateral shift. Now we are going to understand what is lateral shift. Okay, very, very important. Very, very important, lateral shift. So this is a glass slab over here which has a refractive index of mu. It is surrounded by air, that is mu is equal to 1. It has a thickness T over here. So what is happening? What is happening over here? Acha, one more thing that you can keep in mind. One more thing that you can keep in mind while understanding refraction. While understanding refraction is basically you can keep this thing in your mind. Draw. You can basically keep draw in your mind. So what is the meaning of draw? The meaning of draw is denser to rarer away from normal. So this is basically denser to rarer. If it is from denser medium to rarer medium, the light will bend away from normal. Okay. Light will bend away from normal. Okay. It will take some time. Okay. Lateral shift. So see this, people. Very, very important to understand. Light is coming in this direction. Now it is from rarer to denser. So it will bend towards normal. See, if this is the normal, it is bending towards normal. It is traveling. Now denser to rarer away from normal. It will bend away from normal. So this is basically the path of light. Okay, this is basically the path of light that I'm talking about over here. Okay, sir, very good. Now what I'm going to do is I'm basically going to apply Snell's law at each point. Let me apply Snell's law at this point over here. So if I apply Snell's law at that point, so I can basically write refractive index of air, that is 1 into sine I is equal to refractive index of the glass, that is mu, into sine R. This is some relation that I'm getting. So I can basically write this as sine I is basically equal to mu sine R. Mu sine R. Very good. Okay. Now people, you have to understand one thing. This is R and this is R dash. Okay. This is R and this is R dash. But see, I'll prove one point. Okay. I'll prove one point. I'm going to apply Snell's law at this point. So this becomes mu into sine R dash is equal to 1 into sine E. This is exactly what we are getting. Now people, see this. This is also normal. Are you all able to guys find out that this angle R dash is actually equal to angle R? See, this is parallel, this is also parallel. This is just alternate interior angle. So R dash would be equal to R. Yes or no? Yes sir, r dash would be equal to r in this condition. So this is the first case, so first equation, this is the second equation, and r is also equal to r dash. Just substitute, है ना? I am not ignoring you, Mubina. I think I did not see your chat. R is equal to r dash. R is equal to r dash. So just substitute r over here. So what does this equation become? This becomes mu into sine r is equal to sine e, is equal to sine e. Now what is mu into sine r? Mu into sine r is actually sine e, sorry, sine I. So this becomes sine I is basically equal to sine e. Now from this fact we are able to understand that I is equal to e. I is equal to e over here. Oh my god. That means how much time it will take? It will take some time. It will take some 4 or 5 hours more. And it will take some 4 or 5 hours more. Okay. ठीक है? So from this we are able to understand r is equal to r dash also and I is equal to e. Now if angle I is equal to angle e, you have to understand that this ray, this light ray over here and this light ray over here would be parallel to each other. So I can definitely say AO, है ना, that AO is parallel to PB, Clear? These are some of the observations that you should know. That r is equal to r dash, I is equal to e, and as I is equal to e, the incident ray and also the emergent ray are parallel to each other. है ना? Incident ray and emergent ray. This is called as the incident ray. Incident ray. This is called as the emergent ray. This is called as the emergent ray. Both are parallel to each other. Okay, people. These are both are parallel to each other. Now one thing that you have to note. What is the note? I'll tell you. See people, if the glass slab would not have been there, what would have been the path of the light? It would have just traveled in straight line. But due to the glass slab being there, refraction is taking place and the final path is over here. It would have traveled in this path, but the final path is over here. So the perpendicular distance between them, है ना? So this perpendicular distance is called as d or called as lateral shift. This is called as lateral shift or the perpendicular distance between these two lines. That is the incident ray which would have traveled if the glass would not have been there, and the emergent ray, the perpendicular distance between them, d. Okay. So the formula for that is d is basically equal to t into sine of I minus r divided by cos of r. This is the formula. Not going into the derivation part of it. No need for the derivation, but this is one formula that you should keep in mind. Okay. This is one formula that you should keep in mind. This is called as the lateral shift. Okay. Lateral shift. T into sine of I minus r. T is the thickness. Sine I minus r divided by cos r. No, it is not same. Okay, very good people. So we are gaining speed. Don't worry, we are gaining speed. Okay, so we have calculated everything. Now let's solve a question on this. The question says, find the lateral shift of a light ray while it passes through a parallel glass slab of thickness 10 centimeter placed in air. The angle of incidence in air is 60 degree and the angle of refraction in glass is 45 degrees. This is what we have to find out. Simple. The formula is d is equal to t into this is the formula that I'm going to use. Okay, so this becomes d is basically equal to t. What is t? T is 10 centimeters. So 10 into 10 की power minus 2 because I've just converted into meters, है ना? Sine of what is angle of incidence? Angle of incidence is 60 degree. Okay, this is 60 minus r. What is r? 45 degrees. This is 45 degrees for you all. The whole divided by cos r. What is cos r? Cos r is again 45 and a cos 45. Yes or no? Yes, sir. So this becomes 10 ki power minus 1. Now this is sine 15. I hope you know to find out sine 15, and this is cos 45. What is cos 45? 1 by root 2. 1 by root 2. So this becomes root 2 over here. Hai na? I hope you know to find. I hope you know how to find sine 15. If you do not know, just look over here. If you do not know, just look over here. See this. Can I write sine 15 as? Can I write sine 15 as sine of 45 minus 30? Or sine of 60 minus 45. Anything works. Anything works. Now use sine A minus B. Sine A minus B. What is sine of A minus B? Sine A minus B. Sine A cos B. Sine A cos B minus cos A sine B. This is basically the formula. This is basically the formula. This is 1 by root 2. Cos 30 is root 3 by 2. Minus again 1 by root 2. This is half. So this comes out to be root 3 minus 1 divided by 2 root 2. This is sine 15. This is sine 15 for you all. Hai na? This is sine 15 for you all. So this becomes sine 15 is root 3 minus 1. Root 3 minus 1 divided by 2 root 2. 2 root 2 into root 2 into 10 ki power minus 1. Root 2 cancel. So what do we get? We get root 3 minus 1 the whole divided by 2 multiply by 10 ki power minus 1 meter. This is basically a lateral shift. Yeah, we can say so. Yes. Yup. Yes, we can say so. Yes. ठीक है? Okay, people. Now, people, very, very important. People, how many of your people are there? How many people are still alive? How many people are still alive? Yes or no? How many people are still alive? How many people are here still alive? Because very, very important portion coming up. Very, 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 very important portion coming up. And this is the portion in which most of the people make mistakes. Most of the people make mistakes. Okay, let's start. Let's start, people. That is the apparent shift, depth and height. Very, very important. Very, 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 very important. See this, people. I want you all to draw diagrams with me. I want you all to draw diagrams with me. Okay. This is the refracting surface. This is the refracting surface. What is this? This is refracting surface. Refracting surface. Okay. This is mu denser medium. This is mu rarer medium. Okay. And I have an object over here. Okay. I have an object over here. This is basically the object. Okay. This is the object. This is basically the object over here. Okay. And this is the observer that I'm looking over here. Observer is somewhere here. This is your eye, hai na? Observer is somewhere over here. Okay. Now what happens? See this. What happens over here? Very important, people. See. First of all, a light ray will come, hai na? A light ray will come, and I'm going to do the light ray which will pass undeflected. Because why will it pass undeflected? Because obviously this is incident 90 degrees. Hai na? It is incident 90 degrees, right? Hai na? It is incident 90 degrees over here. Or the angle of incidence is 0. Angle of refraction is also 0. Or it is incident perpendicularly. So it will pass without deflection. The light rays will pass without deflection. Very good. Very good. But what about this light ray? What about this light ray? This one. Sir, this is going from denser to rarer medium. This is going from denser to rarer medium. That is away from normal. Away from normal. So this is basically, I'm just going to draw a normal over here. Yeah, this is basically my normal. Yeah, normal. This is gonna go away from normal. Like this. Yes or no? Yes or no? Yeah, I will cover all topic. Don't worry, I will cover all topic. Hai na? I will cover all topic. Okay. Yes, it'll bend away from the normal. So it would feel like it is joining somewhere over here. Yes or no? So the image, so this is basically your real object. This is your real object, but the image would be formed over here. The image would be formed over here, and this is basically a virtual image that is getting formed. So for an observer over here, he would feel like the image is formed over here or the object is lying over here. Original position is over here, but he would feel like that the images or the object is over here. Are you all able to understand this, people? Now, a very important note, very important note over here, very important note, very important note. That the note is all distances, all distances, all distances should be calculated from refracting surface, from refracting surface. Okay, everything should be calculated from refracting surface. So sir, so this means which color should I use? Which color should I use? Okay, I'll use white. No, okay, I'll use some yellow. Okay, I'll use yellow. So this is called as this distance. This distance is called as the real height. This is the real depth. Sorry, this is called as the real depth. This is called as the real depth, and this will be called as the apparent depth. Apparent depth. This is called as the apparent depth. Okay, and what will be this called? This be called as the shift. The shift. This is called as the shift. Yes, I am covering everything, people, don't worry. So this distance is called as d over here, that is the real height or the real depth. This is called as d dash or the apparent depth or the apparent height, and this is called as the shift or the apparent shift that I'm taking place over here. The shift that is taking place over here. Yes or no? Yes or no, people? So d is basically the real, okay, the real depth, real height, anything. Okay, real depth, real height. D dash is basically called as the apparent one. D dash is called as the apparent depth. Apparent depth. And x is basically your shift or normal shift. Simple. X is your normal shift, which is basically, can I say it is d minus d dash? Yes, sir. I can totally say it as d minus d dash. Yes or no? Yes or no, people? Is this clear? Is this clear? Now, let us just reverse the case. Let us just reverse the case. Everything still remains the same. Everything still remains the same. I'm just going to reverse the case over here. Reverse the case. Let us reverse the case. Okay. Let us all reverse the case. See this. Very important. है ना? Very important. So earlier it was denser to rarer. Now this is the rarer medium and this is basically the denser medium. This is basically the denser medium. Similarly, same thing. That is the observer. That is the observer. But right now, people, what happens is it's very important to understand. Right now, you have to understand. It's very important to understand what is happening over here. Ruko. See what will happen. See what will happen. So I have a light over here. I have a light ray which will obviously go undeflected over here. Yes or no? Okay. I have one more light ray over here. I have one more light ray over here. Now this is rarer to denser. Matlab, it will go towards normal. It will bend towards normal. It will bend towards normal. It will bend towards normal. So that means it will bend something like this. It will bend something like this. Yeah. It will bend something like this. Bend towards normal. So what will happen? Just extrapolate all the graphs. Extrapolate all the light rays over here. Extrapolate all the light rays. Extrapolating. Yes. So this is where the image is formed right now. This is where the virtual image is actually formed right now. This is your real object. This is your real object. So over here, in this case, are you all able to understand that this is your apparent depth? Sorry, this is your real depth. This is your real depth. This is your apparent depth. This is your apparent depth. And this is your shift. This is your shift. This is D. This is D dash. Yes or no? Yes or no? Clear? 100% clear. Is this diagram clear, people? Now this is a very important point. This is a very important point, that all distances should be calculated from refracting surface. Any distance has to be calculated from refracting surface, be it height or be it depth. Every distance has to be calculated from the refracting surface. Okay, clear? Clear? Can I move ahead? Can I move ahead? Yes sir, we can move ahead. So the formula over here that you have to keep in mind is basically it applies for both of them. D dash is basically equal to D divided by mu mu relative. D divided by mu relative. Now you have to understand this formula. What is this mu relative and everything? You have to understand this formula. What is this mu relative and everything? Now many people find this mu relative a very tedious task, sir. What is this mu relative and everything? It will be very confusing, sir. Don't worry, I'll explain. What is this mu relative? How to calculate mu relative? Okay, how to calculate mu relative? Okay, how to calculate mu relative? Just give me a second, people. Okay, so see this. Something like this is happening. This is the refracting surface. This is mu1 and this is mu2. Okay, and this is the object over here. Okay, this is the object over here. है ना? Light rays are going somewhere like this. Okay, and this is bending towards away from the normal. Sorry, this is bending away from the normal. This is the normal that we are intersecting over here, and if we extrapolate this graph, we are getting the image somewhere here. है ना? We are getting the image somewhere here. So this is the real object and this is the virtual image. This is the virtual image that I'm getting. So what is the formula, people? I'll tell you. First of all, this is the real depth. This is the real depth. This is the apparent depth. This is the apparent depth, and this is basically the shift. This is basically the shift that I'm talking about. है ना? So this is D, this is D dash, and this is X. Okay. Now the formula that you have to keep in mind is, that D dash is basically equal to D divided by mu relative. Now what is this mu relative? What is this mu? Just a second, huh? Okay. Now what is this mu relative? Now obviously you are English students, but I'm supposing that you know a little bit of Hindi. है ना? I know you know little bit of Hindi because there is a trick that I use over here, and for that you need only this much amount of Hindi, है ना? So what is mu relative? Mu relative is kaha se kaha, from where till where, है ना? Finally from where to where? Finally from where to where? What is mu relative? Finally from where to where? That is basically the trick. Sir, what is this from finally from where to where and everything? That means you have to basically say the incident ray, from where to where it went, from initial to final point, from where to where it went. You will all say, sir, it went from mu1 to mu2. That is basically mu relative. That is basically mu relative. That is d divided by mu1 divided by mu2. Now this is not the original formula. Obviously this can change. But what you have to keep in mind, what is mu relative? From where to where, है ना? From where to where? From where to where? This is what you have to keep in mind. Okay, now this is d dash. Obviously you can find the shift. So what is the shift? D minus d dash, that is the shift. Simple. Okay, clear? Yes or no? Absolutely clear. See? So see, this happens when you are looking for some treasure hunt, है ना? What happens is the real object is over here. So light comes over here, gets bent towards away from the normal. Same thing happens, bent away from the normal. But we think, array, light can only travel in straight line. So we get the image formed over here. So this is basically the real depth. This is the apparent depth. And this is the shift that I'm talking about. Okay. 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 Moving on. See, over here also. This is the observer, this is water, and this is fish. Obviously this is denser medium, है ना? Obviously this is the denser medium that I'm talking about. Yes, so this is denser and this is rarer medium, है ना? So light will go from away from normal. It will go away from normal, but we think light can only travel in straight direction. So this is the image that is getting formed. So this is the actual depth, this is the apparent depth. Okay, yes or no? ठीक है, let's understand. Now this is also one more case. If we are under the water, if the swimmer is under the water and a bird is flying over here, है ना? So see, this light rays will go from rarer to denser medium. That is, it will go what? Rarer to denser medium towards normal. It will bend towards normal. It is bending towards normal. Okay, it will bend towards normal. So when we meet it, we are getting the image over here. So for a swimmer who is swimming underwater, he will feel that the bird is at a much larger distance. Okay, clear? Everybody? Yes or no? Yeah, can I have some fire in the chat box if you have understood this? Can I go have some fire in the chat box if you have understood this? Let's solve a question. Okay, let's solve a question. See figure and answer the following questions. Find the apparent height of the bird. Find the apparent depth of the fish. Find at what distance will the bird appear to the fish. At what distance will the fish appear to the bird. Okay, this is exactly what we have to find. Okay, chalo, let's find it out. Okay, people. So what I'll do, I'll basically just copy this, and I'll copy this diagram. Okay, ठीक है. So for the first question, what do we have to find? Find the apparent height of the bird. So basically, fish is the observer right now. Obviously, fish is the one who will be seeing the bird, and let's see what happens, and let's see what happens over here. Okay, let's see what happens over here. Now this is question. Okay, let us find, this is question A. Okay, this is question A, apparent height of the bird. Okay, if you all notice over here, now the light will enter into fish eyes, है ना? Light will enter into fish's eyes. So what is going to happen? Something like this. So this is the incident one, the straight one, है ना? The straight one. Good. Next, light will go here, and light will go here. This is rarer to denser medium. This is rarer to denser medium. So in rarer to denser medium, what happens? In rarer to denser medium, sir, it bends towards normal. It bends towards normal. है ना? ऐसा? Yes or no? Or I can just show it more nicely. Just a second. Towards normal bend. So we have to extrapolate it right now. Yeah, something like this. And this line also we are extrapolating. So we are getting the image somewhere over here. This is the virtual image of the bird that we are getting. This is the virtual image of the bird that we are getting. Are you all able to understand? Are you all able to understand? So for the fish, the bird will be at a much more greater height. This is the real height. This is the apparent height that I'm talking about. Now, as I told you, all distances should be calculated from the refracting surface. All distances should be calculated from the refracting surface. So this height, this is the real height. This is D. This is D for you. This is the apparent height. This is D dash for you. This is the D dash. We need to calculate D dash. We need to calculate D dash. So D dash becomes D divided by mu. What is D? What is the, is this height given? Yes, I think so. This height is given as 36 meter. This height is 36 meter divided by mu relative. Mu relative. Sir, what is mu relative? What is mu relative? Mu relative is from where to where? Finally, from where to where? Sir, it is going from air to water, sir. Light is going from air to water. So this becomes mu of air divided by mu of water. So 36 divided by 1 divided by 4 by 3. So this becomes 36 into 4 by 3. So this becomes 48 centimeter. Are you all able to understand this? Are you all able to understand this? Yes or no? So originally it was at 36 meter, but because of refraction, the fish sees the bird at a height of 48 centimeter. Or sorry, 48 meter. Apparent height. Apparent height. Now, what is the second question? The second question is find the apparent depth of the fish. Find the apparent depth of the fish. Find the apparent depth of the fish. Question 2. Now, depth of the fish. So obviously, bird is the observer right now. Bird is the observer right now. So light rays will go from fish to the bird. Then over here, this is denser to rarer. And this is denser to rarer. So it will bend away from the normal. It will bend away from the normal. This is basically the normal for you all. And so now we need to extrapolate it. So this becomes extrapolation. So this is basically the image that is getting formed of the fish. So originally it is here. Originally it is here. But the bird sees at the depth of this. So this is your original D. This is your D dash. This is your D dash. Yes or no? So over here, D dash is basically D divided by mu relative. What is D? What is D? Achha, it is 36 meter. Again 36 meter. Hai na? Divided by, from where to where? Light is traveling from where to where? It is traveling from water to air. So from water divided by air. So mu relative over here becomes mu of water divided by mu of air. Mu of air is 1. Mu of water is 4 by 3. So this becomes 36 into 3 divided by 4. So that is basically 27 meter. 27 meter. So this is 27 meters. Clear? Yes or no? Yes or no? Now what is the last two questions? What are the last two questions? At what distance will the bird appear to the fish? Will the bird appear to the fish? Will the bird appear to the fish? So this is already 36. This is already 36. See, it is very easy to understand. Very easy to understand. So the bird actually will be at a distance of 48 plus 36 meters for the fish. So the bird will be basically for the fish, the bird will be at a distance of 36 plus 48. है ना? 8 plus 6 14, 7 84 meters. So the fish will be like, arey, he is 84 meters high. He is 84 meters high. Okay, and for the bird, this is 36 and this is 27, है ना? So 36 plus 27, this becomes 63 meters. 63 meters now. Okay. Clear? Everybody understood this concept? Understood this concept or not? Yes or no? Understood this concept or not? Yes or no? Okay. Now, an air bubble in a glass slab with refractive index 1.5 near normal incidence is 5 cm deep when viewed from one surface and 3 cm deep when viewed from the opposite surface. The thickness in centimeter of the slab is how much? See this. This is the question. Good question actually. It's a good question. It's a good question. So this is a slab and it has an air bubble inside it. It has an air bubble inside it somewhere over here. Let us assume that the air bubble is somewhere over here. Okay. And let me assume that the thickness of the glass slab is T over here. Is it? It is T over here. Okay. It is T over here. And from this side, it is at a depth of X. And from this side, obviously, it will be at a depth of T minus X. है ना? Geometry. This is just geometry. है ना? Somewhat understood, sir. Yeah, you will understand. You will understand. Don't worry. है ना? You will understand. Don't worry. You can just recap it again, and you will be able to understand it. Okay. So the total thickness is T. Air bubble is somewhere over here. From this side, it is at a depth of X, and from this side, it will be up to depth of T minus X. Now, what it is written? So it is written when viewed from one side, it is 5 cm deep. So if I look over here, it is written that this depth for me it is 5 cm deep. But if I look from here, it is 3 cm deep. It is 3 cm deep. Now how to find this out? Now people, this is not the exact value that they are given. This is basically the apparent depth that they have given. The apparent depth. It is the apparent depth because they have already told you that an air bubble in a glass slab with refractive index 1.5 is 5 cm deep when viewed from the surface. So if you're viewing from the surface, due to refraction, you will only see the apparent depth, not the original depth. Okay, this is apparent. This is apparent. Okay. So D is equal to D, not D is equal to D dash. D dash is basically D divided by mu. Apparently you are able to see at 5 cm. Originally it is at X. Yes sir, originally it is at X. What will be mu over here? Mu will be 1.5, that is 3 by 2. This becomes 15 divided by 2, that is the X. Value of X comes out to be 15 by 2. Now from over here, what is the same formula I'm going to use? D dash is equal to D by mu. Apparently we are able to see it at 3 cm. Originally it is at T minus X. And what is the refractive index? It is 3 by 2 again. 3 by 2. What is the value of x? Value of x is 15 by 2. This comes out to be 9 divided by 2, which is basically t minus x. Value of x is 15 by 2. So this comes out to be 24 by 2. So 24 by 2 is basically 12 centimeters. So this is basically the thickness of the glass slab. Thickness of the glass slab. If you have understood this, please, can I have some can I have some fire in the chats, people? Can I have some fire in the chats? Yes or no? Yes or no? It's a good question. It's a good question. Now we are going to talk about total internal reflection. Okay, don't worry, we are going to visualize this and everything. Okay, we are going to visualize this and everything. Okay, we are going to visualize this and everything. Okay. Okay, chalo. What is total internal reflection? People, one thing that I have to tell you, that I forgot to tell you over here is, you know, whenever refraction happens, okay, whenever refraction happens, okay, whenever refraction happens, you have to understand reflection also happens. You have to understand reflection also happens. So some part of the light, some part of the light will get refracted and some part will also get reflected over here. And obviously this is going to follow law of reflection. If this is angle I, this also will be angle I. Okay. So in refraction you have to understand, yeah, some of the light will get refracted and some light will get reflected also. Clear? It is not something like all the light will get refracted. No. Some part will get reflected and some part will get refracted. Okay. Very good. Coming back to total internal reflection. What is total internal reflection? Now people, you have to note, very important, total internal reflection only takes place when light travels from denser medium to rarer medium. This is only possible from denser medium to rarer medium. Not possible in other mediums, okay? Not possible from rarer to denser, no. Okay, now let us understand what is happening over here. Okay? Now, see, Jayalakshmi, I had said two things. The first thing was that whenever refraction is taking place, reflection also will take place. I don't know if you are able to see this. or not. Are you able to see? See, this refraction is taking place, but also reflection is also taking place. Are you able to see this faint green light? Faint green light over here? I'm not sure if you are able to see this or not. Let me just see. No, it's not visible. Yeah, so what I'm saying is, whenever refraction is taking place, reflection also will take place. So some light is getting refracted and some light will also undergo reflection as well. Okay. Now let us understand total internal reflection with the help of a visualization. Okay. So ray, I know, need from denser to rarer, hai na? So this becomes water and this becomes air. See this, people. See what is happening. Lights on. See, this is what exactly is happening. See this. This is denser medium. This is denser. This is rarer. So light is bending away from normal. Denser to rarer, away from normal. So some of the light is getting refracted and some of the light is also getting reflected also. Okay. Now see what happens. As I increase the angle of incidence, over here, what happens? See this. What is happening? There comes an angle. There there comes an angle where the angle of incidence, where the angle of reflection, the angle of refraction becomes 90 degree. The angle of, see, what is angle of refraction? What is angle of refraction? This is angle of refraction, right? This is angle of refraction. This is angle of refraction. So for one particular angle of incidence, for one particular angle of incidence, the angle of refraction becomes 90 degree. And greater than that, all of the light gets reflected inside. This is called as total internal reflection. And in this also you can say that this is angle I and this is angle R, and angle I is equal to angle R. Are you all able to understand this? Are you all able to understand this? Yes or no? Yes or no? I have one more diagram. Don't worry. I have one more diagram to make you understand. One more diagram to make you understand. See this. This is mu1 and this is mu2. So mu1 is greater than mu2, है ना? Denser to rarer. Earlier it was just going straight. So no bending of light, no bending of light. Okay. Now right now it is incident at some θ1 angle, so it is getting bent over here. Now here it is incident at some third θc angle. है ना? It is incident at some C angle. It is getting refracted something like this. If you increase the angle even more, it will start getting reflected inside. Are you all able to understand this? Are you all able to understand this? So as you increase this angle also keeps on increasing. For one particular angle, the angle of refraction becomes 90 degree. And that particular angle is called as critical angle, in which the angle of refraction becomes 90 degree. That angle is called as critical angle. Clear? Yes or no? Is this absolutely clear? Now I can basically derive a equation over here which is very important for your exam point of view. I'm going to apply Snell's law over here. Okay. So mu into sine of IC, that is critical angle, is basically equal to mu into, that is, this is mu of denser into mu of rarer sine 90 degrees. Sir, why sine 90 degrees? Because here angle of refraction is 90 degree and this is critical angle. So I get sine of IC. I get sine of what is happening? Sine of IC as mu R by mu D. Or I can even say that the critical angle is mu R, or sine inverse of mu R divided by mu D. Clear? Yes or no? Hello? Very, very important, people. Very, very important. Very, very important. Okay, so this is one formula that you have to keep in mind. What is critical angle, people? Voice is breaking. I don't think so. Voice is breaking. Okay. What is critical angle? The angle of incidence in which the angle of refraction becomes 90 degree is called as critical angle. Okay. And if the angle of incidence is much greater than critical angle, all of the light will get totally internally reflected. Okay. Totally internally reflected. Let us solve some questions. Achha, before the solving of questions, I want to explain this Snell's window. Okay, I want to cover Snell's window. Achha, is it breaking sometimes? Is it fine now? Is it fine now? It's perfect now. Okay, now I want you all to understand Snell's window, which is actually an application of total internal reflection. Now in can we say object apparent height will be 0 if the rays hit the surface at theta c. Yes, eternal being. Yes. Okay. Now you must have all seen this diagram in a Discovery Channel or National Geographic Channel. Whenever they go underwater, you are only able to see a circle part of the world. Rest everything is black. This is called as Snell's window, or circle of illuminance, and this has some radius r. This is the radius that we're going to find out in the next part. This is the radius that we're going to find out in next part. Okay. See it over here. Circle of illuminance. Now, why does this circle of illuminance take place? See, people, in order for you to see the world, light should enter your eyes. Yes or no? Yes, light should enter your eyes. Otherwise, you will not be able to see the world. That is the same process which applies in Snell's window as well. See this. If this is you, okay, this is you, hai na? So what is happening? What is happening over here? Light rays are, just going over here. So this is denser to rarer, okay? So no bending of light. So over here bends away from normal, no problem. Over here bends away from problem, no problem. But there is one angle. If you all notice, there is one angle, that is the critical angle in which the angle of refraction becomes 90. The angle of refraction becomes 90. No light will pass through this, or only the light will pass from this radius. Only the light will pass from this area or from this radius. Because at this angle, all of the light will get refracted at 90 degree, and beyond this angle, all of the light will get totally internally reflected. It will not go ahead. It will not go ahead. Are you all able to understand this? Are you all able to understand this? Yes or no? Yes or no? So if you are able to, so same things happens in this direction also. See this, light is going to travel. Okay, light is going to travel. Light is going to travel. Okay, no problem. But at this angle, this light gets refracted over here. Light is not able to cross this. And if the angle is more, it will get totally internally reflected. That is the reason you get a circle over here. You get a circle over here. And in only this circle, you are able to see the outside world. Is it clear? Is it clear? Okay. Whenever you want to solve circle of illuminance problem, okay, only two methods you have to use. This is radius r, this is h. You have to find out two things. First, sine of IC, that is basically equal to mu r divided by mu d. This is the first step. And then second is tan of IC. You basically calculate these two things and then you are able to find the value. Okay. Okay, yes or no? Okay, yes or no? Just two methods. So just two things, two steps. First sine IC, second tan IC. That's it. Okay. For example, this problem, see this. A disc is placed on surface of a pond which has refractive index of I by 3. A source of light is placed 4 meters below the surface of the liquid. The minimum radius of the disc such that light will not come out. So this is the water surface that I'm talking about. This is the water surface that I'm going to talk about. Water surface. Yes or no? Okay. I have a light source over here. I have a light source over here. This is the light source. Okay, light source. Okay. And the height over here is, what is the height over here? 4 meters below. Achha, this is 4 meters below. 4 meters. This is 4 meters below. Very good. Okay. And let me assume the radius of the disc should be r. The radius of the disc is r or something. Okay. This is the radius of the disc. Okay. This is r. This is 4. So obviously, how this disc will get formed? Light is going to come from here. It will bend away from the normal. Light is going to come from here, bend, go away from the normal. But over here, the light will strike over here and the angle of refraction is going to be 90 over here. Yes or no? Okay. So light is basically going to travel. Light is basically going to travel like this and then get refracted over here. Okay. And if you want to draw a normal, you can draw a normal over here. No problem. So over here you are able to find out that this is angle IC, this is also angle IC, and this is 90 degree for you. This is 90 degree for you. Now let's calculate. So what is sine IC? Sir, sine IC will be mu rarer divided by mu denser. What is mu rarer? Mu rarer is air. No, this is air. Mu denser, 5 by 3. 5 by 3. So sine IC is 3 by 5 actually. Sine IC is 3 by 5. Sine IC is 3 by 5. So opposite by hypotenuse. So this becomes 3 and this becomes 5. So radius should be 3 meters. Simple. Simple. Clear? Very good. Very good. Very good. Okay. Yes, I've already mentioned it, people. How many times should I mention it? I've already mentioned it. If you just keep on spamming, it does not mean that you'll get a response, no? Okay. That's it. Chalo. Now some applications of TIR, people. Some applications of TIR that you should know. Hai na? What is it? Prism. Prism is one of the applications, and optical fiber is one of your applications. Optical fiber is used for internet connectivity, for transmitting messages and everything. In this you have a cladding and as well as a core. Okay, core and cladding. Okay, so this is called as the core. This is the core, and this is basically the pathway through which the light undergoes total internal reflection and it travels. Now this core is coated by another protective covering called as the cladding, and this cladding is covered with some plastic coating as well for extra protection. This works under total internal reflection. Okay. Okay. Now this prism also works under what? Total internal reflection. See, it is coming over here, getting totally reflected, Coming over here to TIR, 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 TIR. Even rainbow, brilliance of a diamond, the shine of a diamond, all applications of total internal reflection. Okay. No break, Mobina, because we have to complete a lot of things. No break. We have to complete a lot of things. Okay. Just a second. Okay. And I've given you the extra information as well. You can all read, because obviously you will be getting the notes. Okay, you will be getting the notes. Now people, very, very important thing, prism. We're going to start with prism. Okay, we're going to start with prism. When will we break, sir? I don't know. Let's see. Do you want a break? Do you guys want a break or something? So we started the class around 10 o'clock, right? It is acha. Okay, I'll give you a break around 12:30 or something. Okay, I'll give you a break around 12:30. Okay, 12:30. Okay. So what is a prism? A prism is basically a transparent homogeneous refracting medium bounded by two plane surfaces inclined and subangle. That is the definition of a prism. What is a prism? It is a transparent homogeneous refracting medium bounded by two plane surfaces inclined and subangle. That is exactly what prism is. Okay. Okay. Chaliye. Now let us understand all the parts of a prism. All the parts of a prism, very, very important. Okay. This angle is called as, this angle is called as A, or it is called as angle of the prism, angle of prism, or refracting angle. It has two names, angle of prism, या prism angle, or refracting angle, है ना? Two names. Yeah, I'll give you after some time. Okay. Now what happens is, what happens over here? Let me guess that this is mu surrounding for you, and this is mu prism. Okay, this is mu prism, and obviously mu prism, the refractive index is much greater, है ना? It is much greater. So what happens over here? Light is incident over here. Yes or no? Oh yes, sir. Then I have to draw a normal over here. Okay, just let me draw a normal. Yes, this is my normal. This is my normal. Okay, this is my normal. So light is going from rarer to denser medium. So bend towards normal. This is gonna bend towards normal. So see, it bend towards normal. Then again I have to draw a normal. Again I will draw a normal. Let me just extrapolate this normal. Okay. Again I will draw a normal. Yeah, something like this. Yes or no? Yeah. Then this is from denser to rarer, away from normal. Denser to rarer, away from normal. Clear? Okay. ठीक है, चलिए. So this is called as incident angle. Incident angle. This is the first refracting angle. The second refracting angle. This is called as the angle of emergence. Okay. Yeah. Draw is equal to away. Denser to rarer, away. है ना? Okay. Now what do we need to find out over here? Now what do we need to find out over here? Okay. Obviously you can apply Snell's law. You can apply Snell's law. That is something that you can apply. You know, that is something that you can apply over here. But there are a lot of things that you should know over here. Lot of things that you should know. First thing, if the glass slab would not have been there, this would have been the path followed. This would have been the path followed by this incident ray. So can I basically say that this is gonna be the deviation del 1. Yes sir. And if the glass slab would not have been there, okay. So can I basically say this is del 2 also? This is del 2. Okay. Weightage is weightage is there, people. That is the reason I've already told you it's an important chapter. Hai na? So first thing, you already know how to apply Snell's law. You already know how to apply Snell's law and everything. Hai na? You can apply Snell's law over here. You can apply Snell's law over there, and you already know all sorts of things. The first thing that you have to note over here is that R1 plus R2 is equal to A. This is the first thing that you have to note over here. First thing that you have to note over here, that R1 plus R2 is equal to A. This is the first thing that you have to note. Okay, that is R1 plus R2 is equal to A. Okay, sir. More. So can I find out the deviation? Yes, you can find out the deviation. The deviation del 1 can be written as, this is also angle I, this is also angle I. Can del 1 be written as I minus R1? Yes, I can write this as I minus R1. Similarly, can I write del 2 as E minus R2? E minus R2. E minus R2, del 2. Yes or no? So what is the total deviation? The total deviation can be written as I plus E minus R1 plus R2. This is basically the total deviation. Or I can even say that this is I plus E minus A. Sir, how minus A? Because R1 plus R2 is A. Yes or no? Yes or no? Okay, clear. Okay, so this is what I had to tell, and this is one more diagram which is already given. Hai na? This is one book diagram. Okay, I've already drawn it just for you all to understand. Hai na? Now we have to understand minimum max deviation. Okay, now we have to understand minimum max deviation. Okay, let us understand minimum max deviation. Now people, when do we get minimum or maximum deviation? When do we get minimum deviation, maximum deviation? When do we get it? When do we get it? Now people, you have to understand that minimum deviation, hai na, it occurs when I is equal to, sorry, I is equal to A. Sorry, array yaar. I is equal to E and R1 is equal to R2 is equal to A by 2. This is the condition for minimum deviation. Condition for minimum deviation. And if this is the condition, can I basically say that I already know that del is basically equal to I plus E minus A? Yes or no? So del minimum becomes 1 plus E, I can write it as 2I, and A I can write it as, yeah, A I can write it as this A itself. Okay. Okay. Yes or no? Okay. So this is one formula that you have to keep in mind. Next formula that you have to keep in mind, that mu is basically sine of A plus dm the whole divided by 2, the whole divided by sine of A by 2. Sine of A by 2. This is one formula that you have to keep in mind. This is one formula that you have to keep in mind. Okay. I'm not going to basically derive this formula. This is not needed also, hai na? This you derive in your engineering and everything. This is not required, but this is the formula that you have to keep in mind. And many questions are asked from this formula itself. Okay. Now if you notice in this graph, people, this is the graph between deviation and angle I. If you all notice over here, you will notice that, see, very important. For one particular deviation, you are getting two angles. That is, for one deviation, you are getting two angles. What does this mean? Obviously, because, no, I'm not sleepy. Because if you all notice, if this is angle I, so some light ray is going in this direction. So this is angle I and this is angle E. So one light ray can enter from here also, right? With angle E as the angle of incidence and leave with angle of emergence as angle I. Are you all able to understand? If a light ray is entering with angle I and leaving with angle E, I can also enter with angle E and leave with angle I. That is the reason I am getting, for the same deviation, I am getting two different angles. But for the minimum deviation, I am only getting one angle. That is I is equal to E. Clear? 100%? Yes, sir, 100% clear. Now, over here, this is small angled prism. Small angled prism. Same. Everything is same, people. Everything is same. Just that you have to understand, over here, angle A, hai na? Angle A, angle R1, angle R2, angle I, angle E, all are small. That's it. This is the only thing that you have to keep in mind. So the formula also is same. What is the formula? So mu is equal to sine of A plus dm divided by 2, the whole divided by sine of A by 2. This is the formula. Yes or no? Yes, sir. This is the formula. But we know, for small angles, sine theta is approximately equal to theta. So mu over here becomes A plus dm divided by 2, the whole divided by A by 2. 2 and 2 gets cancelled. So what do I get? I get 1 plus, A plus dm divided by A. Multiply on both sides. This becomes mu into A is equal to A plus dm. Yes or no? So dm over here becomes A into, or mu minus 1 into A. Formula. Same formula. It is the same formula. Just the angle is small, and that is the reason we have got a new formula over here. You can keep this in your mind. Yes or no? How many people are still there? People? क्या बात है, कैसे हो प्रियल, कैसे हो प्रियल? हाँ जी. So this is done. Now let us solve one question. Okay, let us solve two questions. Let us solve two questions. Okay. Okay. Okay, let us solve this. What is it? The refracting angle of a prism is A. Refractive index of the material of the prism is cot A by 2. The angle of minimum deviation is how much? है ना? Angle of minimum deviation is how much? So basically they have told this is the refractive index. So mu is basically equal to cot of A by 2, cot of A by 2, which is basically equal to sine of A plus dm divided by 2, and this becomes sine of A by 2, है ना? Okay. Now can I write cot A by 2 as cos A by 2? Cos A by 2 by sine A by 2? Yes, I can write it as cos A by 2 divided by sine of A by 2. Yes or no? Yes sir. Which is basically equal to sine of A plus dm the whole divided by 2 divided by sine of A by 2 divided by sine of A by 2. Over here sine of A by 2 gets cancelled, है ना? So this becomes cos of A by 2 is equal to sine of A plus dm divided by 2, है ना? Okay. Now can I write cos of theta as sine of 90 minus theta? Can I write? Huh? Can I write cos of A by 2 as sine of 90 minus theta? Yes or no? So I can write this as sine of 90 minus A by 2 is basically equal to sine of A plus dm divided by 2. Okay. So you can basically remove the sine function over here. So this becomes 90 by A by 2 is basically A plus dm by 2. है ना? Multiply 2 on both the sides. So what do I get? I'm basically solving it over here. This becomes 180 minus A, which is basically equal to A plus dm. A plus dm. This goes to the right side, left side. So this becomes 180 minus 2A. 180 minus 2A, that is your answer. I'm not able to understand. I'm not able to understand. I am the one who's standing here and teaching. I'm teaching since 6 or 7 hours. Still you need break. Still you need break, huh? See, I've already told you. I'll give break around 12 o'clock, 12:15. Okay? I've already told you that I'll give you break around 12 o'clock, 12:15. Okay? Okay. This is a good question. This is a good question, people. This is a good question. क्या है? The refractive index of the material of a prism √2 and the angle of the prism is 30 degrees. One of the total two refracting surfaces of the prism is made a mirror inwards by silver coating. A beam of monochromatic light entering the prism from the other face will retrace its path after reflection from the silver surface if it is an angle of incidence on the prism is. Okay. Now, sir, for you only. No, I don't need break right now. I don't need break right now. So this is the prism. This is basically the prism that I'm talking about. And the angle of the prism is given as 30 degrees. Angle of the prism is given as 30 degrees. Now, I have silvered one of the surfaces. Over here. Okay, I have silvered one of the surfaces over here. Now, what are they saying? That a beam of monochromatic light entering the prism from the other face will retrace its path. Now, when will it retrace the path? Principle of reversibility. Principle of reversibility. What is principle of reversibility? Principle of reversibility states that the light will retrace the path if it strikes at 90 degrees to the plane mirror. Yes or no? So that means a light ray will basically incident something like this. This is rarer to denser, that is towards normal it will reflect as something like this. 90 degree, and because of this it's going to retrace its original path. Are you all able to understand? Yes sir, we are able to understand. Okay, clear people, clear everybody. Now the refractive index is root 2 over here. Let me guess, this is the normal. This is the normal. Okay, this is the normal. This is angle I for you. This is angle I for you. This is angle R1. Okay, this is angle R1. Okay, now if you notice over here, what is angle R2 over here? What is angle R2 over here? If I construct a normal over here, can I basically say that angle R2 is 0? Angle R2 is 0. Yes, sir, angle R2 is 0. And I also know angle R1 plus R2 is basically equal to A, which is basically equal to 30 degrees. If R2 is 0, R1 becomes equal to A. So R1 is also 30 degrees. So R1 is 30 degrees. R1 is 30 degrees. So this becomes 30 degree. This becomes 30 degree. So applying Snell's law over here, I get, this is air, right? So sine I, 1 into sine I is basically equal to root 2 into sine of 30 degree. Clear? 45 degrees is your answer. 45 degrees is your answer. Clear? Are you all able to understand this? Clear? Yes or no? Now we are going to start refraction at spherical surfaces. Now we're going to start refraction at spherical surfaces. Or do you want a break, people? Do you want a break right now? You want a break? You want a break of 15 minutes or something? Do you want a break of 15 minutes or something? We'll take a break of 15 minutes. Then we can start at 12 o'clock. Okay, we can start at 12 o'clock if you want. Okay, if you want, we can take a small break. Okay, I'll also fill my water bottles and come. Okay, so 15 minutes break I'm gonna give you. Okay, just 15 minutes break. Okay, not more than that. Okay, 15 minutes break. Okay, 15 minutes break, and then we are gonna start by 12 o'clock. Okay, 12 o'clock. Okay, how many more topics? So refraction at spherical surface, it's a very small topic. Then lens, that's it. Lens, combination of lens, that's it. Okay, then I think more 2 or 3 hours, and then we can finish it. Okay, people, so just 15 minutes break, and then we can go. Okay, 15 minutes break starts now. अभी एसी कम करके रखा है। Hello, 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 hello. Hello, hello, hello. I'm always back on time. Yeah, I'm always back on time. Yes. So yeah, see the thing being key actually like the J main paper. So I saw your comments. The J main paper of 2025 actually was way easier. Was very easier. I think NTA they accidentally flipped the question paper of NEET with J and the question paper of J with NEET. And I think NEET 2025 students got the J paper and the J people got the NEET paper. And I think so that's what happened. Okay. See. Okay. I have read your comments, people, that take the PYQ classes in English. Okay, I've read it. I've read it. Okay. But see, I'm not the one who takes the decisions over here. है ना? I'm just helping Yavar sir over here. What you can do is you can go to any of the video section or any of the live video which has already happened. You can comment down there that you want so and so session from so and so teacher. The team and the management will see it and will act accordingly. If you say this in a live session, nobody will see it in this middle of the night. So what you can do is, yeah, I will cover it. I will cover optical instruments. Okay. So what you can do is go to any video which has been uploaded, go to any live which has been completed, go there, comment down, the team and the management will see it and they will act accordingly. That is it, what I can say. Okay. Simple. Okay. Yeah. People, so see, I've already told you that I've already laid the foundation. I've already laid the foundation. That is concave mirror and everything. The starting of the lecture, whatever I have told you. Now, refraction on spherical surfaces. It's a very small topic. It's a very small topic. Then we are going to jump to thin lenses. Okay. Then we're going to jump to thin lens. Then lens formula and combination of lens and mirror, cutting of lens and that's it. That's it. Only very little less is remaining. Okay. Very little less is remaining. So let's just finish it in an hour or 2 hours. Okay. Max to max 2 hours, people. Okay. Max to max 2 hours. Max to max 2 hours. Okay, people. Max to max 2 hours. So let me see. I think I will be completing it by, I think now it is 7 hours, right? Yes, I think it's, yeah, now it's 7 hours. So I will be completing it by 2 a.m. Okay, 2 a.m. is the maximum time. Before that, we'll try to complete it. Are you all ready, people? Are you all ready? I don't know. I just drank. Uh, I just drank a hot cup of coffee right now, full of energy. Yes. Okay. What is the number of images formed if angle is 50 degree and placed symmetrically? So just calculate it with the technique that I taught you, know, in the starting class. So 25, 25, 25 plus 50, 75. This will be 75. Then again 50 added. I've already taught you. I've already taught you. Okay. So let's see. Okay. Let's see. Okay. Chalo. Now refraction at spherical surfaces. Nothing to worry about, people. You already don't know everything. Sign convention. I've already taught you. Everything I've already taught you. I've taught you literally everything. You just need to apply the formula that I'm going to give you. That's it. That's it. One thing that you have to notice is, one thing that you have to keep in mind is, all of the normals that you're going to draw right now, all of the normals that you're going to draw right now will all pass through the center of curvature. Will all pass through the center of curvature. Any normal that you're going to draw will all pass through the center of curvature. Are you all able to understand? Arey yaar, this thing. People, just give me, just this is a glitch actually, है ना? Okay, this is a glitch actually. Just this is a glitch. Just I'll have to save this. Arey yaar. Just a second, people. Just a second. Okay, just a second. Just a second. Just a second. Just let me save this. Otherwise, it'll go. It'll all go in waste. You'll not get notes only. And just a second. Just let me save this file, and I have to basically reopen this file. है Just a second. Just a second. Okay. Otherwise, you'll not get your notes, and all of my hard work will go into waste. है Just a second. Okay. Just a second. Yeah, it's a big file. It will take some time, but yeah. Yeah, just a second. Exit and ray optics. I have to open ray optics. Downloads. Yeah. What is this? Fine. Just a second. Exit. Open with note. Yeah. No, it's not my birthday. It's not my birthday. Don't worry. The voice is clear, right? Is the voice clear? Is the voice clear, people? I hope so. The voice is clear. Yes. Okay. So as I was saying, any normal that you draw right now, it will all pass through the center of curvature. It will all pass through the center of curvature. Any normal that you draw would pass and should pass through the center of curvature. Okay. Over here also, any normal you draw, it would pass through the center of curvature. It should pass through the center of curvature. It should pass through the center of curvature. That is one thing that you should know. Okay, perfect. Okay, very good. Now, coming back. Okay, people. So what about the sign convention? The sign convention still remains the same. I've already taught you the sign about the sign conventions. See this. Okay, where is it? Okay, I'll give you the formula. Okay, I'll give you the formula. It is N2 by V minus N1 by U is equal to N2 minus N1 divided by R, or mu2 by V divided by mu2 by U is equal to mu2 minus mu1 divided by R. This is the formula. This is the formula. Okay. Now, this is basically the formula. Now, how to understand, sir, which is N2, which is N1, and which is basically N1 and N2? Nothing to worry about. See this, people. See this. If this is the incident ray, obviously this is going to be negative direction and this is going to be the positive direction. Okay, simple. Okay. The surface which the light strikes first is your N1. So this is your N1 and this is your N2. That's it. This is how you decide it. This is how you decide it. So incident ray, it decides your minus and plus. So this is your plus and this is your minus. First it strikes the N1 surface and then the N2 surface. Clear? 100%. This is your formula. This is your formula that you have to keep in mind. Okay. This is the formula that you have to keep in mind. Just a sec, people. I think I am missing out something. Just let me check. Yeah, okay. Okay, people. Clear? Okay. Now, what about the magnification formula? Sir, magnification formula is basically height of image divided by height of object. Here it becomes here it becomes N1 divided by N2, and this becomes V by U. Yes or no? Is the formula clear? Is the formula clear, people? Yes, N1U divided by N2U. Okay, this is the formula for magnification. Rest, everything stays the same. Everything stays the same. No problem whatsoever. No problem whatsoever. Let us solve. Let us solve over here. Now see, I don't have to repeat things, but still I can just basically say this is the incident ray. So this is negative, this is positive. So this is positive direction, this is negative direction. Light is coming from here. So this is negative, this is positive. See, this is khatam. Light is coming from here. This is negative, this is positive. Finish. Light is coming from here. So this is positive, this is negative. Okay. Okay. Chaliye, let's move ahead. Now, this is something important, people. This is something important. The first focus and the second focus. Okay, all of the refracting surfaces, the lens, the refracting surfaces, they have two focuses. The first focus or the primary focus, which is also called as the primary focus, and the second focus as well. Now, what is this primary focus? What is this first focus, second focus? Chalo, let us understand. Let us understand. What is written? The first principal focus or the first focus is the point on the axis where when an object is placed, the image is formed at infinity. Meaning if this is the refracting surface, or also if this is the lens, or if this is the lens. Okay. Now, what is the first focus? First focus is that point on the principal axis. If you keep an object on that point, the image will be formed at infinity. That point is called as the first focus. Sir, what about the second focus, sir? What about the second focus? The second focus is basically that point in the principal axis. If an object is kept at infinity, the image will be formed at this point. Are you all able to understand? Are you all able to understand, yes or no? Are you all able to understand, yes or no? I'm going to repeat it again. What is first focus? First focus is that point on the principal axis where if the object is kept, the image will be formed at infinity. What is second? What is the secondary focus? Secondary focus or the second focus is basically that point on the principal axis. If the object is kept at infinity, the image will be formed at that point. Two focuses. Two focuses. Okay? I think it's self-explanatory. This is the object, image is formed at infinity. Object is at infinity. Image will be formed at f2. Okay? Okay, I hope so this is clear, Thima. Yeah, Thima, have you understood it? Okay, moving on. Let us solve. Let us solve, people. Let us solve. Come on, let us solve. Let us solve. Let us solve. Let us solve. I have an object over here. I have an object over here. 20 centimeter over here. This is air and that is N2. Sir, incident ray would be in this direction. That means this is negative, this is positive. So let us use the formula. Let us use the formula. What is the formula, sir? It is N2 by V minus N1 by U is basically equal to N2 minus N1 divided by R. This is basically the formula. Hi, Anna. Yes, sir. This is the formula. Now, this is N1 for you right now and this is N2 for you right now. Okay? Yes, sir. Because the light is striking the air first. Okay? So N2 is 4 by 3. Yes, sir. N2 is 4 by 3. V, I do not know. V, I have to find out. N1 is air. So this becomes 1 divided by U. Now, what is U? What is U? It is minus 20. Minus 20. So minus 20 minus minus becomes plus over here. So this becomes 20. Which is basically equal to N2, that is 4 by 3 minus 1 divided by the radius of curvature. Divided by the radius of curvature. This is the radius of curvature. This is radius. Radius is in this direction. This direction. Plus, plus. So this is plus 20. Yes or no? Clear? Now let us solve this. This becomes how much? 4 by 3. This is 3 by 3. 1 by 3. So this becomes 1 by 60. Yes, this becomes 1 by 60. This fellow, this becomes 4 by 3V is basically 1 by 60 minus 1 by 20. Okay, this is into 3 and this is also into 3. So finally this becomes 1 minus 3, that is minus 2 by 60. Minus 2 by 60. Okay, minus 2 by 60. Okay, so 1s are and this is 30s are, है ना? Minus 1 by 30. So 3 1s are and this becomes 3 10s are. Okay, so the value of V comes out to be minus 40. Did everyone get minus 40 centimeter as your answer? Did everybody get minus 40 as your answer? Minus 40. Everybody minus 40 as your answer, yes or no? Now, how to understand if it's a virtual image or a real image? You can understand by the sign itself. Now, you do not have to follow the mirror one, okay? Please do not follow the mirror one. See this. Very easy to understand. O over here, it is at minus 40. Minus 40 meaning? Minus 40. That means image is somewhere over here. Image is somewhere over here. Ha, sir. Image is somewhere over here. Yeah, got it. Very good. Hai na? This is from rarer to denser. Rarer to denser. So, I'll tell you how is it. This is radius, no? So this is basically focus would be somewhere over here and center of curvature would be over here. So normal would be something like this. Yes, this is the normal. So this is from rarer to denser, that is towards normal. Rarer to denser, towards normal it would shift, no? Something like this, and then extrapolate, and this is the image that you're getting. And one more path, one more light, you can go something like this, hai na? Undeflected it will go. So virtual image. Got it? Very good. So this is a virtual image, hai na? You can basically test yourself if it's a virtual image or a real image with the help of a diagram. Okay, cool. Next. Okay, this is a one more refracting surface, people. So I will basically say, sir, incident ray something like this. This is negative, this is positive. Formula is N2 by V minus N1 by U is N2 minus N1 divided by R. This is the formula that I am getting. Please solve. N2 is 2 over here. So this is 2 divided by V minus N1 is air. So 1 divided by U. U is in the negative direction. So minus 30. This is minus 30. Minus becomes plus. So this becomes 30. N2. What is N2? This is 2 minus 1. This is 1 divided by R. R is in the negative direction right now. How much is it? 20. That is minus 20. This becomes minus 20 for you all. Okay, very good. So this becomes 2 by V is basically minus 1 by 20 minus 1 by 30. This is what I am getting over here, hai na? So I am giving 3 over here, I am giving 3 over here, I am giving 2 over here, I am giving 2 over here. So this becomes minus 5 divided by 60 over here, or this becomes minus 1 by 12 over here, hai na? Minus 1 by 12. So V over here becomes minus 24 centimeter. Minus 24 centimeter. Yes or no? Yes, R is negative. Did everyone get this value? Did everyone get this value? Yes or no? Did everyone get this value? Yes or no? Now let us try to find out whether it's virtual, real or anything. Very easy to understand. See, it's in the negative direction. Same direction as the object. So obviously it will be virtual image. V is minus 24. So somewhere over here you are getting the image. You are getting the image somewhere over here. Hai na? So rarer to denser, towards normal, no? Towards normal it's going to refract. Okay, people. Yes. So you are able to understand this is going to be something like this. This is going to be something like this. This is 20, 24. Okay, the center of curvature will be somewhere over here. This is the center of curvature, hai na? So this is the normal. So O from here it will go. This is from rarer to denser, that is towards normal, it's gonna refract, something like this. And yeah, virtual image. Okay, so again you're getting a virtual image. Next, thin lens. Now we're gonna start with thin lens. Okay, we're gonna start with thin lens. Okay, people, everybody able to understand? Yes or no? Chalo. Now lens. Now people, you have to understand there are various types of lens which are available. Biconvex. Sir, what is biconvex? R1, R2. This is biconvex. Equiconvex. Both the surfaces are of equal radius. Plano-convex. One is plane, other one is convex. Concavo-convex. This is not concavo, it is concavo. Okay, concavo-convex. R1, R2. This is convex and this is concave. Biconcave. Equiconcave. Plano-concave, convex or concave. Now how to identify which one is what? The second name, है ना? The second name tells you its nature. The second name tells you its nature. Second name. So this is a convex lens. This is also is a convex lens. This also is a convex lens. This is a concave lens. This is a concave lens. This is a concave lens. This is also a concave lens. The second name tells you its nature. Okay, the second name tells you its nature. So sir, what is this, sir? What is this? It's a concave lens. What is this? It's a concave lens. Again, what is this? It's a concave lens. The second name tells you its nature. Now people, one more misconception that I have to make clear. People, what does a convex lens do, sir? What does a convex lens do? Does it diverge or does it converge? What does a convex lens do? Does it converge or does it diverge? Tell me, come on, tell me fast, come on, tell me fast, and also like the video, Tell me. What is the question? The question is, what does a convex lens do? Does it converge or does it diverge? Yes, tell me. Exactly. Eternal being is very right over here. Eternal being is very right over here. I have to tell you people that convex lens doesn't mean that it is it's a converging lens. It's not, it does not. This is wrong. And concave lens diverges. This is also wrong. Sir, why wrong, sir? Because from earlier classes we are just studying this. Yes. No, you're all wrong. Eternal being is right. Convex lens does not mean that it's a converging lens. No. Concave lens does not mean it's a diverging lens. No. Now you will be like, sir, but no, sir. From 10th standard we are studying, sir. Concave is diverging, sir. Convex is converging, sir. No, sir. How is this possible? Because in 10th standard you only had air as a medium. Right now you can have anything as a medium. People, convex and concave, they just represent the geometry of the lens. A lens will be converging or diverging depending upon the medium, depending upon the refractive index of the lens. Are you all able to understand? Yes or no? So convex and concave are just the geometry. So if it is thick in the middle, it's a convex lens. If it is thin in the middle, it's a concave lens. But whether the lens is going to converge or going to diverge, it depends upon the medium, and it also depends upon the refractive index of the lens. Are you all able to understand this? We're gonna solve a lot of questions about it. We're gonna solve a lot of questions. I'm gonna prove that to you. So what does a lens depend upon? So the convex and concave, they are just geometry. If it is thick, it's convex. If it is thin, it is concave. Sir, what about diverging and converging? Depends entirely upon the surrounding medium and also the refractive index of the lens. So are you saying that a concave lens can also be a converging lens? Yes. Are you saying a convex lens can be a diverging lens? Yes. Because it depends upon the medium, it depends upon the refractive index of the lens. Okay. Lens maker formula, very important. What is lens maker formula? Lens maker formula is basically 1 by, or I can basically say 1 by V minus 1 by U is basically 1 by F equivalent is basically equal to mu lens divided by mu surrounding minus 1 upon R1 minus 1 upon R2. This is basically your lens maker's formula. Are you all able to understand this? How can we say that concave convex difference? Yeah, that is what I'm saying, Mubina. Concave and convex lens is basically just the geometry. If it is thick in the middle, then it's convex. If it is thin in the middle, it's concave. That's it. You can't comment about the diverging power or the converging power of it. You can't talk. You can only talk about it when you know the refractive index of the lens and also the refractive index of the surrounding medium. Okay. Yeah, this is the formula. This is also called as the lens maker formula. Okay, now how to understand? Sign convention still remains the same. Sign conventions all same, everything same. Sir, incident ray in this direction, so this is negative, this is positive. It strikes this surface first, so this becomes R1 for surface. This is the second surface. Automatically, this becomes the second surface. Clear? Clear? Am I clear or not? Am I clear or not? Okay. And one more thing, yeah, one more. You can add one more thing into this formula. You can also tell this as, this is basically power. This is also power because 1 by F is equal to power. 1 by F is equal to power. Okay, 1 by F is equal to power. So this is lens maker formula for you all. Moving on. Question. Let us try to find out question. Acha, one more thing. One more thing. In mirror, if you remember in the case of mirror, I already told you in the case of mirror, F is basically R by 2. F is basically R by 2. Hai na? I've already told you about this. That F is basically R by 2. This is correct. But in lens, F is not equal to R by 2. Okay, F is not equal to R by 2. Not equal to R by 2. Okay, you have to remember this. So because some people can come, no, Arey sir, you want to find the focal length? Arey sir, radius of curvature is 20, focal length will be 10. No, wrong. It is wrong because focal length depends upon the medium and it depends upon the lens also, the refractive index of the lens. So you can basically write also that F depends on lens mu and surrounding mu. Okay, yes, for paraxial rays, yes. Okay, let us try to find out. So sir, are you basically saying that if I change the medium, the focal length would change? Yes, that is exactly what I'm saying. Oh, okay, let's find out. Chalo. I'm going to basically say that incident ray is coming from here. So this is positive, this is negative. This becomes R1 and this becomes R2. Okay. Now, what is the formula? The formula is 1 by F is basically mu of lens divided by mu of surrounding minus 1. Okay. And this becomes 1 by R1 minus 1 by R2. This is basically your formula. This is basically your formula. Okay. Chalo, let's find it out. Okay. Which is basically equal to mu of lens. What is mu of lens? 3 by 2. What is mu of surrounding? It is 1 only, air. Hai na? So 3 by 2 minus 1. Very good. Now 1 by R1. R1, this is R1 for you all. Radius is over this side. That is plus R1. How much is it? 20. So this becomes 1 by 20. Very good. R2, this is R2, negative side. See, radius is in the negative side. How much is it? 20, but minus 20 because of minus. So minus plus. Clear? Clear? So this becomes half into 2 by 40. Sorry, 2 by 20. 2 by 20. 2 gets cancelled. So this is 1 by F. So F comes out to be 20 centimeter. This is the focal length for this particular case. This particular case. Yes or no? Clear? For this particular case, you have find out it is 20 centimeter. Now you can even calculate power from here. Sir, how to calculate power? Very simple. Very simple. We know power is basically 1 by F. So 1 by F is how much? 1 by 20. But this is in centimeter. I need to convert it into meter. And I need to convert it into meter, right? So divide by 100. So this is 1 divided by 20 divided by 100. So this 100 goes to the upper side. This goes to 100 divided by 20, which is basically 5 diopters. So diopters is basically the SI unit of power. Okay. Power also calculated. Chaliye, next. Next. Oh, this is a plano-convex lens. A plano-convex lens. Plano-convex. Sir, incident ray in this direction, this is negative, this is positive. Find the focal length. So 1 by f is basically mu of lens divided by mu of surrounding minus 1, and this becomes 1 by r1 minus 1 by r2. This is the formula. This is the formula. Sir, mu of lens. What is mu of lens? It is, okay, let's calculate this mu to be 3 by 2. Okay, this is 3 by 2. So this becomes 3 by 2. Mu of surrounding is air, so it is 1 minus 1, and this becomes, okay, now this is r1 and this is r2. Okay, r1, see, this is r1 positive side, it is 20, so this becomes 1 by 20. Very good. Now r2, see, this is plane, radius is infinity, radius is in infinite. Okay, so 1 by r2 becomes 1 by infinity, which is 0, so you don't have to write about it. Very good. So 1 by f is basically half into 1 by 20. So f becomes 40 centimeters. F becomes 40 centimeters. Clear? 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 Everybody, if you are able to understand this, fire in the chats. Fire in the chats if you are able to understand this. If you are able to understand this, fire in the chats. Very good, very good, very good, very good, very good. Next question, next question. Oh, I have changed the medium now. See, I have changed the medium. Let's calculate. What is the formula? Sir, 1 by f is basically equal to mu lens divided by mu surrounding minus 1. And this becomes 1 by r1 minus 1 by r2. This is the formula that we know. Yes, sir, this is the formula. Sir, incident ray over here, this is negative, this is positive. Very good. So this becomes mu of lens. It is 4 by 3. Okay, 4 by 3. Divided by 3 by 2. Okay, 3 by 2. Minus 1. Okay, sir, minus 1. And 1 by r1. Sir, 1 by r1. This is r1 and this is r2. R1, positive side, sir. This is positive side. So, plus 20. So, 1 by 20. Okay, next. R2, sir, negative side, negative side. This is 30. 30, negative side. So, minus 30. So, minus minus becomes plus. Yes or no? Yes or no? Very good. Very good. Let's solve this. Let's solve this. How much is this? This becomes 8 by 9 minus 1. Hai na? This is 8 by 9 minus 1. I'm going to solve it over here. Solve it over here. So 1 by f is 8 by 9 minus 1. And this fellow becomes how much? I'm going to give 3 over here. This becomes 3. I'm going to give 2 over here. This fellow becomes 2. This is 5 by 60. Hai na? 5 divided by 60. This becomes 5 by 60. 1 by f is basically, this is 9 by 9 minus 1 by 9. Minus 1 by 9 into 1 by 12. Hai na? 12 9s are 108. So f is basically minus 108 centimeter. Are you all able to understand this? Are you all able to understand this? Now people, I'll tell you something. See this. I'll tell you something. What does this f mean? F is 20 centimeters, positive 20 centimeters. That means if a ray of light is parallel to the principal axis, it will strike over here. This is f. This is f is equal to 20. Hai na? This is f is equal to 20 in this medium. F is equal to 20. What about this? F is equal to 40. So if a ray of light comes parallel to the principal axis, it will go and strike over here. Okay, converging. What about this, people? See, this is a convex lens. Still we are getting the focal length as minus 108. That means if a ray of light comes over here, it will diverge. It will diverge. And focus is over here. This is 108 centimeter. Are you all able to understand? Are you all able to understand this, people? This is a diverging lens. This, in spite of it being a convex lens, it's a diverging lens. That's what I told you. Convex lens and concave lens, nothing. It has nothing to do with what? Diverging or converging thing. The diverging and converging thing only depends upon the lens, the refractive index of the lens and the refractive index of the surrounding. Concave and convex are just the geometry, just the shape of the lens. Clear? So one more thing that you can write, is if the focal length is positive and if the focal length is negative, If it is positive, it's a converging lens. If it is positive, then you can say basically it's a converging lens. Okay. But if it is negative, you can definitely say it's a diverging lens. You can definitely say it's a diverging lens. Clear? Clear? Very, very important, people. Very, very. Is there problem of volume? Is there any problem of volume, people? Clear? No, I don't think so. I don't think so. It is good from my side. It is good from my side. Okay. Lens formula. Now we're going to talk about lens formula. What is lens formula? Very simple. Lens formula is just 1 by V plus 1 by U. No, sorry. 1 by V minus 1 by U is equal to 1 by F. So do you like this formula? No, I don't like this formula. I use which formula? I use V is equal to oof by oof. This oof. There is a difference. This is plus right over here. Okay, this is plus over here. Make sure this is plus over here. Okay, plus over here, plus over here. है ना? It's not minus. It's plus. In mirror, for mirror it was minus. For lens it is plus. Okay, make sure that you don't do that mistake. What about magnification, sir? Magnification comes out to be positive V by U. Positive V by U or F divided by F plus U. Okay. 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 This is the formula. This is the formula. You all know how to use it. What is the sign convention? Everybody knows how to use it. Everybody knows how to use it. So chalo, let us solve some questions, people. Let us solve some questions. This is the question. What is the question? Find the position and the height of the image. Basically, you have to tell everything. Let us solve. Chalo, let us solve. Hello, Akshita. How are you? Hai na? Sir, incident ray in this direction, sir. So this is negative, sir. Acha, haan, I have not told you this. No, I have not told you this. I have not told you this. Hai na? See this. If you get a symbol something like this. If you get symbol something like this, this is basically a converging lens. Okay, this is basically a converging lens. This is a symbol of converging lens. Okay, okay. And this symbol is basically a diverging lens. Or even if this is not given, you should be able to identify with the help of focal length. With the help of focal length. How? See, F is equal to plus 10 centimeter. That means this is a converging lens. This is a converging lens. Are you all able to understand? Okay. So this is over here. This is minus. This is plus. This is minus. This is plus. Okay. Okay, let's solve. So first of all, V is equal to oof by oof. Oof by oof. Hai na? Okay. Sir, what is U? U is minus 50. Okay. Minus 50 into focal length is plus 10. Okay. Plus 10. So here you don't have to look for the sign. Here you don't have to look for the sign because converging lens is plus 10. So you don't have to look, sir, it's plus 10 or here. No. For lens, you don't have to look. If it's given, it's given. This is plus 10, then you have to use plus 10 over here. Okay. Okay, everyone is back. Kya baat hai? 10 and this becomes minus 50 plus 10. So this becomes minus 500 and divided by minus 40. Cutting. And this becomes 25 by 2. 25 by 2 centimeter. So V is formed at 25 by 2 centimeter somewhere over here. No, Akshita. Converging doesn't mean concave. Diverging does not mean convex. Please go back to the lecture. I think you have missed something. Yes, Akshita. Start from lens. Please start from lens. Okay. If you have skipped something, please start from lens. Very, very important. Okay. Converging means concave. No. See, I'm telling you, concave and convex, nothing. It has nothing to do with diverging and converging. Concave and convex are just geometry of the lens, just shape of the lens. A concave lens can be diverging as well as converging. A convex lens can be diverging as well as converging. It depends upon the refractive index of the medium and also the lens. So please start from lens, Akshata. Please start from lens. Okay, please go back and start from lens. Very important. It's a very big conceptual error that you're making. Okay, V is 25 by 2 centimeter. Okay, can we find out the magnification? Yes, we can find out the magnification. Magnification is V by U. What is V? V is 25 by 2. And what is U? U is basically negative 50. And negative 50. So this comes out to be how much? Minus 1 by 4. Yes. Minus 1 by 4. Minus 1 by 4. Okay. Which is basically equal to height of image divided by height of object. So height of image is basically height of negative of height of object divided by 4. So what is height of object? 2 mm. Acha, 2 mm. 2 mm divided by 4 negative. So this becomes minus 1 by 2 mm. So the image that is going to get formed is basically inverted as well as diminished, but obviously it's going to be a real image. Let's see how it is going to get formed. See how it's going to get formed. See, okay? Strikes, है ना? Then it's gonna converge. है ना? It's a converging lens. Till where? 25 by 2 centimeter. So 25 by 2 मतलब क्या हो जाएगा? This is 10 centimeter. No, so this is 10. This is 20 somewhere over here. Okay, it's gonna converge something like this. Yes or no? Yes, sir. It's gonna converge something like this. Now 10 centimeter. This is your secondary focus. So let me say that this is your focus. This is focus. This is 2f. Okay. So parallel and tapak. Okay. This is something like this. Then one more passing through the optical center, and yeah, this is the image that you'll get. This is the image that you'll get. This is the image that you'll get. Clear? Clear, people? Clear, everybody. And what is the size? This is going to be, size is basically going to be half mm. Half mm. Now, people, I'll tell you something. Okay, clear? Clear. Very good. Let's solve. Same thing, everything is same, just this is different, है ना? Let's solve. So V is basically equal to oof by oof. This is positive oof. So this is negative, this is positive because incident ray over here, है ना? U is minus 30. So minus 30 into focus is 10. So this becomes minus 30 plus 10. Okay. So this becomes minus 300 divided by minus 20. Okay. Cutting, this becomes plus 15 centimeter. That is your V. Okay. That is your V. Magnification is basically V by U. So this is 15. U comes out to be minus 30. So this comes out to be minus half. है ना? So what do you mean by minus half? It's inverted as well. It's inverted and also diminished as well. Inverted and diminished. है ना? Inverted and diminished. Directly you can say that height of image is basically negative 1 mm. You can directly basically say from over here. Simple, and obviously it's going to be a real image. Okay, let's go next. Okay, one more thing. Chaliye, let's solve. Over here, what is happening? V is equal to oof divided by oof. What is, this is negative, this is positive, है ना? U minus 20, है ना, into F plus 10 divided by minus 20 plus 10. So this becomes minus 200 divided by minus 10. Cut. This becomes 20. Magnification is again V by U. So V is basically how much? 20. U is minus 20. This becomes minus 1. So the image, height of the image. So this is again inverted image, same size. Height of the image is going to be minus 2 mm. That's it. Clear? Yes, Am I clear? Am I clear? Now you should be very fast with it. You should be very, 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 very fast with it. Very, very fast with it. Yes or no? Okay, this one. This one. V is equal to oof divided by oof. Sir, U. U is how much? This is negative, this is positive 6. So minus 6 into focus, that is 10, divided by minus 6 plus 10. This comes out to be minus 60 divided by 4. Divided by 4. Hai na? So 2 2s are, this is 2 30 15 minus 15. Minus 15 centimeter. So M comes out to be V by U. This is minus 15 divided by U. U is minus 6. Hai na? Minus 6. So this is 3 2s are 3 5s are. Hai na? Yeah, 3 5s are. Yeah, this becomes 5 by 2. 5 by 2 or 2.5. 2.5. So over here, this magnification, the image is going to be erect. It's going to be erect. It's going to be erect. Very important to note over here. It's going to be erect over here. Yes or no? And magnified also. Erect and magnified. Erect and magnified. Very, very important. Very, very important. Yes or no? Yes or no? Now comes the most important part. I've already told you while explaining concave mirror, I've already laid the foundation that this table is same for concave mirror and convex lens. I'll tell you. See this. Visualization. Let's go to visualization. See this. Okay. See this. Just a second, people. Let me just draw everything. This is 120. Focus is 40. Okay. This is 80. No. No. This is still has to be far. Still has to be far. Okay. This is perfect. Over there. Yeah. See this, people. See this. This is focus. This is, see, very, very, very easy to understand. Okay, people. Very, very easy to understand. Very, very easy to understand. Now, what is happening? What is happening? See this. When the object is at infinity, image is formed at the focus. And as I'm coming near, the height of the image is increasing. And once it goes to the focus, image is at infinity. And see. Same thing is happening. I've just inverted this. Like same like concave mirror itself. Just like concave mirror. See this? Just like concave mirror. I have just basically, flipped this book over here. See this? Inverted. Yes, same as concave. And at focus at infinity, and between focus and pole, we get a virtual image. Same as concave. Over here, we get a real image. See, this animation should be inside here. Same thing, I've already told you. I've laid the foundation over here. Yes or no? Cool. Now let us talk about combination of lenses. Combination of lenses. Nothing. Combination of lenses is 1 upon f equivalent is basically equal to 1 upon f1 plus 1 upon f2. This is basically a combination of lens. Don't worry, we will be solving numericals. If they are just touching very close to each other, you can use this formula. But if they are not touching, they are far apart, you can use this formula. That is 1 upon f equivalent is 1 upon f1 plus 1 upon f2 minus d divided by f1 into f2. This is the formula that you can use. Okay. If they are far apart, you can use this formula. If they are close to each other, you can use this formula. Now, make sure that you have to use the correct sign. You have to use the correct sign. If it's a converging lens, F should be in positive. If it's a diverging lens, F should be in negative. Make sure that, hai na? So F should be positive if it's a converging lens, converging, hai na? And F should be negative if it's a diverging lens. Okay. Okay, cool. Make sure you like the session, people. Make sure you like the session. Okay. Now, combination of lens and mirror. Sir, what is this combination of lens and mirror? Basically, this is the combination that I'm talking about. I have a lens over here and I have coated it with a mirror. I have silvered one of the refracting surfaces. So one of the refracting surface has become a mirror right now. So basically, I can say something like this. This is a combination of a lens and as well as a mirror put together. Are yes or no? As well as a mirror put together. So refraction takes place through the first surface, reflection takes place through the mirror, and again refraction happens through the first surface. So all of these three things together, clubbed together, will basically you will get this. But you have to understand, whenever you get these kind of questions in which the combination of lens and mirror, whenever you get combination of lens and mirror, you have to understand the final combination. The final combination acts as a mirror. Final combination acts as mirror. Final combination acts as a mirror. Okay, what is the formula? The formula is 1 upon F equivalent is equal to 1 upon Fm, that is focal length of the mirror, minus 2 divided by focal length of the lens. This is the formula. Don't worry, we will be solving numericals. Don't worry. That is the formula. That is 1 upon F equivalent is equal to 1 upon Fm, that is focal length of the mirror, minus 2 divided by focal length of the lens. That is the formula. Don't worry, we would be solving each and everything. PYQ, 2000 PYQ. What is it? For a plane convex lens, a plano-convex lens, okay, mu is 1.5, radius of curvature is 10 centimeters. It is silvered on its plane surface. Find the focal length after silvering. That means I have a mirror something like this. I have a mirrors of something like this. This is plane mirror. This is plane. This is the plano part. And this is the convex part. I have mirrored this plane surface. Okay. Now, this is the axis which is passing. Now, how to solve this? People? How to solve this? They have already told you the mu over here is 3 by 2. It is 3 by 2. Radius of curvature is 10. So radius over here is 10 centimeters. है ना? And radius over here is infinity. Now this is the incident ray. This is negative. This is positive. So this is R1 and this is R2. Okay. Silver and I find the focal length. Okay, chalo. Let's find out. So 1 upon F equivalent is basically equal to 1 by Fm minus 2 divided by FL. This is your formula. Yes or no? Let's solve. People. Let's solve. What is the focal length of mirror? Sir, mirror focal length would be 0. Would be infinity. Baba, if radius of curvature of a mirror is infinity, radius of curvature is infinity, focal length also will be infinity. So 1 by Fm will be 0. 1 by Fm would be 0, right? What is focal length of mirror? Does focal length of mirror depend upon medium or anything? No, it does not depend upon medium. It only depends upon the radius of curvature. So if radius of curvature is infinity, focal length of the mirror will also be infinity. So this becomes 0. Okay, this is 0. Bye bye, tata. So minus 2. Now 1 by FL. What is 1 by FL, people? Can I write 1 by FL as mu of lens divided by mu of surrounding minus 1, and this becomes 1 upon R1 minus 1 upon R2. Hey? Sir, I think we have seen this formula. This is lens maker formula. Sorry. Yeah, this is the lens maker formula. Yes or no? This is the lens maker formula. I've just, because see, I can't substitute focal length of lens as 5 over here. No, I can't do that because it depends upon the surrounding and the medium. So I have to use this formula. Acha. Okay, let's solve this. Let's solve this. So this becomes, I'll solve it over here. This becomes minus 2. Okay, mu of lens. What is mu of lens? 3 by 2. Mu of surrounding is air. So this will become 3 by 2 minus 1. That is half. Multiplied by 1 upon R1. What is 1 upon R1? It is opening in the positive side. So plus 10. 1 upon R1. 1 upon R2 is 0. 0. Simple. So this comes out to be, F equivalent comes out to be minus 10 centimeter. What do you mean by minus 10 centimeter? What do you mean by minus 10 centimeter? Minus 10 centimeter meaning you can replace this whole setup. You can replace this whole setup with a concave mirror basically. You can basically replace this whole setup with a concave mirror with a focal length of minus 10 centimeters. Minus 10 centimeters. So this is plus, this is negative, this is positive. Khatam. You can basically replace this whole setup with the focal length of minus 10 centimeters and then solve it as a mirror. Simple. Solve it as a mirror. Simple. Understood. Clear. No, it's not diverging. No. Eternal being, it's not a diverging mirror. It's not diverging. It's not a lens. It acts as a mirror. I've already told you. Combination of lens and mirror. The final combination acts as a mirror. So mirror is not diverging and converging. No, it is always, obviously, it is concave or convex. So this is acting as a concave mirror. Clear? Clear, eternal being? Okay. Cutting of lens. Very, very important. Very, very important. Cutting of lens. Okay. If this lens has a focal length of f, if I cut it along this axis, these are the two lenses that I'll get. This also still would have focal length of f. No change. No change. Okay. But if I cut it along this axis, I would get these two lenses. If this is f, this will also be 2f, this will be 2f. The focal length would get doubled. Okay. Yeah, you should not forget the silvered part. Ultimately, it is acting as a mirror, no? So 2f and 2f. This is something that you can keep in your mind. Sir, how did you derive this? You can derive this using the lens maker formula. So R1, this is R, and this is infinity. This is infinity, this is R. You can basically solve it using the lens maker formula. But you have to keep this in your mind, okay? You have to keep this in your mind. Question, I guess. Yeah, question. What is it? Good morning. An equiconvex lens is cut into two halves, XO X dash and YO Y dash, as shown in the figure. Let F dash F double dash be the focal length of the complete lens, and each half in case 1 and 2 respectively. Choose the correct statement from the following. Only optical instruments and only optical instrument is remaining. Okay. Only optical instrument is remaining and combination of lens, that's it. Okay. So complete lens has a focal length of f. If I cut it along XOX direction, no change in focal length. I've already told you that. So f dash is still equal to f. But if you cut it along this, the focal length gets doubled. So f dash becomes 2f. This is your answer. Oh, A. I don't know, mostly under an hour, in an hour or so, hai na? Now, if the lens is made up of many different refractive indexes, the number of images, formed is equal to number of refractive indexes or number of different type of refractive indexes. Clear? That means over here the lens is made up of how many different types of refractive indexes? 1, 2, that's it. So because see, 1 and 2, these are same, no? These are all same. This is mu1, mu2, mu1. How many different refractive indexes are there? So only 2. So what will be the number of images formed in this case? Number of images will be formed is 2. 2 images will be formed. 2 images. Clear? Okay. And same case with lens also. If the mirror is cut, the intensity will be reduced of the image, but the image will still be there. Same with the case of lens. Even if you cover one half of the lens, the image will be there, only the intensity would be decreased. Same thing. See, I've already told you, mirror is very important to understand lens. So once foundation is set, everything is clear. Okay. Question, recent question from 2023. A lens is made up of 3 different transparent medium. See, first 2, 3. As shown in the figure, a point object O is placed on its axis beyond 2f. How many real images will be obtained on the other side? Obviously, the answer would be 3, because 3 different refractive indexes are there, so the number of images will be 3. Clear? Question for you all. Question for you all. Question for you all. Okay, this is question, very very important question, people. Now, as you can see, the lenses are touching each other, है ना? The lenses are touching each other. Okay. Now, what you have to understand is that you always have to assume that there is some space, very little minute space between these two lenses. Very minute little space between these two lenses. And that space is covered with the refractive index of the surrounding. Basically, you can assume it to be something like this. This is your first lens and this is your second lens. So this is also surrounding, this is surrounding, this is surrounding, this is lens 1 and this is lens 2. You can assume it to be something like this. Okay, clear? Let's solve. Find F equivalent. How to solve it? So we know F equivalent will be 1 upon F equivalent is basically 1 upon F1. Okay, I'll solve it from here. Hai na? 1 upon F equivalent will be 1 upon F1 plus 1 upon F2. Hai na? Yes, sir. Sir, what about F1, sir? Let us calculate the focal length of this. Let us calculate the focal length of this. Let us calculate. Hai na? Chaliye, let us calculate. Sir, what is 1 upon F1? Can I write 1 upon F1 as? What is mu of lens? I'm going to write mu of lens. I'm going to use this formula. Which formula, sir? 1 upon F is equal to mu of lens divided by mu of surrounding minus 1 multiplied by 1 upon R1 minus 1 upon R2. Yes or no? This is the formula that I'm going to use. So 1 upon F1 becomes mu of lens. What is mu of lens? 3 by 2. 3 by 2. What is mu of surrounding? Surrounding is again air. So it is minus 1. It is 1. So minus 1 divided by multiplied by 1 upon R1. Sir, this is incident ray in this direction. This is minus. This is plus. Sir, this is R1. This becomes R1. This becomes R2. R1 positive direction. So 20 plus 20 minus R2. R2 negative direction. R2 negative direction. So minus minus becomes plus 1 by 20. Clear? Clear, 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 clear. Okay. Next, plus. For this lens right now, for this lens, the sign is still the same. The sign is still the same. But this is R1 right now and this is R2 right now. This is R1 and this is R2. So, this becomes mu of lens, that is 4 by 3 minus 1, because mu of surrounding is air. Hai na? Multiplied by 1 upon R1. Sir, R1 negative direction. R1 negative direction. How much is it? How much is it? 20 itself. So, minus 1 by 20. Minus, sir, this R2 positive direction, 1 by 20. Clear? Clear or not? So this becomes, what happened? This becomes half into 2 by 20 plus, this is how much? 3 by 3, 1 by 3, hai na? 1 by 3. Multiplied by minus 2 divided by 20. Minus 2 divided by 20. Yes or no? Yes, sir. Khatam, khatam, cut, cut, finish. Hai na? And this becomes how much? This is 1 by 20. This is 1 by 20 minus 2 by 60. Hai na? Minus 2 by 60. I give 3 over here and this becomes 3. So this becomes 1 by 60. 1 by 60. So 1 upon F equivalent. Hai na? So what I get is F equivalent is equal to 60 centimeters. Now what does plus 60 mean? Plus 60 mean, it means this is a converging lens. It's a converging lens. So basically you can substitute this or replace this with the help of a converging lens. You can converge. You can basically, yeah, Substitute this or replace this with a converging lens which has a focal length of 60 centimeters. Yes or no? Yes or no? Clear, 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 clear. Yes or no? Clear, clear. Okay. Chaliye. One more question. One more question. One more question. One more question. Okay. One more question. है ना? Find F equivalent, position, height, everything. Okay. We have to find everything out. है ना? We have to find everything out. ठीक है. So basically, you can assume this thing to be something like this. This is your first lens. Some space is there. This is your second lens. Some space is there. This is your third lens. है ना? This is surrounding, 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 surrounding. Lens 1, lens 2, lens 3. Something like this. Okay. Perfect. Very good. Perfect. Very good. Okay. Let's move on. So, sir, 1 upon F equivalent is 1 upon F1 plus 1 upon F2 plus 1 upon F3. Same thing you have to do, people. This formula you have to apply. है ना? Okay, chalo. Mu of lens, that is 3 by 2. Surrounding is 1. है ना? Surrounding is air itself. So, this is 3 by 2 minus 1 multiplied by 1 upon R1. Okay. Incident ray, something like this. This is negative. This is positive. है ना? R1, this is R1, positive direction, 20, 1 by 20, minus, acha, then this is R2, negative direction, so minus, minus, plus, so this becomes 1 by 20, khatam. This is for F1 upon F1. Then 1 by F2 can be written as mu of lens, that is 2 minus 1, 2 minus 1, and then this is R1 for you all. This is R1, negative direction, minus 1 by 20. Minus 1 by 20. R2, this is R2, that is 30. Remember, this is 30. Positive direction. So, this becomes minus 1 by 30. Because formula is 1 upon R1 minus 1 upon R2. Hai na? Yeah, I am writing, Akshita. This is just for F1. This is for F2. I will be writing for F3 as well. Okay. Next. For F3. 4 by 3. 4 by 3 minus 1. Multiplied by 1 upon R1. This is R1. This is R1. Positive direction. So, this becomes 1 by 30. R2. Negative direction. So, minus, minus, plus 1 by 30. Clear? Is the equation clear? Hai na? Is the equation clear? This is half. This is half. This is 2 by 20. So, that will be 1 by, no. Half and 2 by 20. No. So that will be 1 by 20. This is 1 by 20. This is okay. This is okay. Cutting. Okay, 4 by 3. That is 3 by 3. 1 by 3. 1 by 3. 2 by 30. So this becomes cancel. 3 cancel. Okay. I think the F equivalent that you should get over here is minus 90 centimeters. Yes, that is exactly what you're getting. Minus 90. Can you just confirm if this is the correct one? Yeah. Fe is equal to minus 90 centimeter. That means this should be a diverging lens. This should be a diverging lens. It's a diverging lens that we are talking about over here. You can replace this whole setup by something like this. This is the diverging lens, but with focal length of 90 centimeter, minus 90 centimeter. Now we need to find out the position, the image, and everything. Everything we have to find out. Hai na? So simple. This is very simple. Very simple. So see, we need to find the position. So V is equal to oof by oof. Hai na? Oof by oof. So this is negative, that is positive. Hai na? Negative, this is positive. What is the distance? 40 centimeters. So negative 40 minus 40. What is the focal length? Minus 90 divided by minus 40 minus 90. This is basically your answer. This is 3600 divided by minus 13. No? Yeah, minus 13. Minus 130. Cutting. Yeah, this is the answer that you're getting. 360 divided by minus 30. Very good. This is basically your V. And magnification also you can find out V divided by U. V is basically 360 divided by 13 or minus multiplied by u. What is u, bhai? What is u? U is minus 40, है ना? U is minus 40. This is basically your magnification as well. Okay, clear? Clear, 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 clear. Now you can basically find it out. Now you can basically find it out. Now you can basically find it out. Okay. Now, question. A convex lens and a concave lens, each having same focal length of 25 centimeter, are put in contact to form a combination of lens. The power in diopters of the combination is, see, they've already given the focal length, so no need to worry. So F equivalent is 1 upon F1 plus 1 upon F2. Now, convex lens and a concave lens, each having same focal length of 25 centimeter. Now, convex lens, so that means positive focal length. So this is 1 upon 25. And concave lens, negative focal length, minus 1 by 25. This is basically 0. So 1 by F equivalent is 0. So what is power? What is power? No. Sorry. Same focal length. Power comes out to be 0. Power comes out to be 0. Same simple. See, now you will say, no sir, you told concave lens and convex lens, their geometry, nothing to do with converging, diverging. Arey haan. But if they have not given any medium, we can assume it to be air, and in air, convex and concave lens, they behave as converging and diverging respectively. Simple. Not 0 is equal to infinity. 0. Arey baba, 1 upon F is equal to power, no? 1 upon F is equal to power. So P is also equal to 0. Okay? Clear? Yeah, this is one question that you can try. 2015 question, very easy. This question and this question exact same. This is exact same question, and not exact same. The values are different, yeah, but exact same calculation, है ना? Exact same calculation. Now, people, we are gonna start with optical instruments. We are gonna start with optical instruments. Okay. Last. No, F is not equal to infinity, buddy. Yeah. F is equal to infinity. Yes. F is equal to infinity. Yes. F is equal to infinity. Okay, yeah. 1 upon F is 0. Yes. Optical instruments, people. Yes. है ना? Just 20-25 minutes more and then we're done. है ना? And yeah, also, no, not 5 minutes break. Thima, let's just finish it, no? Let's just finish it. What say? You want 5 minutes break? You want 5 minutes break? Do you want 5 minutes break? Yeah? Okay, just tell me. Depending upon the comment section, we will do something. If you want 5 minutes break, you can tell me in the comment section. And if you do not want 5 minutes break, we can continue. Tell me. And one more thing. After completing optical instruments as well, if you want to do more question practice, we can do it. Okay, we can do it. I don't mind. Yeah, I don't mind doing question practice. Tell me. Okay, we'll do something like that. We'll do something like this. I also want to go to the washroom. है ना? I'll just go to the washroom fast. Till then, we can take a break. है ना? Just a washroom break. Just for me. है ना? Just for me, a washroom break so that I can just freshen up myself. It will just take 2 or 3 minutes. Maximum 2 or 3 minutes. Then we'll come back. Okay, people? Just 2 or 3 minutes washroom break. Okay? Washroom break. That's it. Washroom break. That's it. Okay? Max to max. Okay? Just washroom break. I'll just come and then we'll finish it. Just a washroom break. I'll just freshen up myself and come. Okay, just a washroom break. Okay. Yeah, I'm back. Yeah, let's finish it. Okay, let's finish it. Optical instruments, very easy, people. Very, very easy. Formula oriented, people. Okay, it's just formula oriented. Are you all ready? Are you all ready? Back? Very good. See, just formula oriented, people. Optical instruments. Okay. Now, before we start optical instruments, we need to have some basic knowledge or basic foundation before we start with optical instruments. Now, first is least distance of distinct vision, or LDDV. Okay, what is that? Okay, what is that? See this. The minimum distance required to see the objects distinctly without strain is called as distance of distinct vision. It is also called the near point of the eye. It is 25 centimeter for normal human eye. That means if you notice, people, see, this is something, है ना? This is something, है ना? So okay, I'm able to see it very clearly right now. I'm able to see very clearly. I'm able to see very clearly. Now it is blurred. It is blurred, and my eyes are also paining. My eyes are also paining. It's very strained right now. I'm not able to see it clearly. I have to use a lot of pressure. I have to use a lot of muscle over here to to see it clearly. So this distance, this minimum distance, by which I can see things clearly without straining my eyes, is called as the least distance of distinct vision. Are you all able to understand this? So see, right now I'm able to see. Right now I'm able to see. 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 Now the eyes are strained. If I go more near, it will be blur, and it will strain my eyes very much. So this is basically the least distance of distinct vision. Clear? Yes or no? Okay. And for normal human eye, it is around 25 centimeters. And it is average for a normal human eye. And most people, their average somewhere falls around this same value only. And but many people, their least distance of distant vision may be 27, 28. Sometimes. So, but yeah, average it is 25 centimeters. Okay, very clear. Now, now, now we have to understand this, very much important. What is visual angle? What is visual angle? I've written a very simple line over here. What is that simple line? How big something appears will depend on how big it actually is and how far or close it is. Like, obviously. See this. I have a chotu pen over here. I have a chotu pen. See this. Now this is close to you. This is close to you, and this bottle is far from you. Are you able to see? Now you are able to see as if the height of the pen is much more than the height of the bottle. But in reality, this is the reality. This is the reality. But if it's closer to you, your eyes perceive as the pen is much more larger and the bottle is very small. But in reality, this is the scene. Are you all able to understand this? Super clear, super clear. See this? See this? Okay. See, pen is very, if the pen is very near to your eye, you're able to perceive as if the pen is very large. So it's all about visual angle. Yes, it is all about visual angle, people. It is all about visual angle. So what is this visual angle? So see this, people. See this, people. If this is the object, okay, this is the object, this is the eye, okay, this is the eye. If I basically push this object towards you, if the distance between the eye and the object keeps on decreasing, obviously the value of theta will increase. Obviously the value of theta will increase. Are you all able to understand this? Are you all able to understand this? The value of theta is increasing over here, and more the theta, more the object size will be larger. So more the image size will be larger for you. Yes or no? See this, like this. See, right now it's very small for you. Right now it's very small. But as soon as the distance is decreasing, the theta is increasing. The theta is increasing. That means the magnification is increasing for you, or the size is increasing for you. And theta over here is basically height of the object divided by the distance of the object from the eye. So theta is basically h divided by x. H divided by x. Now, why do we use, now, this is theta is basically h by x, that is basically your visual angle. Now, can I basically say theta and x are inversely proportional to each other? Yes, they are inversely proportional. That means if I want to maximize this theta, x should be minimum. And what is x minimum, people? What is x minimum? Sir, I think it is least distance of distinct vision. Yes. So x has to be replaced with capital D. That is the maximum value of your visual angle. Are you all able to understand this? Because if the distance goes, see, even if the distance is less than capital D, you are still able to see, but it's very strained and very blurry. So that is the reason the minimum distance that we use is capital D over here. And this is the maximum visual angle that we are getting over here. Clear? Now, why do we use optical instruments? Why do we use optical instruments? We use optical instruments to increase that theta m. Not to increase theta. That is so theek hai, we have already increased naturally. Hai na? By keeping x is equal to capital D. Why do we use optical instruments? We use optical instruments to increase the maximum visual angle or to decrease the capital D even further. Theek hai? Are you all able to understand? Why do we use optical instruments? To increase this fellow or to decrease this fellow. Simple. Clear? First optical instrument, the simple microscope. Simple microscope, also called as the magnifier. Magnifying glass, hai na? Magnifying glass, hai na? Same thing. What is happening? See this. Very, very important, people. Very, very important. See this. Oops. Okay. See this. The lens that you have to use is convex lens over here, and make sure this convex lens that you're using has a very small focal length. That is one of the requirements over here. Okay. Now there are two adjustments over here. One is normal adjustment, and the second adjustment is called as the maximum magnification. Okay. Now let us understand what exactly is this. What is normal adjustment? Now in normal adjustment, the eyes are completely relaxed. It is least strained. Now what is happening over here? Let me explain it to you. People, this is a convex lens. Okay, sir, it is a convex lens. Sir, very, very easy. It is very, very easy to understand, people. See this. Now, this is the object with height h. Hai na? This is the object with height h. I have kept it to the focus. Of convex lens. Sir, if an object is at focus of the convex lens, the image will be at infinity. Hai na? The image should be at infinity. That is what exactly we are getting over here. A virtual image. We are getting a virtual image over here. A virtual image which is large and magnified. Sir, can I decrease this f? Yes, you can increase this f. Array, see this, people. See this. See, this is a convex lens. See, if you see this. This is exactly what we are doing. Over there. If I decrease this more, obviously the theta is going to increase. If the theta is going to increase, the magnification power is going to increase. So what is theta? What is theta without, that is, yeah, what is theta without the use of optical instruments? What is the visual angle? It is h by capital F. Sorry, h by focal length. After the use, can I basically say it is h by d? Yes or no? So the magnification comes out to be capital D upon small f. Clear? Yes or no? Okay. Pakka? So the magnification of simple microscope is capital D by F, where F is the focal length of the lens over here and capital D is the LDDV, least distance of distinct vision. Good. Now we are going to use this for maximum magnification. How to achieve maximum magnification? In maximum magnification, eyes are least relaxed and most strained. Now, in normal adjustment, we keep the object at focus. We bring this object more closer. Image moves more closer and till it reaches capital D. Beyond this, it won't be visible. See what we are doing over here. See this. This is very easy to understand. In simple microscope, the object was kept over here. Okay, the object was kept over here. Okay, and the image we were getting over here. No problem. This is simple magnification. But we know that we can stretch our limits to capital D. That this value can be capital D. This value can be capital D. So we keep this object more closer till we attain capital D over here. So we bring the object more closer, lesser than the focal length, till we attain capital D over here. Are you all able to understand this? So see this, theta. Without the optical instrument, we are getting h by x. After using optical instrument, we will get h dash by d. Are you all able to understand this? So the magnification comes out to be d by x. Sir, can we find out the value of x over here? Yes, you can find out the value of x over here. You already know v is equal to oof by oof. You already know it is oof by oof. Hai na? So it's very simple. Value of v becomes minus d, u becomes minus x, and minus x, f is f, and everything still remains the same. You can basically calculate the value of x over here. Substitute, and you will get the value of magnification as 1 plus d by f. Above all, what you have to understand is that in simple microscope, the magnification value is m is equal to capital D by f. That's it for simple microscope. For simple microscope, normal adjustment. For maximum magnification, you just have to add 1 to it. That's it. So simple microscope, normal adjustment is capital D by f. For maximum magnification, it is 1 plus d by f. That's it. Okay. Very good. Compound microscope. Combination of two convex lenses, small focal length. Okay. Two convex lenses are used over here. This is called as the objective. This is called as the eyepiece. What is the use of the objective? The use of the objective, what does it do? Simple. It is very simple to understand. This is basically the object. It magnifies the object to certain limit. Okay. Then this eyepiece is close to your eye. This real image acts as a real object for this. Acts as an object for this. Okay, and then this eyepiece magnifies it again. Are you all able to understand this? So this is the object, this is the objective lens over here, this is the object. This objective lens magnifies it up to a certain limit. Then this eyepiece is used to again maximize or magnify this again. So two magnifications are happening over here. Are you all able to understand this? Now, two formulas I am giving you. Just remember those two formulas and you will be able to solve the combined microscope. Okay, see this. Minimum magnifying power. Minus L. What is minus L? I'll tell you. Minus L divided by FO multiplied by D by FE. Sir, what is this D by FE, sir? What is this D by FE? Arey Baba, this D by FE is basically the simple microscope. That is the reason this is minimum magnifying power. See this? For simple microscope, for normal adjustment, it was D by F. For maximum, it was 1 plus D by F. Over here, you have to understand, people, this eyepiece acts as a simple microscope. Eyepiece acts as a simple microscope. Are you able to understand this? Are you able to understand this? So if you need minimum, you are just multiplying it by d by fe. If you need maximum, you are multiplying it by 1 plus d by fe. Did you understood it? Did you understood it? Rest, this remains the same, minus L divided by F naught minus L divided by F naught. This remains the same. Sir, what is this minus L or L? L is called as the tube length. L is basically called as tube length. Sir, what is this tube length? Tube length is basically the difference or the distance between F1, F naught, FO and FE. This is tube length. Difference between FO and FE. That is tube length for you all. So you can basically calculate it from the diagram itself. FO and FE. This is tube length for you all. So for minimum, minus L by F naught into D by FE, because for simple normal adjustment. But for maximizing, you have to just basically 1 plus D by FE. That's it. Clear? 100%. Very good. Last but not the least, telescope, people. For telescope, very easy, people. Magnification is F naught by Fe. That is it. That's it, people. This is the formula given here in NCERT as well. F naught by Fe. That is focal length of objective divided by focal length of eyepiece. 4 phi. 4 phi. 4 divided by phi. That's it. For what is this? For telescope. So for telescope, it is coming from space. So we can basically assume it to be coming from infinity. Parallel rays are coming over here. Yes or no? Parallel rays are coming over here. Yes, this is FO. This is FO. So the image will be formed over here. This acts as an object for this eyepiece. है ना? For eyepiece. This is at the focal length of this eyepiece as well. So the image will be formed at infinity. Yes or no? Clear? Very easy to understand. So magnification is 4 phi. 4 phi. Clear? Okay. Now people, it is over. It is over. है ना? The one shot is over. But if you want, we can solve numericals problems, because I have a little bit of problems remaining as well. If you want, we can solve it. Depends upon you all. Do you want to solve or do you want to end it? Do you want to solve or do you want to end it? Do you want to solve or do you want to end it? Tell me. Tell me. You want to solve? Do you want to solve? Or okay, you want to solve. Okay, chalega. See, there are two methods of doing this. Either we solve it right now or you will solve it as a homework. Okay, chalo, let's do it. Okay, let's solve. Chalo, hai na? Everybody is saying let's solve. Okay, chalo, let's solve. Okay, chaliye. Let's see which all problems are remaining. Hai na? Which all problems are remaining, and depending upon that we will solve. Okay. Yeah, I think we have solved all of this. We have solved all of this. We have solved all of this. Yeah. Yeah, solved everything. This is done. Okay, chalo, let's solve this. 2006. Okay, right now let's solve this. A microscope is focused on a mark on a piece of paper, and then a slab of glass of thickness 3 cm, refractive index 1.5 is placed over the mark. How should the microscope be moved to get the mark in focus again? What exactly is happening? Let me tell you. Hai na? This is a piece of paper. This is a piece of paper, and something is written on it. Something is written on it. Chalo. Something is written on it. This is something which is written on it. This green dot is something which is written on this piece of paper. So which MCQs is better? Akshita, see, I'll tell you. Please follow just one book. If you're following MTG or MTG, please follow MTG. If you're following DC Pandey, please follow DC Pandey. Do not buy both the books. Now, the problem with both the books is, if you solve MTG and DC Pandey, you can solve all the easy and moderate questions. But if something like NEET 25 comes into play again, then the questions are not available in DC Pandey and MTG fingertips. Okay, so for harder questions, you'll have to solve JEE Main, PYQs and everything. That is what I would suggest. Okay. Okay, a microscope is focused on the mark on a piece of paper, and then a slab of glass of thickness 3 centimeter and refractive index is placed over the mark. Okay, so a slab is now placed over it. A slab is now placed over it. Okay, with a thickness of 3 centimeters. 3 centimeter is the thickness of the slab. Thickness of the slab. Okay. So what will happen to this dot? I'll tell you what will happen to this dot. See this. So this will go undeflected. Oh yes, sir. So this is denser to rarer medium, sir. Denser to rarer medium, away from normal. Away from normal. Something like this. Yes or no? Something like this. Yes. So I'm going to extrapolate it. I'm going to extrapolate it. Zzz, something like this. So the image will be formed over here. The image will be formed over here. So obviously earlier without the slab, the microscope was focused on this. Now it has shifted. So obviously you have to shift the microscope also. You have to shift the microscope also. By how much you have to shift? Simple. It is basically d dash is basically d divided by mu. What is d? D is 3 centimeters, sir. Okay. Mu relative, na? What is mu relative? From where to where? From where to where? It is going from where to where? From glass slab to the air. What is glass slab for you all? 1.5. So this is 3 by 2. 3 by 2 divided by 1 or 3 by 2 over here. So this becomes, this is how much is it? 6 by 3. Is it to 2 centimeters, people? Is it 2 centimeters? Yeah, it is 2 centimeters. This becomes 2 centimeter. 2 centimeter. Okay. Now see this. This is D. This is D for you. This is dash. D dash. So what is the shift over here? X. Can I see this D minus D dash? X is basically D minus D dash. So this is 3 and this is 2. So you have to shift the microscope by 1 centimeter. 1 centimeter upward. Clear? Clear, people? Everybody? And don't worry, I have I have stamina of solving and teaching you many more things. Don't worry, we can solve a lot of questions if you want. So this is the one thing that we know, 1 centimeter. Okay, more questions. You want more questions? Chaliye. Okay, I hope so you are able to understand. I hope so you all understood the previous question. Light travels a distance x in time t1 in air and 10x in time t2 in another denser medium. What is the critical angle for this? What is the critical angle for this? Okay. Okay, light travels a distance x in time t1. Okay. Chalo, let's use distance by speed. So that is, speed is equal to, we all know, speed is basically equal to distance by time. This is the relation that I'm going to use. So speed is basically light travels a distance x in time t1. Okay. In air. Acha, in air. Okay. So in air the speed is c, distance is basically x and time is t1. This is the first relation that I'm writing. Then 10x distance in time t2 in another denser medium. Acha. So the speed in that denser medium would be v, which is basically equal to distance is 10x and time is t2. Time is t2, hai na? In another denser medium. What is the critical angle for this? Acha, what is the critical angle for this? This is what we have to calculate. Okay, this is what we have to calculate. Okay, ठीक है. So what is a critical angle? It is basically sine of IC is basically mu r divided by mu denser. This is what we have to calculate. है ना? Okay. Now can I write mu r? Now mu r is basically air over here and mu denser is the denser medium over here, hai na? So this becomes sine of IC mu of rarer medium. Mu of rarer medium, that is basically how much? That is how to write this? This is mu of rarer medium, that becomes 1 over here, right? Because it is air. So this is air over here. And mu of denser medium, can I write this as C divided by mu d? Can I write this as C divided by mu d? Yes, I can write this as C divided by mu d. Or mu d can be written as, what can be mu d written as? Mu d can be written as C divided by 10x. C divided by 10x into t2. Yes, mu d I can write something like this. Yes or no? Yes or no? So just substitute over here. This becomes C into T2 and this becomes 10 into X. Okay. So sine of IC is basically 10X divided by CT2. CT2. Huh? What is the value of X? Value of X can be substituted as C into T1. C into T1. So this becomes C into T1. So C gets cancelled. So what I get over here is sine of IC is basically 10 times of T1 divided by T2. So IC is basically sine inverse of 10 T1 divided by T2. 10 T1 divided by T2. Option A. Clear? Everybody, is this clear? Chaliye, next, moving on. Find the value of angle of emergence from the prism. Refractive index of the glass is √3. Okay. See, over here, this is incident at 90 degrees. So it will pass again undeflected. It will pass undeflected over here. Yes or no? Yes. Now, this is the normal. Are chichi. This is the normal. This is the normal over here. Okay. This is the normal over here. Hai na? If this is 60 over here, this is also 60 degree. This is also 60 degree over here because parallel corresponding angles. This is 90. If this is 90, this is 30 degree. This is 30 degree in this triangle. Yes or no? Okay. Now this is denser to rarer, away from normal. It will be something like this. This is the angle of emergence. This is the angle of emergence. Refractive index is √3 over here. Okay. So just apply Snell's law over here. Snell's law over here. Snell's law. Snell's law would be how much? √3 into sine 30. √3 into sine 30 is basically equal to 1 into sine E. 1 into sine E. So this is √3 by 2. √3 by 2 is basically equal to sine E. So E becomes 60 degree over here. E becomes 60 degree over here. ठीक है. Do you want more problems? Do you want more problems? Do you want more problems? Tell me fast. Do you want more problems? Tell me fast. Do you want more problems? Sure, we can. Chalo, let's solve. Now, if you all want to study, then who am I to stop you? Hai na? If you all want to study, whom I have to stop you? Okay, chalo. A small coin is resting on the bottom of a beaker filled with liquid. A ray of light from the coin travels up to the surface of the liquid and moves along its surface. How fast is the light traveling in this liquid? So this is 4, this is 3. So I can definitely say that this is 5. This distance is 5, hai na? Obviously, because right angle triangle, hai na? And light is traveling in this direction. If you all notice, just a second. Light is traveling in this direction and then going over here. Arey chichi. Arey. Light is traveling in this direction, hai na? So basically this is critical angle. If this is the normal, arey yaar, what is happening? If this is the normal, so I can definitely say that this is IC, and this is 90 degree. This is IC and this is 90 degree. No. Arey, no, don't worry about me. Hai na? So see, if this is 4, this is 3, this is 5. This is 5, hai na? This is 5. Can I basically say that this is 37 degrees? Because right angle triangle. If this is 37, this is also 37. Simple. So IC value is 37 over here. So can I basically say sine of IC is basically mu R divided by mu denser. So sine of IC, what is IC? 37. Sine IC is basically equal to mu rarer divided by mu denser. Now I think this is air, hai na? This is air, so mu rarer becomes 1. So this becomes 1 divided by mu d. What is sine 37? Sine 37 is 3 by 5. So 3 by 5 is basically equal to 1 divided by mu d. So mu d becomes 5 by 3. Mu d becomes 5 by 3. And 5 by 3. But they need how fast is the light traveling in the liquid. So it is very easy. So it will be V is equal to C divided by mu. V is equal to C divided by mu. C becomes C becomes 3 into 10 की power 8 and mu becomes how much? 5 by 3. So this is 5 and this is 3. So this is 9 by 5. 9 by 5 or 1.8 into 10 की power 8 meter per second. Option D. Next. Very good question. This is a very good question. This is a very good question. What is this? For the given incident ray as shown in the figure, the condition of total internal reflection of this ray and the minimum refractive index of the prism should be. Acha. So basically they are telling, so total internal reflection should take place over here. Should takes place over here. So what should be the minimum refractive index of this prism that we are talking about? Hai na? Let us solve. See this. 45-degree incidence. This is air, no? This is air, and this is mu, some mu, hai na? 45-degree. This is mu. This is some angle r. This is some angle r, hai na? This is the normal. I'm basically extrapolating the normal over here. Extrapolating the normal over here. Okay, very good. And also this is the normal over here. This is the normal over here. This is r. Okay. This is 90-degree. So can I basically say that this is 90 minus r? Yes or no? Yes, sir, this is 90 minus r. That is definitely that we can say that. We can definitely say that. Hai na? Okay. So I'm going to apply Snell's law over here. I'm going to apply Snell's law over here. So this becomes 1 into sine 45. That is 1 into sine 45. 1 into sine 45 is equal to mu into sine of r. Mu into sine of r. So this becomes 1 by root 2 is equal to mu into sine r. Hai na? Mu into sine r. So sine r I can write. Sine r I can write 1 by root 2 into mu. 1 by root 2 into mu. Yes or no? I'm live, right? I'm live, right? Or has everybody slept? Huh? Chalo. Okay, so sine r is equal to 1 by root 2 u. Hai na? Okay, this is the first equation. Now they have told us what should be the minimum value of the refractive index so that it can do total internal reflection. So it can do total internal reflection. So this is very easy, people. So see, what should be the minimum condition? So the minimum condition is that ray would come over here, it would strike over here and it would start grazing. This is the minimum condition, that the angle of refraction should be 90 degrees. That is basically the minimum condition. That is the minimum condition. So can I basically say that sine of 90 minus r, that is sine of 90 minus r, which is basically sine of IC, hai na, is equal to mu rarer divided by mu denser, or mu denser, that is mu of prism in this case. Mu of denser is 1 because air. Mu of rarer is 1, that is air. Hai na? Sine 90 minus r is cos r. So cos r is basically 1 divided by mu of prism. Now people, I have sine r, I have cos r. I have to find mu over here. Square both of these equations and add them. So what will do? So what will happen? If you square it, so we'll get sine square r plus cos square r. That is equal to 1, which is basically equal to the square of this. That is 1 by 2 u square, and the square of that thing, 1 by u square. This is 2. This is also 2. So this becomes 1 is basically equal to 3 divided by 2u square. So this becomes 2 by 3. Okay, this becomes how much? 2 by 3, and then 3 by 2. Okay, this becomes mu is square root of 3 by 2. Yeah, option C. Option C. Okay, clear. Yes. One last question, okay? One last question. One last question for you all, hai na? Then tata, bye-bye. Lens is there, converging lens, f is equal to 10 centimeters. Find the position and height of the image. Okay? Chalo. So V is basically oof by oof. Oof by oof. So negative, positive, hai na? Incident ray like this, hai na? So U is basically minus 15 into 10 divided by minus 15 plus 10. This becomes minus 150 divided by minus 5, hai na? So this becomes how much? 30. 30 centimeter. So magnification is V by U. So 30 divided by minus 15. So this becomes minus 2. So the image, है ना? Image would be how much? So image would be magnified but inverted. Magnified but inverted. That is exactly what we will be getting. है ना? So simple. So this can also be HI divided by HO. And people, thank you so much. Okay. Ray optics completed. Okay. Ray optics, one of your most biggest chapters, completed in 9 hours. Okay. We have completed in 9 hours. है ना? And I already told you that we would be taking 9 hours. है ना? We would be taking 9 hours. I have completed everything. I have not left even a single thing. I have literally completed everything. Literally completed everything. Okay. Now it is your chance. It is your turn to practice more questions, practice more questions, get better, है ना? Get better. I have given my all in this one shot, in this game of NEET Ray Optics. Okay. Please comment down what all chapters you need next from me. And sleep killed, but chapter 2. Class was so fast and crystal clear. Thank you so much, Akshata. Please drop in your comments. How did you like the class? है ना? Please make sure I'll read every one of them, and personally I'll message you. Okay, personally I'll comment through my ID. Okay, and please practice more and more questions. The only way by which you can basically master physics is by practicing more and more numericals. Okay. Don't mug up your formulas. Understand the concept behind formulas as I basically gave you all the visualizations and everything. And also I'll ask the team. Okay, I'll ask the team. So kindly give all of these links also. Okay, to give all of these links in the description or in the pinned comment section. So you can also play with it and understand it much more further. And just a second, people. Yeah. And yeah, no problem. Mostly I would be taking wave optics. Okay. Mostly I would be taking wave optics, because naturally after ray optics you should complete wave optics, है ना? Yeah, today we killed ray optics. Yeah, killed and murdered ray optics. Okay. The real oof class. Okay, very good, thank you. So mostly I would be completing wave optics, है ना? Okay. Harsh Sugamano, on which channel we get your problem practice, where to find your DPPs of ray optics? Okay, so what you can do is, just a second. Yeah, just a second, people. For anyone who can understand a little bit Hindi, I've used very simple Hindi language. You can go check out NEET Alchemy by Unacademy. Again, one of my own channels. I'm doing an all NEET PYQ series over there. This is also one of my own series. So I'm just solving all NEET PYQs from 1988 till 2025. NEET, AIPMT, AIMS, all of the PYQs in just one video. Chapter wise I'm solving. I've already completed ray optics. You can go over there and basically solve all of the equation. Okay. Left no crumbs. Okay, है ना? DPPs, for DPPs and everything, you can text me on Telegram itself. है ना? You can text me on Telegram itself. This is my Telegram ID. Where is my Telegram ID? This is my Telegram ID. You can basically scan it. You can text me. I can send you my DPPs if you want more practice. Okay, so that is for ray optics, people. And I don't think so anything is left. है ना? So what else you have to do? What else you have to do is the next chapter that we're going to complete is wave optics, है ना? Because naturally after ray you have to complete wave. Then after wave you can comment what all chapters you need, है ना? You can comment what all chapters you need. Okay. So you can obviously, है ना? Already done. Okay. Subscribe NEET Alchemy. Yes, very good. So next is simple harmonic motion. So anybody who knows simple harmonic motion can join in. Yeah. So you can comment. Yeah. Please comment down how did you like the session. Please comment down what all chapters you next. Mostly after wave optics, I would be starting off with thermal. Okay. Yeah, obviously I've used simple Hindi, है ना? I've used simple Hindi. I also don't know the complex Hindi words, है ना? I don't know the complex Hindi words myself. So I've used simple Hindi. You can understand the PYQ series. And the second thing is, after wave optics, mostly I'll be starting off with your heat portion. Okay, so basically your thermal properties of matter, your heat expansion, your KTG, thermodynamics. These four chapters we are going to kill and destroy. And yeah, let's see. And you can comment down as well with what all chapters do you need next. Depending upon that, we can change our plan or do anything that we want. Okay, okay. So that is it, people. That is it, people. Please comment on how did you like the session and everything. Please like the video, subscribe to the channel, and we'll surely meet in the next one. Okay, we'll surely meet in the next one. So this is Jonathan signing off from Unacademy NEET English. We'll meet one more time with another session of Game of NEET 3.0. Till then, sayonara. Take care. Love you all. Bye bye. Okay, chalo, bye bye.